Section 14 of Fires and Firefighters by John KENLON. This LibriVox recording is in the public domain. Chapter 13. Theaters and Fire Panics. The problems affecting fire control in places of public amusement are amongst the most intricate, demanding solution by fire departments. For here the human element becomes an important factor in the situation, and though every safeguard scientific ingenuity can devise may be adopted, and though thousands of dollars may be expended in the installation of the most modern and complete equipment of that nature, it lies within the power of one small boy in the gallery who thoughtlessly calls out "Fire!" to transform an assembly of happy pleasure seekers into a shambles. That is to say, unless some scheme of controlling an audience in moments of emergency can be devised, and towards this end many fire protection associations are working. Hence, in treating the subject, it will be convenient first to consider the active measures demanded by municipalities from the managers of theaters for the public safety, then to give an example of an actual theater fire, drawing from it the obvious deductions, and finally to touch on audiences themselves. Broadly speaking, theater safety depends upon the situation and convenience of exits, the use of the fireproof curtain completely separating the stage from the auditorium, the installation of a system of automatic sprinklers in places where much inflammable material is to be found, such as in scenery docks, and minute attention to such details as the provision of fireproof scenery and the caging in of all lights, electric and otherwise. Perhaps it will be simplest to give the regulations suggested for or existing in New York on this subject, which may be accepted as representing the standard requirements. Standpipes 4 inches in diameter must be provided with hose attachments on every floor and gallery, one on each side of the auditorium in every tier, and one on each side of the stage in every tier. In addition, there must be at least one in the property room and one in the carpenter's shop, if the latter be contiguous to the building. All these standpipes must be kept clear from obstruction and be fitted with the regulation couplings of the fire department. They must be kept constantly filled with water by means of an automatic power pump of sufficient capacity to supply all the lines of hose when operated simultaneously. This pump must be ready for immediate use at all times during a performance. A separate and distinct system of automatic sprinklers with fusible plugs, supplied with water from a tank situated on the roof over the stage, and not connected in any manner with the standpipes, must be placed on each side of the proscenium opening, and on the ceiling over the stage, at such intervals as will protect every square foot of stage surface when they are in operation. Wherever practicable, these sprinklers must also be placed in the dressing rooms, under the stage, and in the carpenter's shop, paint rooms, store and property rooms. A sufficient quantity of hose, fitted with regulation couplings and with nozzles and hose spanners, must be kept attached to holders. For immediate use on the stage, there must always be kept in readiness 4 casks full of water and 2 buckets to each cask, all to be painted red. There must also be provided hand pumps or other portable fire extinguishing apparatus, and at least 4 axes and 6 hooks of different lengths on each floor of the stage. Every portion of the building devoted to the accommodation of the public, as well as all outlets leading to the streets, must be well and properly lighted during the performance, and the lights must not be extinguished until the entire audience has left the premises. The illumination of all parts of the building used by the audience, with the exception of the auditorium, must be controlled from the lobby by a separate shut-off. Gas and electric mains supplying the theater must have independent connections for the auditorium and the stage, and provision must be made for shutting off the gas from outside the building. All suspended or bracket lights surrounded by glass in any portion of the theater used by the public must be provided with wire netting protection. No gas or electric lights must be inserted in the walls, woodwork, ceilings, or in any part of the building unless protected by fireproof materials. The footlights, when not electric, in addition to the wire network, must be protected with a strong wire guard and chain placed not less than 2 feet distant, and the trough containing the footlights must be composed of and surrounded by fireproof material. All border lights must be subject to the approval of the Department of Buildings and be suspended for 10 feet by wire rope. All stage lights must have strong metal wire guards not less than 8 inches in diameter, so constructed that any material in contact therewith is out of reach of the flames. The bridge calcium lights at the sides of the proscenium shall be enclosed in front and on the side by galvanized iron, so that no drop can come in contact with the lights. Electric calciums, so called, are included in the above requirements. Standpipes and all apparatus for the extinction of fire or for guarding against the same must be in charge and under the control of the fire department, and the Commissioner is responsible for the carrying out of these regulations. A diagram of each tier, gallery, or floor, showing distinctly the exits therefrom, each plan occupying a space of not less than 15 square inches, must be legibly printed in black lines on the program of every performance. Every exit must have over the inside of the door the word "exit" painted in legible letters not less than 8 inches high. All exit doors must open outwards and be fastened with movable bolts, which must be kept drawn during performances. No doors shall open immediately upon a flight of stairs, but a landing of reasonable width shall be allowed between them. The proscenium opening must be provided with a fireproof metal curtain or one constructed of asbestos, overlapping the brick proscenium wall at each side not less than 12 inches, and sliding vertically at each side within the iron channels of a depth of not less than 12 inches. These grooves must be securely bolted to the wall and must extend to a height of not less than 3 feet above the top of the curtain when raised to its full limit. This curtain should be raised at the commencement of each performance, lowered between each act, and again lowered at the end of the performance. This system is now regularly in force in Chicago. If the curtain be made of asbestos, that material must be reinforced with wire, while to ensure its remaining taut and its easy descent, a rigid metallic bar of sufficient weight must be firmly attached to its base. The excess weight of the curtain is to be overcome by a check rope of cotton or hemp, extending to the floor on both sides of the stage, so that its cutting or burning will release the curtain, which will then descend at its normal rate of speed. This curtain shall at no point be nearer the footlights than 3 feet. As regards doorways, none shall be allowed through the proscenium from the auditorium above the first floor, and all doorways shall have self-closing standard fire doors on each side of the wall. Openings, if any, below the stage must each have self-closing fire doors, and all such doors must be hung so as to permit of opening from either side at all times. Near the center of the highest part of the stage should be constructed one or more ventilators of incombustible material, extending at least 10 feet above the stage roof, and of an area equal to at least 12% of the area within the stage walls. Openings in these ventilators should be closed by valves so counterbalanced as to open automatically, and kept shut by cords in which must be inserted a fusible link at a point near the bottom of the ventilator. This cord should be fastened on the stage floor level near the prompter's desk, so that in case of necessity it can be easily reached and severed. All that portion of the stage not comprised in the working of scenery, traps, and other mechanical apparatus, and usually equal to the width of the proscenium opening, should be built of fire-resisting material. The fly and tie galleries should be constructed of iron or steel, while the gridiron or rigging loft should have a lattice iron floor and be readily accessible by iron stairways. All stage scenery, curtains, and decorations, and all woodwork on or about the stage should be saturated with some non-combustible material, and this should apply likewise to all finishing coats of paint given to woodwork. A strong feature should also be made of a careful and thorough examination before and after a performance of all fire apparatus by the firemen, whether municipal or private, attached to the theatre for professional duties. This, in brief, standardizes the main features regarded by experts as embracing the minimum demands consistent with the safety of the public, and they have been given in some detail, since, shorn of picturesque narrative, they are more likely to receive attention from the serious-minded. A better example of a calamitous fire at a theatre, attended with appalling loss of life, could not be selected than that of the Iroquois Theatre in Chicago. On the 30th of December, 1903, 2,000 women and children crowded to a matinee performance of a musical extravaganza called Mr. Bluebeard. The theatre had the reputation of being the largest, safest, and newest in Chicago, and had seating accommodation for 1,740 persons. Holidays were in full swing, and being the last afternoon performance of the old year, it drew hundreds of little ones with their happy parents, not alone from the city itself, but from many towns in the vicinity. The house was consequently packed, many people willingly standing at the backs of the galleries in order to see the celebrated Eddie Foy, the chief laugh-maker of the play. A particularly popular song was in progress, and children and grown-ups were absorbed in watching 8 pretty girls and 8 young men singing and dancing to the strains of the fine orchestra, when suddenly a large piece of burning muslin border fell upon the stage. Unknown to actors and audience, the spotlight had fused, or so it was suspected, and stagehands with sticks had been fighting the fire for some moments in the wings, before this ominous herald made its unwelcome appearance in full view of all. The singers gasped and wavered. The orchestra ceased with a crash. For the space of a heartbeat there was silence. Then a curious figure, bearing a small child, staggered from the wings to the footlights. It was Eddie Foy, and the child was his son. Hurriedly he passed the boy to the conductor, and the grotesque appearance of the comedian, clad only in his tights and minus half his grease paint, momentarily distracted the attention of the audience from the flames behind him. "For God's sake, play, and keep on playing," he implored the leader of the orchestra in hushed tones, and the musicians responded to his appeal with trembling hands and uncertain fingers. Meanwhile, desperate efforts were being made to lower the fireproof curtain, which, bellying in owing to a draught from the auditorium, jammed and descended only a few feet. As the flames spurted out beneath its edge, a woman's shriek rang out, and of the horror which ensued few of the survivors can bring themselves to speak. Fire and smoke, driven from the stage, swept up to the galleries, where a panic had already started. Mothers wrapping their arms about their children were trampled underfoot in the wild rush of despair. Then the stage loft collapsed. A column of flame rose from the ground to the ceiling, and the theatre was plunged in darkness, while the battle of life continued in one crescendo of horror. All unconscious of the tragedy being enacted within a stone's throw, some painters in a building opposite one of the balcony exits suddenly saw a man standing on the escape. As they looked, the red glare of fire on the story below him showed them that his way to safety had been cut off, and that his need was desperate. Running out a ladder from their window to where he stood, they urged him to cross. But ladder and man slipped from the coping and plunged, with a sickening thud, into the street below. And now more crazed creatures were making their way to this narrow platform, and of them 12 were drawn to safety on some planks. By this time, however, the fire was above, beside, and beneath them, and women and children, packed like sardines, helpless to move, were roasted slowly alive before the eyes of their would-be rescuers. When the firemen succeeded in entering the charnel house, they were confronted by a wall of bodies 10 feet in height and 7 feet in width. It was impossible to believe that amongst these distorted forms could have remained any living person, but the fire marshal called to the surrounding silence, "Is there anyone living here?" There was no reply, and the men made their way over this ghastly barricade in search of perchance one survivor. Out of the 2,000 merrymakers who had entered the theater, buoyant with happy expectations, 602 were carried to the morgue. It was found by the exploring firemen that those in the second balcony had suffered most in their futile efforts to descend the stairs. The sight was a horrible one. Wedged in a solid mass, which had practically lost all semblance of humanity, were what had once been men, women, and children, twisted and entwined together in their death struggles. In the vice-like grip of usually feeble hands were found bits of cloth, fragments of jewelry, and strands of hair, evidently wrenched from their possessors in that hideous carnival of terror. One poor woman, from being bent back over a seat, had not only a broken spine, but had become practically dismembered through the pressure placed upon her, while in many instances faces had become so distorted as to be unrecognizable even to near relatives. Others, who had bravely kept their seats and withstood the spur of panic fear, had been overcome by smoke and gas, and at least had received as their reward a peaceful death. A fire captain, observing one of his men carrying the body of a girl, called to him, "We've got no time for that sort of thing now. We must get on." To his surprise, the man raised a tear-stained face and said brokenly, "Captain, I've got one of my own about this age, so if you don't mind, I'll carry this little one out." The captain silently handed him a blanket, and unrebuked he bore his sad burden to the door. Those there were whose hearts were too hardened to be touched by the piteous spectacle which had unnerved the strongest minded. These unspeakable creatures lurked and crouched in corners, waiting for the opportunity to pull a ring from a powerless hand, or to wrench a brooch from a motionless form. Over the scenes at the identification it is unnecessary to linger. Suffice it to say that so widespread was the sympathy evoked by this terrible catastrophe that for many days following Chicago was a city of mourning, all festivities being suspended. The distressing incidents accompanying this outbreak have not been dwelt upon with the idea of satiating a morbid curiosity, but rather because they bring home forcibly to the general reader some notion of what a theater panic really means. To how many has the question ever occurred, when seated at a theater and enjoying a play, "What should I do if someone shouted fire now? Should I push and fight and struggle, or should I remain calmly in my place?" It is this question of the personal equation which makes fire control in theaters a problem at once perplexing and all-important. Obviously, the first step towards the safety of theater audiences must come from a properly equipped and constructed building. Next, the records of almost every theater disaster show that the critical moment in determining the fate of the audience is that immediately following the first indication of alarm. Hence, the training of theater attendants should be directed rather towards the prevention of panic than to the regulation of the movements of a panic-stricken audience. For one thing, the wide disparity in numbers between the available house force and the audience would clearly render abortive any attempt at such regulation. There are, however, well-defined principles which, if carefully observed, will materially assist in directing the movements of an audience in case of fire. Firstly, to ensure the best results, all employees permanently connected to the theater should be organized into exit drill companies, each individual member being assigned a special duty. While it is both necessary and important that the individual units of these companies should be instructed in the handling and use of fire equipment and grounded in the rudiments of fire extinction, the paramount consideration is the safety of the audience, and every available means should be utilized of rendering assistance to the ushers whose business it is to obtain its prompt and orderly departure. All fire signals should be transmitted by an electrically operated alarm system, the recording apparatus of which should be placed in the main business office, the box office, and the stage manager's office. Upon receipt of an alarm by the stage manager, or when fire is discovered in the stage section before an alarm is struck, the curtain should be dropped immediately, and the stage manager, one of the actors, or the fireman on duty should go before the curtain and announce the discontinuance of the performance. Upon the wording of that announcement and the manner of its delivery will largely depend the behavior of the audience, and hence it is strongly recommended that a form of announcement should be prepared in advance, and copies thereof placed in the hands of the various stage employees. It should be brief and to the point. Something after the following is recommended. I am instructed by the management to announce that it will be necessary to discontinue the performance and immediately to dismiss the audience. Everyone in leaving the house should implicitly follow the directions of the ushers stationed in each aisle. Of course, the use of music, a lively march or something of a stirring character, is an excellent means of keeping an audience in hand and getting them away without unnecessary fuss or excitement. But this, again, presupposes an element of control over the orchestra, which it would be almost impossible to ensure unless the same musicians were permanently employed, and the management were satisfied that they could be relied upon to do their duty in case of emergency. Otherwise, obviously, they would be worse than useless, and would probably only augment signs of unrest in the most undesirable quarters. Another excellent method would appear to be to have a large plan of the theater, with exits clearly marked, painted on the fire curtain, and exhibited for a few moments during each entr'acte. After the announcement of the cessation of the performance has been made from the stage, the ushers should move forward to their respective aisles, and by word of mouth should quietly instruct their charges as to the speediest way to the street. For the assignment of exits, the seat plan on each floor should be divided into sections, and to each section there should be assigned certain exits, according to the relative discharging capacities, so that the time required for discharging the number apportioned to any one exit would average about the same for all. Each usher and doorman should be provided with a copy of the seating plan, on which would be indicated the exit assignments in detail. Ushers should, of course, be required to remain on duty by their respective exits during all performances. Fire alarm boxes should be placed in positions where they can be conveniently reached, but never in view of the audience. For the average theater, there should be a box on each side of the parquet on the wall, and in the rear of the last row of seats, as well as one in the front hall. For balcony and galleries, there should be also 2 boxes, one on each side behind the last row of seats. For the stage, there should be 1 box on the rear wall, a box on each side near the proscenium wall, and, when necessary, boxes in the dressing rooms and the carpenter's shop. The boxes in the auditorium should above all else operate as noiselessly as possible, as a signal therefrom heard by the audience would probably be more productive of panic than even the sight of the actual fire. All theaters should be in direct communication with fire headquarters. The system of assigning regular or pensioned firemen in uniform, or of maintaining private firemen in uniform, where the regular force may be unduly depleted by such assignment to theaters, is to be commended. Their presence undoubtedly does much to inspire confidence and reassure an audience in moments of excitement, while naturally their superior knowledge and skill enables them to render valuable assistance when required. Finally, there should be prominently displayed illuminated signs, not only over the exits themselves, but in all conspicuous places, with arrows indicating the shortest and easiest route by which the street may be reached. No doubt the writer will be told that he has suggested counsels of perfection, and that if the caution practical experience demands in theaters, and which is embodied in this chapter, became law, theatrical managers would spend all their time in looking after minute details, and audiences would resent being treated like children. Yet, as a matter of fact, in moments of crisis, grown people are very often akin to children, which is evidenced by the fact that under such circumstances it is extraordinary how few otherwise level-headed persons will for one moment think of leaving a theater by any door other than that through which they entered, quite irrespective of convenience of location. And hence it is that those in control must devise means to prevent them doing just those things which are worst for them, even at the risk of some unpopularity. And a fire in a theater, or a panic arising from an alarm of one, as has been shown, may lead to such ghastly results that it becomes the duty of all municipal governments to do all in their power to prevent such an occurrence. The writer, without wishing to appear extreme, is of opinion that some limitation should be placed upon the seating capacity of theaters, as distinct from stadia and places of that nature. An audience of 1,800 is sufficient to tax all the resources of those responsible in emergencies, and is about the maximum number which can conveniently and quickly pass out of any theater, without causing untold confusion in the street, which will in its turn hamper the fire forces. Equally, however, a theater run along the lines indicated will not only promise the maximum of safety, but without exaggeration will afford its patrons a greater amount of security than, as a rule, they will find in their own homes. End of section 14. Recording by Maria Kasper. Section 15 of Fires and Firefighters by John KENLON. This LibriVox recording is in the public domain. Chapter 14. The High Pressure System. The decisive feature governing firefighting in all countries and under all conditions may in every case be summed up in two words: water supply. Personnel may be of the finest, and apparatus of the most complete, but both are helpless if the wherewithal to quench the fires is lacking. Many disastrous conflagrations have owed their magnitude to this circumstance, and it is a curious commentary upon municipal intelligence that many large cities the world over, surrounded as they are with an abundance of water, absolutely lack the means for concentrating it at the scene of a serious outbreak. Small mains, intended for supply under normal circumstances, become practically useless when great fires are in question. Further, fire departments are often criticized by the inexperienced in newspapers and elsewhere for their inability to check a blaze, when the fault really lies with indifferent city fathers who, in their omnipotence, disregard the advice of those who, after all, are paid to know, and absolutely fail to benefit by past bitter experience. During the year 1903, several large fires occurred in New York, and several disastrous ones of great magnitude throughout the United States. The city had been growing steadily, and it was recognized that the water mains were too small to meet an emergency, and the authorities thereupon decided to investigate this most important subject. After careful discussion and consultation with eminent engineers, it was resolved to install the most up-to-date system of water supply known to science, popularly known as the high-pressure service. In its essentials, there is nothing really very remarkable about the idea, and in fact its designation as above is something of a misnomer. As a matter of fact, the actual pressure off a high-pressure main can be equaled by the modern steam fire pump. But whereas the latter is dependent upon the human element in the shape of the fireman who is responsible for the stoking of the engine, and for the quality of the coal and the organization of the fuel supply, and finally for climatic conditions which in extreme circumstances must affect in some degree an unprotected boiler exposed to the fury of the elements, this alternative system is practically independent of all these considerations. Undoubtedly, the ideal situation for such an installation is in a town which draws its water from surrounding mountains, such as in many Swiss cities. It stands to reason that if a reservoir or lake lies some thousands of feet above the point to be supplied, the laws of gravity will ensure a steady and continuous stream of water at any position in the area connected with it at a pressure according to the altitude of the source of supply. The fire departments of Switzerland have shown themselves keenly alive to these natural advantages, and the mechanical fire pump is practically unknown in their fire departments. But, however, the world has not been formed for the convenience of its occupants, and hence it is that science has been compelled to step in and by artificial means to find a solution of the problem. A brief description of the high-pressure system, written from the standpoint of the firefighter, will explain the scheme of operations, and what applies to one city applies to all intents and purposes to others. The service in the borough of Manhattan, the island of Manhattan in the city of New York, protects approximately 2,600 acres. That in the borough of Brooklyn, about 1,400 acres, and that at Coney Island, about 146 acres. There are 2 pumping stations in Manhattan, with 2,066 hydrants, and some 300,000 feet of mains, chiefly located in the business section of the city. Brooklyn has 1,112 hydrants, including 24 for fireboat connections, while Coney Island possesses 345, including 3 monitor nozzles. In deciding upon the location of pumping stations, prudence naturally directed that they should be placed so as to be practically outside the reach of any possible conflagration, and yet in a position to avail themselves of an unlimited supply of water drawn from either fresh or saltwater sources. Thus the Manhattan stations were located at the northwestern and southern ends of the protected area, the main features of their construction, 1-story and basement, fireproof buildings, being almost identical in both cases. These structures are of sufficient size to carry 8 pumping units each, though the present equipment consists of but 6. The contract calls for a delivery from each pump of 3,000 gallons of seawater per minute against a discharge pressure of 300 pounds per square inch and a suction lift not exceeding 20 feet. At the acceptance tests, the fire pumps in each station totaled a delivery of about 18,000 gallons per minute at the aforesaid pressure, some of the individual pumps discharging as much as 3,800 gallons. This total can of course be increased proportionately, without change in the buildings or mains, by the addition of the 2 pumping units for which space has been provided. Fresh water for each station is supplied through 2 24-inch mains connected with a third of 36 inches diameter. The salt water supply is drawn from the North and East rivers through 2 30-inch pipes. These lead into suction chambers directly in front of each station, and are so constructed that they are at all times below mean low water. This ensures a steady flow and prevents the possibility of interruption caused by air being admitted to the suction lines. Protection is afforded to the river ends of these mains by heavy bulkhead screens, and to the suction chambers by weighty bronze shields which are readily accessible for cleaning. The pumping units consist of centrifugal pumps driven by electric motors, both supported on a common bed. Special care as to strength and ability to resist corrosion was expended upon the pumps, which run at a speed of 740 revolutions a minute. They are of the 5-stage type, each stage being designed to give a pressure of 60 pounds to the square inch, or the combined pressure of the 5 stages 300 pounds to the square inch, which is the maximum working pressure of each unit. It may sound a scientific anomaly, but the fact remains that increase of pressure does not correspond to increase in volume. To frame a crude analogy, an ocean greyhound can steam 18 knots at an economical coal consumption. Increase her speed 2 knots, and the consumption of fuel at once increases out of all proportion to the additional speed. Subsequently, each additional knot, or even half knot, will demand an enormous increase in coal consumption, till eventually a certain maximum of speed will have been reached, beyond which it is impossible for the engines to develop sufficient driving energy no matter how much coal be expended. In other words, thereafter, surplus energy becomes waste. Now, somewhat similarly, each installation of pumps can deliver about 18,000 gallons per minute at a pressure of 300 pounds, but a much greater volume of water can be secured by running them at a lower pressure. Thus, the average pressure required for fire duty is from 125 to 200 pounds at the hydrant, and each station working under these conditions will deliver, with its present complement of pumping units, 30,000 gallons of water per minute. Were this volume of water concentrated within a radius of 500 feet, no imaginable conflagration could survive its attack. The pumping units are set in operation by throwing a switch on the main switchboard, which is directly connected with the motors. By this means the machines are brought into instant use, and in less than 1 minute the maximum pressure can be developed. Current for these motors is furnished locally at 6,600 volts, and each station has 4 separate electrical feeders, 2 from the waterside station and 2 from the nearest substation. Of these 4 feeders, 2 will operate the 6 pumps, but provision is made for connection with the Brooklyn stations of the electric company in that borough, this in cases of emergency. 2 24-inch mains lead out of each station and traverse practically the entire protected area. These are intersected by lateral branch pipes of 12 and 16-inch diameter, which in turn are cross-connected by 20-inch mains at frequent intervals, the water thus traveling only a short distance through a main smaller than 20 inches before reaching the hydrants. These latter are connected to the mains by 8-inch branch pipes, gates being provided at intervals of about 250 feet to enable the carrying out of necessary repairs without affecting any hydrants except those directly adjacent to the gate in question. The pipe system is so planned that without excessive drop in pressure due to friction loss in the mains, it is possible to concentrate 20,000 gallons of water a minute upon the average block of buildings, or the full capacity of both stations upon an area of approximately 1/4 of a square mile. Since the work of the fire department commences at the hydrant, no part of a high-pressure system is more important in determining its efficiency than the type of hydrant employed, which must be ever ready for instant service. Hence, the following points may be tabulated as governing the selection of this most essential feature. Firstly, suitability of design. This includes workmanship and material in order to obtain the maximum of reliable service. Secondly, facility of operation. Thirdly, freedom from frictional resistance to ensure maximum delivery. And fourthly, and of supreme importance, perfect drainage to obviate all possibility of freezing. Without going into a lengthy dissertation upon the specifications prepared and the tests carried out, it is sufficient to say that the hydrants eventually installed are furnished with 4 3-inch outlets, which provide a capacity of 4 2-inch streams with 75 pounds nozzle pressure and roughly 4,000 gallons of water per minute. It was deemed advisable that the main valve in these hydrants, which is 6 inches in diameter, should open downwards against the pressure to be encountered. In order, therefore, that the operation of opening this valve against the heavy pressures liable to be met with in the service mains should be an easy and rapid one, it was so designed that the first 3 turns of the hydrant wrench should open a pilot valve, thereby admitting water to the barrel of the hydrant, thus equalizing the pressures on both sides of the main valve, after which it can be opened without difficulty or resistance. A few seconds is sufficient to accomplish this adjustment of pressures after the application of the wrench. The operation above described sets in action a drip valve, which closes as the main valve is opened, and opens as the latter closes. There is a connection between the drip valve and the sewer, thus ensuring the drainage of the hydrant barrel after use. Valves controlling the hose outlets are provided with a device which balances the pressures, permitting the former to be opened easily with a 5-inch wrench under a pressure of 250 pounds. Needless to say, before this system was finally handed over for practical service in the New York Fire Department, extensive tests were made, 2 of which are particularly worthy of notice. The first took place along the North River front. 21 3-inch lines were stretched from 7 hydrants, and 12 2-inch and 9 1.5-inch nozzles were used. Within 2 minutes after the order to start water had been given, a nozzle pressure of 80 pounds was registered, and so great was the volume of water delivered that the streets speedily became a lake and overflowed towards the docks. The second test was even more exhaustive. 12 3-inch lines with 1.5-inch nozzles, 6 Siamese lines with 2-inch nozzles, a water tower with a 2-inch nozzle, and a deck pipe with a 1 3/4-inch nozzle were all brought instantaneously into action. 1 minute after giving the order to start, a nozzle pressure of 150 pounds was obtained, and in 2 minutes 195 pounds was registered on the 1.5-inch nozzles and 170 pounds on the 2-inch. With the nozzles elevated to an arc of 80 degrees, this pressure carried a solid stream of water 100 feet above the roof of a 14-story building. The gauge on the water tower at this time registered 270 pounds. To the layman, even these simple figures may seem perplexing, so it may be well to translate hard facts into picturesque simile. A stream of water propelled by a pressure of 200 pounds to the square inch, striking an ordinary office partition at right angles at a distance of about 100 feet, would smash it up as though it were so much matchwood, and play with its contents like a whirlwind. Similarly, the same stream, elevated to 80 degrees, could easily clear the cornice of the tallest apartment house in Manhattan, or could wash the dome of St. Paul's Cathedral in London. In 1908, this system was formally turned over to the department, but at the outset the greatest caution was observed over its operation. Thus, companies responding to an alarm in the high-pressure district, as a precautionary measure, always coupled up to the low-pressure hydrants with engines, thus making security doubly sure. As the absolute reliability of the new installation became increasingly apparent, these precautions were gradually withdrawn. Till today, no engines respond to any fires in the high-pressure district unless specially requisitioned. Many outbreaks nowadays are fought and conquered with a second alarm assignment, which, before the advent of the high-pressure system, would have required a fourth alarm, a fact which, trivial perhaps to the lay mind, will be appreciated by chiefs of fire departments in its full significance. No doubt the latter have often realized the danger of having to draw almost every piece of apparatus at their command to a big fire, leaving nothing in reserve with which to tackle another outbreak should one then occur. Simultaneous calls of this nature tax the wit of man to meet, and the days of miracles are past. The first fire can be fought and quelled, but the second, coming when the force is already engaged, forms a very serious menace. In the high-pressure area of New York, 4 fires of some magnitude have been attacked and suppressed at the same time, not to mention several smaller blazes. That fact speaks for itself. Prior to the installation, also, there was always the fear of a sweeping conflagration after the style of Baltimore, but that has passed away forever. New York today is the best fire-protected city on the American continent, but even the knowledge that this is so has not prevented further efforts to meet the demands of the situation. Another pumping station is even now in course of construction, and within 2 years it is confidently expected that the area protected by duplicated high-pressure mains will amount to over 10,000 acres. This in the most congested and most valuable portion of the city. But to return to the detailed description of the apparatus employed in rendering the installation additionally effective. The use of centralized energy for delivering water at a high pressure throughout an entire system naturally entails upon all the mains and hydrants involved the maximum pressure required at any one point. It is therefore quite likely to happen that whereas a pressure of 125 pounds will be ample for one fire, another outbreak may occur in the protected area necessitating a pressure of 250 pounds. This would mean that the pressure would have to be raised suddenly to meet the fresh call, and coming unexpectedly and unheralded, it might seriously endanger the men operating at the smaller outbreak. Or, further to illustrate this point, it is sometimes desirable to take water from a hydrant for a hand line at 75 pounds, and from another outlet to supply a water tower at 225 pounds. To permit of this arrangement, a regulating valve, weighing only 25 pounds, has been invented, which is attached to the hydrant outlet. A pressure gauge is inserted on the hose side. The regulating valve is opened until the gauge needle points to the pressure required, and no matter to what extent the pressure on the receiving side is increased, on the discharging side it remains at the figure selected. If a shutoff nozzle is used on the line, automatically the pressure remains at the figure indicated on the gauge. Even the layman will appreciate the enormous importance of a valve of this nature, without which the system as a whole could not be properly controlled or operated to the best advantage. In order to guard against the somewhat remote possibility of a breakdown of all pumping units in both stations, provision is made for connecting the fire boats of the department to the high-pressure hydrants. By this means, these boats can deliver 60,000 gallons of water per minute at a pressure of 250 pounds. In addition, by this method, fire boats may be made to constitute a valuable auxiliary in the case of any great emergency. But as science is never idle and one discovery leads to another, so it is with the business of fire control, and day by day fresh ideas are brought into being, tested, and utilized for the common weal. Thus, in the later portions of the city protected by the high-pressure system, it has been found advantageous to duplicate the mains and hydrants, so that if one set of mains becomes blocked, the other may be brought into service without delay. The system is operated as a unit, but in case of a break in the mains, it can be divided by closing of the motor valves at the selected points. These valves are controlled by switches on the pumping station switchboard, a row of red and a row of green lights indicating the two lines of mains. In the event of a break, pumps are shut down and the motor valves are immediately closed. When the pumps are started again, the pressure building up on the line that is intact will be shown by the colored lights mentioned. The serviceable main will be kept in use at the fire, but the officer in charge must wait about 1 minute in order to see whether the pressure is from the red or the green line. As soon as the pressure shows on either, those lines connected to that disabled will be shifted over to the hydrants on the main intact, and the fight can be continued with ample water supply. During the continuance of a fire, the chief operating can control the pressure of the pumping station, increasing or decreasing the same or stopping it altogether by means of a special telephone service run into boxes conveniently situated and specially designed for the purpose, which are plentifully installed throughout the protected area. This system has been found to answer well, though it is open to the possibility that orders may be misunderstood from one cause or another. Probably some improvement thereon may be framed in time as the science of firefighting becomes increasingly popular, and it is better realized what an important part is played by fire control in the daily life of the people. For instance, one of the most gratifying effects of the introduction of the high-pressure system in New York was the immediate drop in insurance rates. In December 1908, about 6 months after this system had been put into regular use, the New York Fire Insurance Exchange made a general reduction of rates throughout the high-pressure zone in Manhattan, a reduction amounting to the respectable sum of $500,000 annually. In Brooklyn, likewise, a reduction of $250,000 followed, so that the improvement has already saved the taxpayer in the community about $750,000 a year. Hence, this method is not one of fire control alone, but becomes positively a good investment. Of course, it may be urged that in the United States, the profession of firefighting has developed into such a highly specialized service and has demanded so many drastic changes in equipment and maintenance because the risks incurred are proportionately greater than are met with elsewhere. There is a measure of truth in this, but it is on a par with the individual who, living in a small island, considers motor cars an unnecessary means of transportation and railways a wasteful expense, because he has always found a horse and trap convenient and sufficient for his needs. That is, of course, a somewhat exaggerated simile, but it is an incontrovertible fact that there are many otherwise normal citizens in all the countries of the world who view innovation with suspicion and shield themselves behind the comfortable assurance that our fathers did very well without all these newfangled notions, and what was good enough for them is good enough for us. This especially as regards municipal outlay on fire protection, though in this respect the writer must lay it on record that New York has always risen to the occasion in the most open-handed manner. For some obscure reason, the average man objects to putting his hand in his pocket for anything in connection with the fire risks of the community, just as much as though he were being held up by a highway robber and willy-nilly had to surrender his purse. There is no advantage in laboring an obvious point, and the writer has in his mind not Europe alone, but some American cities, where the fire department is apparently regarded as a costly and unnecessary adjunct to other municipal offices. Yet in all fairness to those whose responsibility it is to protect the lives and property of those given into their charge, there should be no hesitation in providing them with the most modern and up-to-date apparatus for the discharge of their duties. The mathematical aspect of the whole question, as regards the high-pressure system as a whole, is not a difficult one for fire committees to understand. Since one high-pressure hydrant is the equivalent of 6 engines of the first size, how many hydrants would be equal to the entire pumping outfit of the brigade, using an English term, and would not the initial expense of the installation be more than met by the decrease in personnel, the decrease in insurance rates, and the increase in safety of citizens committed to their charge? The answer to this conundrum should not unduly tax the mental equipment even of one of those corporations addicted to the traditions of the Medes and Persians. End of Section 15. Recording by Maria Kasper. Section 16 of Fires and Firefighters by John KENLON. This LibriVox recording is in the public domain. Chapter 15. Fire Control in Schools, Factories, and Hospitals. Since it is no exaggeration to define panic as one of the most effective allies of fire, it is obvious that in dealing with buildings occupied by large numbers of either young or infirm people, or with places where passing crowds are apt to congregate, such as department stores, peculiar precautions are necessary. The genesis of many a conflagration attended afterwards with terrible loss of life is often trivial. Taken in time and dealt with coolly, it would never have developed into a serious outbreak. And equally, the magnitude of the blaze as regards actual fire damage can never be accurately gauged by the death roll. Experience has shown that in such disasters, as many die from suffocation consequent upon crushing, or from injuries received in seeking safety through some desperate and ill-judged action such as jumping into the streets, as perish in the flames. Of course, this is natural. A curl of smoke, a few sparks, and a cry of fire, and unless beforehand prepared for this kind of emergency, the primal impulse of anyone is to reach safety, or what appears safety, as quickly as possible. No thought is given as to the best mode of exit. Misguided instinct suggests the way by which one has entered, and instantly corridors, stairways, and passages become jammed with a frightened, hustling crowd, beyond control, and following each other like sheep to the shambles. It is this incontrovertible fact which has caused the architect to labor towards the design of panic-proof structures, and has led those interested in fire control to devise means which shall render such occurrences rare to the point of non-existence. And it must be remembered that, unfortunately, responsible authorities are called upon to frame regulations oftentimes not for application in modern fire-resisting buildings, but for structures composed largely of lath and stucco, and which, given the opportunity, would burn like tinder-boxes. Hence, it seems scarcely necessary to emphasize the point that with the latter the danger is more acute, and above all else there is need for speed and sang-froid. Now, the only method by which this state of affairs can be assured is by a process of accustoming the human unit to the conditions likely to arise in a fire emergency, and this can best be done by means of drill. Whether it be employees in a factory, children in a school, or the staff of a hospital or a department store, exit drills should always be enforced. And where circumstances allow, provision should be made for some sort of house firefighting force. It must be understood, of course, that the latter in no way takes the place of the regular fire department, which should be communicated with at once in all cases, but rather is intended to act as an auxiliary pending their arrival. It will be convenient to deal seriatim with the 4 types mentioned. In factory buildings, particular danger attaches to the stairways connecting stories. They can only accommodate a limited number of people, and form dangerous exits for crowds. Congestion at their corners means death, and since employees may be expected to vary in nationality, misunderstanding of orders becomes more probable, and the problem of preventing a panic assumes a thorny aspect. In the first place, exit drills should be held as often as possible and should include everyone in the building. When 2 or 3 firms occupy the same premises, there should be cooperation, and the alarms announcing these drills should be given from different floors, in order that practice may be afforded in changing the order of precedence for possession of stairways and fire escapes. The line of march may be so arranged as to take advantage of the additional time required in the descent of those from the upper floors by dismissing such of the lower floors as would not delay their egress. An exception to this rule should be made where buildings are divided by fire walls with protected openings, which permit the transfer of occupants in the fire section to the corresponding fire-free section on the same floor in the building, or where provision is made for a safe retreat by means of gangways leading to adjoining buildings. Incidentally, an excellent scheme where feasible is to dismiss the employees nightly by a fire signal. In assigning stations, the first consideration is the selection of aisle guards, whose business it is to effect line formation, prevent pushing and overcrowding, and to see that the time-honored precept, women and children first, is observed. All subsequent movements should be regulated by a gong or whistle. Thus, the first alarm indicating the floor of the outbreak should consist of a number of taps indicating the floor. As soon as the first stroke sounds, work should cease, and if possible all power be shut off the machines. Then all stock, chairs or benches blocking the aisles should be removed by the employees nearest, and placed either above or below the work tables. The next movement is to march to the exit passage in single or double file. If in the latter, couples should link arms for mutual support, the women using their free hand to raise their skirts to prevent themselves and those behind them from tripping. And each file should move forward, observing a uniform distance between the couples. The signal to start should be given by the room captain, and under no circumstances should any employee be permitted to attempt to secure clothing from a locker or cloakroom. Upon reaching the street, the line should be led away to a safe distance from the building, and for this duty one of the supervisors should be selected and drilled as a guide. Elevator attendants should take their cars upon the first sound of a building alarm to the floor indicated, and hold themselves subject to the orders of the floor chief. In high buildings of the fire-resistive type, the operator should run his elevator into the fire zone, receive passengers, and, if conditions favor, discharge them a few floors below. The usual difficulty, however, is that floors and stairways are so crowded that he has no option but to run to the ground floor. The assignment of exits necessarily depends upon their number, capacity, and location, but it is important that all means of egress should be based on approximate estimates of their relative discharging capacities, which can be readily arrived at by actual tests. When possible, provision should be made for the unhampered entrance of firemen, and in the planning of such fire drills, combinations of exits should be studied. Employees having the welfare of their workpeople at heart can always obtain advice, if in any doubt on this subject, from officials of the fire department. All that is intended here is to suggest certain simple rules of conduct which will tend to prevent confusion and make for safety. The location of stairways, fire escapes, and other exits should be indicated by illuminated signs, and for the information of employees, leaflets should be printed in several languages, giving the details of the fire drill. It goes without saying that all modern buildings of this type should be equipped with an electrically operated alarm system, the mechanical gong of which could be better heard above the noise of any machinery than one struck by the room captain, and would possess the additional advantage of automatically operating on all floors from any position. The box stations governing these alarms should be accessible only to responsible persons. It may be urged that such precautions presuppose certain members of the staff being possessed of intelligence and a considerable amount of organizing ability, but as a rule, either foremen or forewomen in sectional charge of 50 employees will be found to fill admirably such executive positions as room captains. They, in their turn, are naturally subordinate to the manager, who should accept supreme control and the responsibility attaching thereto. Aisle guards may be compared to lieutenants. They should be strong and alert, and owing to the fact that they may be required to use some physical force, should, when possible, be men. They should be especially watchful for persons stumbling, fainting, or becoming hysterical. Where stair exits have sharp bends, they should be stationed there to prevent congestion, and above all, they should be made to realize their obligations and to feel that their duties are no mere sinecure. Finally, there should be at least one male and one female searcher on each floor, to visit the toilet rooms and other such places where perhaps the fire signal could not be heard. In buildings of an antiquated type, these precautions make no pretense of securing absolute safety to the individual, but if the drills be arranged with the advice of a skilled fire official, it is probable that panic will not unreasonably seize all inmates, and that the fire department will at least be given an opportunity of effecting such rescues as human ingenuity and providence will allow. At any rate, they will not be met with the appalling conditions, which, alas, have been only too common hitherto, when persons have found death needlessly while safety awaited them with the advent of the professional firefighters. The fire risk is real enough, without the additional factors of fright and bad management, and it is to guard against these that the above has been suggested. One of the most terrible conflagrations of this nature in recent years was that which occurred on Saturday, March 25, 1911, in the Ash Building, a 10-story structure situated at the corner of Washington Place and Green Street, New York City. The following account, vivid in its simple realism, is taken from the report of the New York Board of Fire Underwriters. Occupancy, 8th, 9th, and 10th floors. Workrooms, showroom and factory, stockroom, pressing and shipping department of the Triangle Waste Company. On the 9th floor there were 2 wooden partitions, one forming the cloakroom, the other being at the north side enclosing the entrance to the freight elevators and stair shaft. On the 10th floor there were partitions of wood and glass forming offices and showrooms. On the rear of the building in the court was an iron fire escape, the steps being 17.5 inches wide. The fire escape did not extend to the bottom of the court, and the court had no exit to the street. On the 8th floor were 5 unbroken rows of 4-foot tables, each containing a double row of sewing machines and shirtwaists in process of manufacture. These tables extended from the Washington Place front south wall to within 18 feet of the north side of the building. This latter space was partially filled with stock, principally on tables. An aisle space was also left running east and west along the north side. The space along the east wall contained the cutting tables. Approximately 275 operators were on this floor. On the 9th floor, there were 8 unbroken rows of 4-foot tables with 300 operators. There were no aisles running east and west at the south side of these floors, the sewing machine tables extending close up to the wall. The space between the tables was approximately 4 feet wide and contained 2 rows of chairs back to back. It also contained baskets and other receptacles for the goods in process of manufacture. The only convenient way for the operators next to the south wall to reach the stairs and elevators at the southwest corner was to walk the entire length of the crowded space between the tables to the north side, and then use the aisles which extended along the north and west sides of the building. The fire started at 4:42 p.m. on the 8th floor in the vicinity of the northeast corner of the building, almost simultaneously with the signal to stop work for the day. It is generally believed to have originated from a match or cigarette igniting scrap material on the floor in the vicinity of the cutting tables. It spread rapidly, however, due to a large quantity of inflammable material, consisting chiefly of thin cotton, lace, and other trimmings. In a very short time the fire had spread over the entire floor and communicated, principally out and in the windows, to the floors above. In addition to the windows, the fire may have communicated from floor to floor by way of the stairs and elevator shafts, as the doors were undoubtedly open, in part at least. The plant was working overtime when the fire occurred. According to the information obtainable, the operators crowded in among the machines, chairs, and goods on the 8th and 9th floors were badly panic-stricken immediately after the start of the fire, and in consequence made slow progress towards the exits. Considerable delay is said to have been experienced in opening the doors leading to the stairs at the southwest corner of the building, as they opened inwards and the women became jammed against them. Practically the entire loss of life was confined to those employed on the 9th floor. More than half of the number said to have been on this floor escaped. It seems apparent, however, that by the time this number had got out, the elevators had stopped running, and the flames around the two inside stairways and the outside fire escape, both on this floor and those adjoining, would not permit any further egress in these directions. The result was that all who remained on the floor until this condition prevailed were overcome by the smoke and fire or jumped from the windows. It is said that a few, probably 20, from the upper floors descended by way of the outside fire escape. These re-entered one of the lower stories and passed down the stairways. Approximately 25 bodies were found closely jammed in the cloakroom next to the stair shaft at the west end of the building. About 50 were found near the northeast corner behind the partition and clothes locker, located 30 inches from the north end of the two tables nearest the east wall. 20 bodies were found near the machines where they worked, apparently having been overcome before they could extricate themselves. About 10 are said to have been taken from the bottom of the court on the north. The balance of those killed, approximately 40, jumped from the windows to the street. There seems to be no doubt that had a fire drill been organized amongst these women, so great a panic would have been avoided. But in the opinion of the writer, automatic sprinklers would in all probability have averted the disaster, as their operation would have turned in an immediate alarm, and the delay in sending in an alarm contributed greatly to the appalling loss of life. It must, however, be remarked that the fire escape in the rear of this building was quite inadequate for the needs of the situation, as in order to gain the street, it will be noticed those using it were obliged to re-enter one of the lower stories and pass thence down the main stairway to the front door. In addition, doors should never be constructed to open inwards. Turning now to the problem of schools. In its essentials, this is in many ways akin to that of factories, with the outstanding difference that in dealing with children even greater care must be exercised by the supervisors or room captains. These should be chosen from amongst the teachers, and their duties with regard to their charges should be along precisely similar lines to those already laid down, though it should be borne in mind that personal influence here plays a greater part. Where pianos or other instruments are available, an excellent plan is the use of marching music to assist in steadying the lines of scholars after the fire alarm. Incidentally, school should always be dismissed once a day in accordance with the practices of fire drill. In the matter of exits, preference should be given to the classes with smaller children, and it is particularly urged that exits for infants should be smoke-proof and of sufficient width to accommodate double lines of 2 children each. Further, as far as the construction of the building will allow, the convergence of 2 columns in narrow halls or stairways should be particularly avoided. This is only too liable to cause confusion, which in the event of the building being a quick burner may result in terrible loss of life. In schools of advanced grades, where there are boys of a certain age, it is a good system to organize a small firefighting force to use the chemical extinguishers common to all public institutions, and from the nature of the duty, youngsters are likely to become enthusiastic over and expert in their management. Since example is proverbially better than precept, the following accounts of 2 school fires, widely differing in ultimate results, but having many points in common, may not be without interest to the general reader. In Collinwood, a suburb of Cleveland, Ohio, there stood on the 4th of March, 1908, a large school accommodating over 800 children. The day was a warm one, and there was but a small fire in the furnace, which was situated under the front stairs. Before the noon recess, the janitor in charge noticed a thin stream of smoke coming from the basement, and at once gave the alarm. On the ground floor, the children were marched out quietly, calm in the belief that the signal was for a drill. But before the anxious teachers on the next 2 floors could marshal their charges, the fire had gained such ground that all escape by the front door was impossible. As the children neared this exit, they were driven back by the smoke which confronted them, and fought to reascend the stairs, only to be pushed down into the flames by the excited and frightened little mob still descending. In the drills used, both teachers and children had been accustomed to employ only the front door as a means of egress, and the fact that this means was debarred to them seems to have had a paralyzing effect upon all intelligence and action. By the time the second stairway, leading to a door in the rear, was thought of, the children were entirely out of hand, and when this door was found to be locked, the situation became uncontrollable. Parents brought to the scene by the sight of the smoke and the shrieks of the children in distress stood helpless, as did the firemen. In this suburb, the only force available was that of volunteers, whose apparatus was inadequate, having no ladders long enough to reach the 3rd floor, and who were unable to obtain sufficient water pressure to extinguish the fire in the 2nd story. One desperate mother, aided by an unknown man, tried vainly to open the rear door, behind which muffled sobs and groans told of the extremity of the little ones within. But her efforts were fruitless, and with her bare hands she succeeded in breaking some panes of glass in adjacent windows, and managed by this means to drag to safety a few semi-conscious tots. None of the children fighting and struggling for life behind this pitiless barrier was more than 14 years of age, and many were only 6 or 7. At the front door, the weight of human bodies became so great that it collapsed and showed to the agonized spectators, many of them parents, a heap of little forms caressed by the flames and half hidden by the smoke. Amongst this pile was one small girl of 10, whose father arrived in time to make a futile attempt to pull her from the death awaiting her. Still alive, but crushed and horribly burnt, she was able to hold out her feeble arms to him, and he, heedless of the peril of his own position and intent only on the saving of his daughter, worked frantically until his own injuries prevented further effort. Another child was recognized by her mother. Their hands met, when a piece of broken glass fell on the mother's wrist, practically severing it from the arm. As the grip of the 2 hands relaxed, the daughter fell back into the blazing pyre to be seen no more. In 30 minutes from the time of the first alarm, nothing remained of the building but 4 blackened and uncovered walls and a smoldering heap of wreckage, some of which had once been human beings. It was only then that the firemen were able to enter the ruins, and there was virtually nothing for them to do. Of the 810 children who had taken in their books that morning, about 170 had perished, and with them died 2 teachers in the vain attempt to lead their charges to safety. The rear door also was broken down by the number of little ones who had been packed so closely against it that their combined weight caused the lock to give when it was too late. Practically all of the bodies were unrecognizable, and frenzied relatives were unconvinced of the losses in their homes until the roll had been called. The origin of this fire still remains unknown. It may have been due to defective flues or to carelessness. But be that as it may, the results of this catastrophe carried mourning into hundreds of homes, and once again emphasized the pressing need of every known structural precaution in such buildings, plus better considered planning of drills. It is a relief to turn from the recitation of such horrors to the narration of a brighter and happier story. In Raleigh, a small town in North Carolina, on Friday morning, February 14th of the present year, a fire broke out in an old wooden school building, which from its construction was a veritable fire trap. In spite of the fact that the halls and rooms were filled with smoke before the 350 children could be got into line, their order was unbroken and their courage unshaken, as they marched through the suffocating atmosphere to the doors and down the wet fire escapes. The principal of the school was notified of the danger by one of her subordinates. Quickly closing the doors in the upper hall, she gave the signal for the drill, which her pupils had often practiced. At the tap of the gong, every child fell into line, those downstairs going out of the front and main entrances, while those on the upper stories descended to the streets by the 2 fire escapes, which were wet and sticky from the snow that had fallen during the morning. All was as orderly as a stage rehearsal. Even the smallest tots followed the elder ones without the slightest confusion. There was no attempt to get hats or wraps or books. The whole operation occupied only 3/4 of a minute, which was better time than had ever before been made in practice. Parents who had rushed to the scene, dreading the terrible sights which might meet their eyes, saw an orderly procession of youngsters march out of the building, filled though it was with smoke and flames. Owing to the snow and the slippery condition of the streets, the fire department had been appreciably delayed in responding to the alarm, and had it not been that the fire chief had insisted on and enforced the precautions of a daily drill amongst the pupils, the loss of life might have been appalling. In the opinion of the writer, all concerned deserve the maximum of praise. The head of the fire department, Sherwood Brockwell, a graduate of the New York Fire College, for his insistence, the superintendent for the intelligent way in which the children had evidently been trained, and the latter for their coolness and their evident trust in their teachers. It is no exaggeration to say that the fire peril could be practically eliminated in schools were the example of Raleigh followed. At the same time, it is absolutely incomprehensible how sane persons, ignorant though they might be of the elementary principles of fire control, could allow so glaringly foolish an arrangement to be made as that which permitted the placing of a furnace immediately under the front stairs of a school building, apart from these having been constructed of wood. Under any circumstances, heating apparatus of that nature should be located in a separate structure, adjacent to but isolated from the school itself. Should a fire occur during school hours, the officer in command of the fire force can ascertain quickly from either the principal or the teachers the location of the fire, which will govern his subsequent actions. Should it be in the upper floors, the entrance must not be attempted by doors or stairways by which the children are leaving, though use may of course be made of any unused stairway. By means of a ladder raised to an upper window, a line of hose can be brought quickly to bear on the blaze, care being exercised to drive it back from the exits. Other lines, as necessary, will be placed similarly. and the fire may thus be held in check until all the scholars are out of the danger zone. Then, should the fire assume dangerous proportions, it may be fought as in other buildings, that is, by stairways both front and rear, and if necessary from both sides. Too much emphasis cannot be laid upon the necessity of preventing excited parents and others from rushing to the entrances by which the children are leaving the building, breaking the line, causing confusion, and retarding the exit of those still within. However good their intent, their interference must work mischief. It is imperative that the children be kept marching until all are safely out of danger. Officers in command should see that an adequate force of police and firemen are told off for this important duty. The safety of the shopping public in the enormous department stores which have latterly sprung up in all American cities, and for that matter in Europe as well, is in itself one of the most difficult problems which those interested can possibly face. Here there is no question of drilling regular habitués, for the population is a floating one. That is to say, the attendants and employees may be trained until they are expert in the duties assigned to them, but dealing with dispersal of great hordes of strangers is one that requires almost superhuman management and foresight. In fact, in the opinion of many, it is impracticable. Drills are rendered difficult by the constant presence of strangers. A test alarm may produce a panic, when even those gifted with the maximum of human magnetism would find the control of strange crowds beyond their powers. But at least precautions can be and are taken. Abroad, as well as in the United States, efforts have been made by private fire departments, which should always be captained by retired officers of regular fire brigades, and by the organization of all employees into a homogeneous unit of action, in the event of crisis to grapple with the events likely to occur so far as circumstances will allow. No human agency can do more. The study of scientific fire control is of recent growth, and many of the great emporia which dot the cities of the world are the result of evolution. But as a rule, when additions are made to such structures, they are subjected to the most searching of fire tests, and the writer can aver from personal experience in New York that neither time nor money has been spared to render the same as secure as is feasibly possible. In addition, it must be understood that under no circumstances can effective drills be carried out, that is, as though under emergency conditions, unless the temper of the public changes in an amazing degree. However, it is always practicable to construct some sort of edifice even upon the most insecure of foundations, and certain primary precautions, though in no way adequate properly to control the situation, may go a long way towards the prevention of a disastrous panic. In brief, all that has been written may be taken as supplying in embryonic form the basis of department store exit drill. That is to say, there should be capable floor masters, capable guards, and by private instruction the actions of all concerned should be regulated. Owing to the fact that many of the employees are women and girls, men should be chosen to fill executive posts, that some chance be given to their weaker colleagues to make their escape, whatever occurs. Upon the first signal of the alarm, each member of the staff should, as in a factory drill, clear all gangways of rubbish, stock, or obstructions. They should then form in double lines along the aisles leading to the exits. Those not actively employed in the emergency organization should then form squads and in pairs, women holding up their skirts, march to the exit they have been previously instructed to use. The elder women in all departments should be trained to lead these lines, and incidentally their example is sure to have a steadying effect upon both their subordinates and their customers. But the real problem is concentrated in how effectually to deal with the casual public, who throng these buildings daily to so great an extent that it is estimated not less than 10,000 persons are sometimes on the premises at the same moment. Apart altogether from the private fire brigades maintained by these establishments, apart altogether from fire escapes and the most modern fire precautions, this constitutes the real peril which must be initially overcome. It can only be accomplished by constant and painstaking training of every individual employee, and by their example, coupled with the exertions of aisle guards, who will indicate to the flurried and hysterical how safety may be most easily reached. At such a moment, one cool floor walker, with his wits about him, will potentially save more lives than the best equipped fire department which ever traveled the streets. Conquering a fire is one thing, conquering a panic is another. And whereas even after its inception, prompt action may quell the former, the latter belongs to the elemental side of human nature, and as such is beyond the reach of science or apparatus. As for structural safeguards, the disposal of rubbish, and other means towards fire control, they have been dealt with elsewhere. Though the cardinal factor of human temperament can never be altered or modified by such external measures, the knowledge of their presence tends to a certain degree to alleviate fear. If the employees of a department store are faced with an enigma in dealing with their customers, then most assuredly the staff of any hospital have every reason to fear fire and its accompanying risks. Here the problem is complicated by the absolute helplessness of the patients, and the possibility that severe shock in some instances may result in death. But on the other hand, nurses, attendants, and doctors are all persons of superior intelligence, and may be expected to carry out instructions not like automatons according to the letter, but with due regard to prevailing conditions. Equally, fire control in hospitals has for long absorbed the ingenuity of architects, with the result that, generally speaking, they are well safeguarded. At the same time, however, certain simple devices can easily be installed, amongst the most valuable of which are fire brakes, which, acting automatically, accomplish in corridors with flames precisely what watertight doors accomplish in ships with water. In other words, they delay the enemy, and if unsuccessful in their passive defense, they at least hold him in check long enough to ensure the adoption of precautionary measures for those concerned. In simple language, they may be described as iron drop doors, which, being operated, cut off the area involved from the rest of the building. Further, though properly speaking this is a structural safeguard, the employment of fire towers is strongly to be recommended. These consist of a covered staircase adjacent to but distinct from the main building, and connected by iron gangways at each floor. Thus, by closing the exit doors, which are fireproof, a completely isolated staircase is formed, down which patients can be moved to safety without hurry or alarm. Incidentally, these towers form admirable adjuncts to all classes of structures and public edifices habitually frequented by numbers of persons, of both sexes and all ages. It seems unnecessary to insist once more upon the careful disposal of all rubbish, since such a precaution appears to belong to the obvious, but the writer's experience has taught him that it is precisely the most ordinary safeguards which are habitually neglected. Finally, the following recommendations may be accepted as applicable to all classes of buildings, and, if adopted, promise a large measure of safety for the occupants. A. All stairways, or a sufficient number of them, should be located in fireproof shafts, having no communication with the main structure, except indirectly, by way of an open-air balcony or vestibule on each floor. Hose connections attached to standpipes should be located on each floor in the stair towers, available either for public or private fire department use. B. Stairs, if any, inside the building, and elevators should be enclosed in shafts of masonry and have fire doors at all floor communications. C. Older buildings with inadequate fire escapes should be provided with automatic sprinklers or smoke-proof stair towers, but outside fire escapes passing in front of or near windows should be discouraged. D. All factory buildings employing operators in the manufacture of inflammable goods should be fitted with automatic sprinklers, and this system should likewise be extended to all classes of structures generally frequented by a considerable number of persons. E. Large floor areas should be subdivided by fireproof partitions or brick walls. The above are not counsels of perfection, and are well within the reach of those having the safety of their fellow creatures at heart. End of Section 16. Recording by Maria Kasper. Section 17 of Fires and Firefighters by John KENLON. This LibriVox recording is in the public domain. Chapter 16. Firefighting in the United Kingdom. Comparisons are often instituted between the fire risks of London and New York. It is glibly pointed out by statisticians with facile pens that whereas for every 100,000 inhabitants, London averages 81 and New York 300 fires, and whereas the population of London is considerably greater than that of New York, ergo, fire control in the former city has attained to a higher degree of scientific evolution than in the latter, and further deductions are drawn according to the nationality and enthusiasm of the individual. But such reasoning is founded upon the superficial aspect of the subject, without taking into consideration the numerous contributive factors governing the problem. In the first place, in making these invidious comparisons, writers forget that units of apparatus, ability of personnel, and general efficiency may be on a par in two separate firefighting organizations, but owing to local causes and climatic conditions, the annual record of the two may be widely divergent. New York has certain disadvantages with which to contend. Its modern buildings are the highest in the world, in themselves a staggering question for the firefighter. In portions of the city there are streets comprising nothing but wooden buildings which burn like torches. Extremes of climate render fires more prevalent and more hazardous. The alien population is vast and criminally careless. And finally, unfortunately, arson has grown to be regarded amongst undesirables as a legitimate and easy way of obtaining insurance as a form of income. Any unprejudiced observer will allow that in these respects London is more fortunately situated, which admission detracts in no whit from the standard of excellence of both departments, which are well worthy of the great capitals they represent. In considering rather more particularly the outstanding features of its brigade, London, in common with all other English cities, has no need for the heavy appliances usually seen in America. Owing to the narrow, tortuous streets in all ancient towns, the manipulation of weighty apparatus with lengthy wheelbases becomes practically impossible, while the average building, constructed of stone, and of only 4 or 5 stories in height, does not constitute a grave fire risk. The residential area of London is chiefly composed of such erections, and even in the wealthier suburbs, where the houses stand in their own grounds, this fact of itself is sufficient to prevent a serious conflagration. In the eastern section of the metropolitan district and along the docks and wharves lining the River Thames, the risks are materially greater, and hence there is a considerable concentration of strength in this locality, though it is worthy of note that of the 65 outbreaks classified as serious during the year 1911, about 34 occurred in quarters inhabited by aliens, a sufficiently good indication of the truth of the preceding statement, that these foreign colonies are a fruitful source of anxiety to the authorities of any city. It is also of interest that of the grand total of 4,000 and odd fires during that year, no less than 1,762 were directly attributed to carelessness, while only 28 resulted from arson. Prior to the year 1866, the protection of London from fire depended upon an organization known as the London Fire Engine Establishment, which consisted of only 130 officers and men, operating 17 stations. The cost of its maintenance was chiefly borne by fire insurance companies, and its duties were practically confined to fire quenching. For the saving of life from fire during many years, the Royal Society for the Protection of Life from Fire, which was supported by voluntary contributions, supplied and manned some 85 fire escapes, which were stationed in various parts of the city, few being in the suburbs. There were, in addition, several so-called volunteer fire brigades, which were not under the direct control of any recognized authority, and proved a veritable thorn in the flesh to the municipality. Having no definite financial support, they employed collectors, with the result that the unfortunate ratepayers were solicited for contributions towards associations which, with rare exceptions, seldom performed any useful service, and for the disposal of whose funds there was no adequate guarantee. Moreover, it was customary for these gentlemen to wear a uniform similar to that of the professional firefighters, causing a good deal of acrimonious confusion amongst those who were under the impression that they had contributed towards the funds of the professional fire brigade. The Act of Parliament of 1865, however, put an end to this ambiguous state of affairs, and on January 1st of the following year, the Metropolitan Board of Works assumed the responsibilities of the two first-named organizations under the title of the Metropolitan Fire Brigade. As for the volunteers, they lingered for some time, being disbanded one by one, till in 1900 the sole surviving company, located in Islington, closed its doors. The funds provided by the aforesaid Act for the maintenance of the brigade were a. Contributions by the fire insurance companies, at the rate of £35, $175, per million of the gross amounts insured by them in respect of property in London. This was calculated to bring in about £10,000, $50,000 annually, while in addition the buildings and staff of the London Fire Engines establishment were handed over free of charge. B. A government grant of £10,000, $50,000 a year, in consideration of the protection afforded public buildings and offices. C. The produce of a halfpenny rate, 1 cent, on all the rateable property in London, which it was estimated would realize a sum of £30,000, $150,000 a year. It will thus be seen that less than half a century ago it was decided, after careful debate, that the fire control of London could be accomplished for the expenditure of £50,000, $250,000 per annum, whereas today it costs in the neighborhood of £270,000, $1,350,000, or more than 5 times as much, and there is no probability of any finality having been reached. To defray this constant increase, varied legislation was introduced, till the Local Government Act of 1888 virtually repealed any limitation of the amount which might be raised from the ratepayers for fire brigade purposes. Incidentally, it is an interesting historical fact that the year 1865, which saw the birth of the modern London Fire Brigade, likewise witnessed the genesis of the existing New York Fire Department. The first chief of the newly formed organization was the late Captain Sir Eyre Massey Shaw, K.C.B., who, an Irishman by birth, had previously been in charge of the Belfast Fire Department, and whose subsequent 25 years of service with the London Command witnessed the stations of the brigade quadrupled and the strength of the personnel increased from 130 to 700 men. Amongst the more important changes which he introduced were the street fire alarm system and the substitution of telephonic for telegraphic communication between stations. From its formation until 1904, the force was known as the Metropolitan Fire Brigade, when, with the sanction of Parliament, it was designated the London Fire Brigade. The old title was somewhat misleading, since large districts in the London area are outside London County proper, and though on occasion the services of the brigade may be summoned to assist suburban fire departments, it is then entitled to make a pecuniary charge for the same. Thus, for the attendance of a steam fire engine, the scale of payment is a preliminary fee of £2, $10, with an additional £1, $5, for every hour or part of an hour during which it may be working. A fire boat costs as much as £6, $30, for the initial expense of its attendance, each succeeding hour being rated at £1, $5. The manner in which this expense must be borne is clearly indicated in the following excerpt from the official regulations. In such cases, the owner and occupant of the property on which the fire occurs are jointly and severally liable to pay a reasonable charge in respect of the attendance of the brigade. This in itself is sufficiently clear, at least in theory, but in practice there must at times be some difficulty in collecting such charges, in which case presumably the ratepayers of the borough concerned must be held responsible. Without wishing to be hypercritical, it does appear to the writer that such a system is open to grave disadvantages, since it is seldom the destruction of one individual building which is at stake, but rather the possibility of the fire spreading and endangering a large area. On the other hand, it may be argued that those who do not assist in supporting the organization have no right to expect the free use of its apparatus and personnel. Hence it becomes a question beyond the criticism of one not conversant with local conditions. To accommodate the London Brigade, there are 83 stations or engine houses, though in addition there still remain some of the old street stations, wooden shelters in which as a rule are kept extension ladders, and which, owing to the inconvenience they cause vehicular traffic, are fast being superseded. For the extinction of riverside or wharf outbreaks, fire boats are stationed at certain points on the river, their crews being lodged either in adjacent fire stations or in buildings especially erected for the purpose. The general principle determining the distribution of fire stations in London is the necessity of ensuring a. the speedy arrival after a call of life-saving and fire-extinguishing appliances at any spot in the protected area, and b. the concentration of 100 men within 15 minutes in any dangerous location for large fires. On receipt of an alarm, the fire appliances turn out with all possible speed, sliding poles for the men on duty and automatic hitches for harnessing the horses being now of almost universal adoption, and rendering a start feasible within the space of a few seconds. It is the custom for the life-saving appliances to leave first, which on the face of it is humanitarian, though perhaps not eminently practical. Unaided by other apparatus, except under rare circumstances, it can accomplish little. All appliances at the station nearest to the scene of the outbreak are withdrawn for service, leaving one man behind in the watchroom to preserve telephonic communication between the officer in charge at the fire and the district superintendent, while the former has power also to obtain the assistance of the engines located at the station next to his. Arrived at the outbreak, the fire chief classifies it according to its severity and transmits one of the three following calls. 1. The home call, which signifies that he is confident that he can deal with it by means of the apparatus at his command. 2. The district call, which means that more assistance is required but that it can be obtained from adjacent stations. And 3. The brigade call, which is an appeal to headquarters for both men and apparatus. Such a system, certainly, as applied to any city with a considerable fire risk, is open to grave defects. In the first place, the telephone operator left at the station of the first alarm is in a difficult position if another alarm comes in from the surrounding neighborhood, and might well become flurried and misunderstand orders. It is imperative that there should be direct communication between the fire chief and his lieutenants. Otherwise, there can be little hope of effective cooperation. In addition, no provision is made for one engine house to cover another, so that in the event of several fires in the same area, all can be quickly and efficiently attacked. The policy employed appears rather to be one of centralization of men and apparatus, robbed of half its efficiency by roundabout and clumsy means of giving and receiving orders. At any rate, it is certain that in a city like New York, the practice of taking all the appliances from a fire station and leaving it unprotected would be fraught with the most terrible danger to public property, and would, in fact, never be tolerated by those responsible. Local conditions may vary and materially influence fire organization, but the cardinal points of fighting strategy are the same the world over, and, as in regular warfare, one of the most important is ever to be prepared for a flank or rear attack. The present strength of the London Brigade consists of one chief officer, 4 divisional officers, 211 subordinate officers, and 1,163 rank and file, including men under instruction, pilots, and coachmen. Considering the prevailing wages in England, the scale of payments is adequate, starting with £1,000, $5,000 a year for the chief, a maximum of £245, $1,225 for superintendents, while the ordinary fireman receives 35 shillings, $8.75 a week, after qualifying as efficient and passing certain tests. Quarters are provided for single and married men alike, a minimum charge being made for the same, ranging from 4 shillings, $1 per week for married firemen to 1 shilling, 25 cents for single men. Incidentally, it is compulsory to live in these quarters, which are in every case situated over the engine houses. After 5 years of approved service, and less than 15, there is a gratuity of 1 month's pay for each year of such service. Upon the completion of 15 years, 3/10 of the pay then being received is allocated as pension. Those who serve for a longer period receive corresponding increases, until, with 28 years of service, the pension amounts to 2/3 of the nominal pay. In the event of those incapacitated from further service through injuries received in the execution of their duty, a special allowance is made according to the particular merits of the case. Pensions are also allowed to the widow and children of officers and men killed while on duty. The regulations are unusually considerate, in that in the case of a widow remarrying, although her pension is to be suspended from the date of her remarriage, should she for a second time become a widow, it may be restored on proof that her circumstances are such that it is necessary for her support, and that she is deserving of the public bounty. For many years it was customary to enroll as firemen none but seafaring men, but lately this has been modified, and now entry to the brigade's ranks is open to all possessed of the necessary qualifications. As regards promotion, this is limited, inasmuch as the senior officers of the force are usually drawn from the executive branch of the Royal Navy, or are engineers of repute in some specialized section of their chosen profession. This forms a radical difference between the practice not alone of the United States, but of most foreign countries. True, in Germany and France, senior officers are men of naval or military training, but they join the fire service as youths and work their way up through the various degrees of command in a precisely similar manner as they would were they attached to the Army or Navy. But the point is that they are thoroughly trained at every step, and though the system is by no means ideal, it is preferable to the appointment of officers to a highly scientific corps, who, though no doubt able and intelligent men, cannot possibly possess either theoretical or practical knowledge of the subject with which they are called upon to deal. In America, it is no exaggeration to say that every newly enlisted fireman is a potential chief. It depends solely upon the ability and determination of the individual, whether or no he shall rise to a position of executive importance, or whether he shall spend all his days in the ranks. This must prove a powerful incentive to any normal character to go forward and win, and it may be asserted without fear of contradiction that the fireman devoid of ambition is of little use to any fire department. It has been argued time and again that the rank and file are apt to prove insubordinate when one of their number is delegated to be in command over them. Certainly in American fire practice this has never proved the case. Rather, it has been the opposite, and the men have been proud in the success of one of their comrades. Further, in the opinion of the writer, the profession of firefighting is one which demands that those adopting it as a calling should be equally versed in all branches of its requirements, in practice and theory. This entails actual experience in physically as well as mentally fighting fires. It means familiarity with the handling of hose, the management of extension ladders, and that intimacy with fire as an enemy which can only be gained firsthand. It goes without saying that the officer in charge of a battleship's barbette guns is thoroughly conversant with every detail of their mechanism, with their muzzle velocities, with their arc of fire, with the individual merits of their projectiles, be they armor-piercing or high-explosive. In fact, he is a master of craft learned in the school of experience. Why, then, should less be expected of or demanded from officers in charge of equipment with which to fight every whit as dangerous an enemy as ever sailed a sea, when lives unnumbered and property beyond calculation may depend upon their actions, and when it must be remembered that every fight is à l'outrance, without chance of armistice? Turning now to the matter of appliances, the 86 fire stations are equipped with 72 Horst steam fire engines, 3 steam and 15 petrol motor fire engines, 16 mechanically driven fire escapes, 191 ordinary fire escapes, 94 hook and ladder trucks, 11 hose and coal vans, 1 motor lorry, 90 hose carts, and 56 miles of hose, not including a large amount of smaller apparatus. Of the steam fire engines, it is noticeable that some of them, though of antiquated pattern, are still adequate for useful service. Thus, one has been in use since 1878, or over a quarter of a century. All the modern types are double-cylindered, their average pumping capacity being 1 3/4 English gallons per revolution. In every case, axles and wheels are made to gauge and are interchangeable. Some of the engines are fitted with burners for using petroleum as fuel. For a number of years it has been the practice to keep a sufficient pressure of steam in the boilers of all engines to enable a full working head to be obtained in from 2 to 3 minutes after leaving the station. Since 1901, motor traction has been gradually introduced, and although steam-propelled fire engines have not given entire satisfaction and are even now for sale, there is no doubt, as elsewhere, that motor traction has come to stay, and in course of time the horse will be eliminated from the department. As regards ladders, the largest in use by the brigade are those of 82 feet, that being their vertical height from the ground when fully extended. Being heavy and requiring a strong crew, they are used primarily for facilitating fire extinguishing operations. The work of their extension is controlled by a small motor, worked by a compressed carbonic acid arrangement, or in emergency by hand, and being mounted on a turntable fixed to a horse-drawn carriage, they are known generally as turntable long ladders. For regular fire escape work, the ladders used are 55 and 70 feet of the telescopic pattern. Motor escapes are being introduced, but their use has by no means become general. As regards horse-drawn appliances, which are still largely in the majority, the animals are hired from job masters, and the price paid, including ordinary harness, fodder, straw, and stable utensils, amounts to about £70, $350, per horse per annum. The job masters take all risks. At stations where automatic harness is in use belonging to the department, a reduction of 55 shillings, $13, is made. Practically all the horsed escapes are fitted with appliances known as first aid fire extinguishing machines. These consist of a tank containing water connected with a cylinder of compressed air, which, being operated, can maintain a jet for from 4 to 4.5 minutes. There are about 81 of these appliances in use, but the chemical engine per se is unknown. Such additional apparatus as cellar pipes, smoke helmets, and a small number of hook ladders are in regular use. But it is noticeable that the water tower and other forms of heavy equipment are lacking, which is to be accounted for by the low buildings and narrow streets. It is almost a pity that a picturesque survival of ancient days has latterly passed from the London Fire Department. Not many years ago, it was customary for firemen proceeding to the scene of an outbreak to herald their progress by shouting, "Hi, hi, hi!" Some 5 years ago this was discontinued and a brass bell substituted. Some reference may here be made to the floating fire equipment of the London Brigade. This has been developed under peculiarly restricted conditions, since the Thames is a tidal river, with only 5 feet of water in some places at low tide. Moreover, most of the traffic is carried on in heavily laden barges with low freeboards, handicapping fireboats as regards their speed, owing to the liability of their wash swamping the former. Finally, these fire floats are limited as to their length and breadth, since it is necessary so to arrange their dimensions that they may easily enter the connecting locks of docks and canals, while their height above the water line must also permit them to pass under low bridges. Considering the enormous dock area of the Port of London, the greatest credit is due to the officers and men for the ability and technical skill which they display in defending the vast responsibility committed to their charge, which, owing to the conditions already stated, rendered the problem one of the most difficult of solution in the world. The first vessel to be built was the Alpha, a twin-screw boat 80 feet in length with a beam of 16 feet and a draft of 3, on a displacement of 63 tons, and having a speed of 10 knots. It was fitted with pumps capable of discharging 1,250 English gallons a minute. This was succeeded by another handy little vessel, the Beta, equipped with 4 pumps, each with a discharging capacity of 1,000 English gallons a minute at 140 pounds pump pressure. These have been followed by the introduction of motor fire floats, propelled by internal combustion gasoline engines. The latest edition embodies several new principles. With a length of 100 feet and a beam of 19, the draft of water is only 2 feet. She is propelled by triple screws driven by 60 horsepower engines, and the collective delivery of her pumps is about 1,500 English gallons a minute. The screws work in tunnels, and her design is such that when proceeding at full speed, about 11 knots, the bow wave is absorbed under the bottom of the vessel, and little or no wash is apparent. With the object of ensuring that the fire brigade shall be readily and easily summoned when a fire occurs, great attention is being paid to increasing the facilities by which it may be called, and in making them known to the public. Connected with every engine house are fire alarms situated in the chief thoroughfares, the number varying with the fire risks of the area. These alarms are equipped and supervised by the post office, and annual rent being paid for their use, as also in the case of the station telephones. In 1911, the number of these alarm boxes totaled 1,545, and the Council of the Fire Department have a scheme for their augmentation on a large scale at present under consideration. It is worthy of note that a number of posts in the east end of the city have recently been fitted with tablets bearing instructions for their use in Yiddish. All street alarms are adapted for the transmission of telephone messages by firemen, suitable instruments being carried on all brigade appliances for this purpose. The principal police stations are in telephonic communication with the fire stations, and this also exists between the latter and the majority of public and other large buildings, such as theaters and so forth. During 1911, the total number of calls amounted to 6,868, working out at a daily average of 19, though on the 14th of August, during a great heat wave, there were 53. In England, it is a criminal offense to send in a malicious false alarm, and a person so doing is liable to a penalty not exceeding £25, $125, or imprisonment for 3 months with hard labor. From the latest report, it appears that the total of malicious false alarms has increased considerably, amounting now to 357, which constitutes a record. This increase can only be explained by the unwelcome attention of the suffragettes with militant tendencies. It is outside the scope of this work to enter upon a dissertation concerning the rights and wrongs of their movement, but as far as fire duty is concerned, there can be only one opinion. Every false alarm draws men and apparatus away from a certain area, which is thus left so much the less prepared to meet an attack by fire, while it stands to reason that constantly responding to these calls unnecessarily fatigues men and horses and renders them less fit for duty. Hence, the action of these women constitutes a menace to the community and is one of selfish egotism, deserving not alone the condemnation of every right-minded citizen, but the infliction of such punishment as shall render similar behavior in the future, even on the part of half-crazed fanatics, unlikely to occur. There is considerable fluctuation in the number of fires reported annually in London. Thus, in 1907, the total of 3,320 was a decrease of 523 on the preceding year, and represented a financial loss of £493,389. 1908 and 1909 saw the decrease continue, the latter year having 123 fires less than 1907, though the financial loss shot up to £699,329. It remained, however, for 1911 to beat all previous records, the number of fires increasing to 4,403, an increase of 1,195, monetary loss being £789,003, or nearly $4 million. The extended use of motor vehicles has an important bearing both on the outbreaks registered and on the amount of the fire loss, since fires in garages are common and the values involved considerable. Chimney fires are not included in these statistics, though their number averages about 800 per annum. In this connection, it may be remarked that by a special act of 1900, the occupant of any house the chimney of which catches fire must pay towards the cost of the London Fire Brigade a fine fixed upon the rateable value of the premises, ranging from 2s. 6d. 60 cents up to a maximum of £1, $5. The training of the men belonging to the brigade is sufficient for the demands made upon them, particular attention being given to motor engineering, instruction in first aid, and gymnastics. The following excerpt, however, taken from the last official report issued, throws a curious light upon the somewhat haphazard methods employed in the physical training of the men. Early in 1911, the fitting up at the Manchester Square Fire Station of a gymnasium with apparatus for carrying out Swedish drill was completed, and an additional fireman was added to the strength of the brigade to act as physical drill instructor. So much interest was evinced in the matter by the staff that gymnastic apparatus has been provided at other stations, and a number of well-attended classes has been held. There is no doubt that the staff have felt the lack of opportunities for physical training, especially in view of the number of hook ladders carried on fire appliances and the extended use of such ladders. It seems needless to emphasize the importance of constant physical training of firemen, as, quite irrespective of a man's muscular development, he quickly becomes stiff and slow of movement unless either constantly drilled or at least given the opportunity of obtaining gymnastic exercise. As regards loss of life, during the last year for which particulars are available, 151 deaths are recorded, of which no fewer than 62 were those of children under the age of 12. The causes of the fires at which this loss occurred include 12 cases of children playing with fire, 11 from their playing with matches, while 32 were attributable to clothing coming into contact with fire or gas stoves. This infantile mortality of approximately 40% of the total death roll, though in itself insignificant when compared with an estimated population of over 4.5 million, certainly points to the fact that some sort of instruction about the dangers of fire could usefully be included in the curriculum of board schools, as it is done in Germany. By the Metropolis Water Act of 1871, it was provided that the water companies should supply, where necessary, water for firefighting free of charge, while they should also install such plugs or hydrants as might be required at the expense of the department. At present, the total number of hydrants in the metropolitan area is about 29,000. Before 1897, all hydrants in the County of London outside the city proper were made with one outlet. In that year, it was suggested that new hydrants should be provided with two outlets, when erected in localities where the fire risks were considerable. The disadvantage of the double outlet hydrants used in the city itself, numbering over 800 and provided by the city corporation at its own cost, was that in the event of it being necessary to connect a second length of hose to the hydrant when the first was already in use, the control valve had to be temporarily closed. Apart from the delay, which might be fatal, the fireman operating the branch in action was often disconcerted by the sudden stoppage of his water supply, and might conceivably find himself in danger owing to this cause. To obviate this, the Fire Committee of the London County Council decided that the experiment should be tried of placing two hydrants in one pit, each being fitted with a control valve. This scheme proved satisfactory, though on account of the expense involved, its introduction has not been general. In January 1901, however, it was determined that the branch pipes connecting hydrants to mains should in every case be of 5 inches diameter, that is, sufficient to supply double hydrants should they be universally installed. Hydrants fixed in public thoroughfares are tested by firemen every 2 months, and are also examined and tested by inspectors under the supervision of the chief officer. And as a result of deficiency in water supply on some occasions, many fresh connections have been made, and the water companies involved have themselves contributed towards the expense of laying new mains or pipes for fire purposes. The quantity of water used during 1911 amounted to 33 million odd gallons, or not 3 times as much as was used in one fire in New York, the Equitable. 2/3 of this quantity was drawn direct from street mains, the other third being supplied by the River Thames and canals. The double pattern hydrants deliver on an average 800 English gallons a minute, which does not seem excessive when compared with the 4,000 gallons obtainable from the high-pressure hydrants in America. The inspection of public buildings is undertaken by the brigade free of charge, though in certain cases grants in aid are forthcoming to provide for the special staff necessary for the operation. In theaters, in which public performances are regularly given, there is an official inspection every 10 days to ensure that the rules of the municipality for securing the safety of the public are enforced. This applies in a modified form to the cinematograph halls, temporary exhibitions, and bazaars, and the plans of all new buildings requiring licenses and of proposed alterations to existing buildings are referred to the chief officer for examination and report. Lodging houses designed to accommodate more than 80 persons are likewise under the control of the fire department as regards means of escape, etc., and though in the first instance this is the business of the architect, who must conform to the building rules of the London County Council, the responsibility for their efficient maintenance rests with the fire chief. In all, about 22,000 inspections are made annually. Latterly, the underground electric railways which honeycomb London have also passed under the supervision of the chief officer, whose advice has been followed regarding the fire safety of these means of transportation. It is estimated that the cost of this inspection branch amounts to approximately £4,000, $20,000 per annum. No less than 265 officers and men were injured in the execution of their duty during the year 1911, or 1/5 of the whole firefighting strength. This is a high percentage and bespeaks devotion to service, which is in every way commendable. And it must be remembered that it is not always the greatest fire which offers the most risk to life and limb. Thus it will be seen that London is efficiently guarded in its fire hazard, and though perhaps some of the methods employed may appear antiquated and not in accordance with the latest improvements in fire control, yet after all the proof of the pudding is in the eating, and for a city of its population the fire loss is small. Whether or no the department could successfully cope with a great sweeping conflagration in the warehouse district is a moot question, which most assuredly the writer trusts will never arise for solution. But there seems no doubt that the chances of a serious disaster from fire in the residential district are practically non-existent, while the building regulations in force are of so stringent a character that, except in the case of panic, against which no one can guard, fire risks in theaters are reduced to a minimum. In this connection, a word of praise must be added for the British Fire Prevention Committee, a voluntary organization which has devoted time, energy, and money towards the solution of all problems affecting fire control, and which, in the most public-spirited manner, has given the results arrived at gratis to the world at large. In considering the fire departments of the important boroughs in the United Kingdom, one outstanding feature is little short of amazing. This is the small number of personnel as compared with the population and the pecuniary values they are called upon to protect. Of course, the fire risks are appreciably smaller in residential districts than they would be in America, since the houses are commonly constructed of stone, are of limited height, and generally do not offer themselves an easy prey to the flames. But far otherwise must it be in the congested warehouse section, and it is really marvelous that disastrous fires are not of more frequent occurrence. It will be of interest to describe seriatim the brigades of 4 great provincial cities, Belfast, Birmingham, Glasgow, and Manchester. Belfast, the commercial capital of Ireland, is a city of 385,000 inhabitants. During the year 1911, the number of fires amounted to 228, with an estimated fire risk of nearly £1 million sterling, the actual loss amounting to 52,000 odd pounds, $260,000 odd dollars. Yet the strength of the brigade consists only of 75 firemen, including the superintendent, assistant superintendent, and third officer. The plant includes 16 fire engines, 3 petrol-driven escapes, 1 80-foot extension ladder, and various other smaller apparatus, all of which seem to be absolutely up to date. Though it may be remarked that salvage work is accomplished by a petrol salvage motor trap, yet in addition there are 2 horse and 1 motor ambulances, which responded to over 3,000 calls in that year, covering a distance of 10,194 miles and occupying 32 minutes per journey, that is, from the receipt of the call until their return to the station. These ambulances are used for ordinary accidents. The steam fire engines were only used once, and the motor fire pump only twice during the entire year. Machines traveling to and from fires averaged 8 miles for each turnout, and were engaged for 133.5 hours, or an average of 35 minutes for each fire, this calculation including the journey to and from the outbreak. These are remarkable figures, and since within the last 10 years there has been practically no increase in the number of fires, Belfast can congratulate itself upon having one of the most economical and effective systems of fire control, salvage work, and ambulance equipment probably in the entire world. Birmingham, according to the last census, is a city with a population of 840,200, covering an area of 43,500 acres. The fire department consists of a chief officer, 2 senior subordinates, and 194 rank and file, which represents roughly 1 fireman to every 221 acres, or 4,200 persons. 1,048 alarms were received during 1912, of which 108 related to chimneys on fire, 126 were false, and 6 were malicious. The estimated value of the property at risk was over £3.5 million, the actual loss approximating £81,000, $405,000. On an average, these alarms occupied only 37 minutes each, while on 28 days no calls were received, on 67 days only 1, on 75 days 2, on 24 days 6, on 2 days 8, and on 1 day 11. These with some 40 stations and 9,000 hydrants. The police department housed some of the apparatus in their quarters. Amongst the most important appliances may be noted 6 motor turbine pumps and escapes, 12 steam fire engines, 1 water tower, a unique feature in English fire practice, 3 chemical engines, and 21 extension ladders. Like Belfast, there is also an ambulance corps, manning no less than 11 ambulances, while amongst minor apparatus may be noted 9 smoke helmets of the latest oxygen battery type. It is worthy of note that every man in the brigade possesses a first aid certificate for ambulance work. The chief officer of the department receives £400, $2,000 per annum, while ordinary firemen are paid from 24 shillings, $6, to 31 shillings, $7.75 per week. All ranks receive free quarters, light and uniform, 8 pence per week boot allowance, and 6 pence, 12 cents, for washing. Annual leave is granted to the extent of 8 days for a fireman, with an addition of 60 hours a month taken in 2 periods of 24 hours and 2 of 6. All places of amusement are inspected by the department, while public and other buildings under the direct supervision of the brigade as regards fire risk pay a small annual charge, the proceeds of which are devoted to the recreation and superannuation funds. This again constitutes a remarkable record for a small, though excellently equipped department. Glasgow, which since the commencement of 1912 includes Govan and Partick, has a brigade the authorized strength of which is 195, and is at present 15 short of that number. During 1912, engines and firemen operated at 526 fires, while in 110 cases the outbreaks were so trifling that they were suppressed with hand pumps. The estimated loss amounted to £150,000, $750,000. It is noteworthy that fires reported as due to defective building construction amounted to 202, or over 31%. There are 11 stations housing 1 motor extension ladder, 16 motor pumps, 8 steam fire engines, and 2 motor first aid traps. In the entire department there are only 2 horses, which is a sufficient indication that with true Scottish acumen, motor-propelled vehicles have been found cheaper and more effective. Sic transit gloria equi. 4 first-aid motor machines are in course of construction, each being designed to carry 1 officer, 12 men, 2,000 yards of hose, 1 30-foot extension ladder, an ambulance box, tools, and other necessary gear. When fully laden, these motors will weigh about 5,500 pounds, with a length of 19 feet on an 11-foot wheelbase. The number of malicious alarms was peculiarly high, amounting to no less than 59, with only 6 convictions for the same. Attendance at fires under certain conditions must be paid for, and the income from this source amounted to nearly £4,000, $20,000, while listed amongst special services rendered are the 2 following interesting items. Entering houses for locked-out tenants, 120 occasions, and searching the roof of a building for thieves, once. Without wishing in the least to be ribald, the writer cannot help wondering why the duty of assisting burgesses of Glasgow who had either forgotten their latchkeys or, perhaps, such things do happen, had been locked out on purpose, should have been delegated to members of the fire brigade. The worst outbreak of the year was that caused through the ignition of a cinematograph film while in the process of manufacture. The fire was under control within half an hour, but not before damage to the extent of £5,000, $25,000 had been done. This led to an inquiry into the whole subject, and it was found that in one establishment, the basement of which was heavily stocked with this inflammable material, the upper stories immediately above were utilized as a hotel. It is hardly necessary to dilate upon what would have occurred to the guests had a fire broken out. This incident is mentioned since, no matter how well a building may be constructed, danger of this sort cannot be invited with impunity, especially when the personal safety and property of 785,000 people rest upon 180 firemen. The report of the Manchester Fire Brigade is again remarkable for its brevity, and for the fact that the authorized strength of the force is only 130, including officers, for a city of 715,000 inhabitants. All the world knows that within this area are to be found some of the greatest cotton-spinning factories extant, and to the outsider it certainly would appear as though the firefighting force could not be adequate for possible demands. For instance, supposing there were 3 outbreaks of even a moderate size in different parts of the city at the same time, a perfectly normal contingency to contemplate, how could they be successfully attacked? The 524 fires of the year 1912 represented a property value of over £3 million, $15 million, though the loss was only £102,000, $510,000. The firemen were actively engaged during the entire year for 320 hours, 35 minutes, this including false alarms, or under an hour a day, while the fireboat responded to 7 calls and was actively engaged on only 3 occasions. Now, it may be argued that the 4 men forming the crew of the fireboat, or the 112 men rated as firemen in the brigade, earn their pay with an absence of worry or anxiety which might be envied by the layman. In fact, doubtless the ratepayer reads the report in question and contemplates the payroll dubiously, revolving the while in his mind whether the total expenditure is justified, or whether, after all, it is not a piece of gross municipal extravagance. The answer is not a difficult one to give. When a man insures his life, he pays a premium for certain benefits, of which perhaps he may never taste, but on that account he does not cease his payments. Similarly, with all outlay for all contingencies, there is no direct and immediate return that can be touched, handled, and assessed at so much material value, but nonetheless the value is existent, though not perhaps to the extent demanded by a captious ratepayer. It is, in short, a payment for municipal fire insurance, and though day after day and month after month the protected area may jog along with no serious outbreak to trouble the even tenor of its way, the time may come when every man and every piece of apparatus will be engaged in a life-and-death struggle for mastery, and it is precisely against that event that the municipality which is far-sighted guards. Hence it is that, with the greatest of deference to those concerned, it does strike the writer with something akin to amazement that such colossal values should be so lightly guarded as they apparently are in English provincial towns. For given the best of appliances and the most skilled firemen, what could 130 men accomplish against anything in the nature of a sweeping conflagration? And supposing other fires occurred at the same time, it would be a physical impossibility adequately to protect against the one or attack and quell the other. As an example, it is not necessary to travel beyond the British Isles. In August 1911, there occurred a serious fire in the Carlton Hotel, London, a building of moderate size, and certainly of no greater magnitude than some of the hotels to be found in the towns, mention of which has been made. This outbreak necessitated the employment of 23 steam and motor fire engines and the attendance of 202 officers and men before it could be brought under control. Had this occurred in Manchester, well, it is needless further to comment. This is penned in no carping spirit, and with the knowledge that man for man English fire departments are the equal of any in the world. But they cannot accomplish miracles, and rather are the municipalities to blame, who, secure in the traditions of the past and unmindful of the chances of the future, are so penny-wise and pound-foolish that they are ready to risk millions of pounds' worth of property in order to escape an infinitesimal addition to their rates. Place the whole question on a business basis. Work out the value of the fire insurance premiums paid on the property within the municipal area, and compare the total arrived at with the total expenditure per annum on the fire departments under discussion, and the result will perhaps surprise owners and insurance companies alike. Of course, it may be argued that it belongs to the business of the latter to assess their own risks and avoid the acceptance of policies in badly protected areas, but that is outside the main discussion, which is concerned with the ethics of firefighting, and most assuredly he would be a bold man who would prophesy that fire would never conquer under such conditions. End of Section 17. Recording by Maria Kasper. Section 18 of Fires and Firefighters by John KENLON. This LibriVox recording is in the public domain. Chapter 17. The New York Fire Department. An experience of a quarter of a century as an active firefighter has left one indelible impression upon the brain of the writer. It has been his good fortune to meet professional colleagues hailing from every known part of the globe, while equally he has had abundant opportunity to inspect the fire departments of the great American cities, as well as those maintained by European municipalities. And one point in common he has found them all to possess, namely that they are firmly convinced that they belong to and represent the latest, the greatest, and the most up-to-date fire department in the world, which is to be expected. If a mother be not proud of her offspring, who should be? And that very enthusiasm itself speaks well of the calling as a whole, and is a sufficient proof that its votaries bring to bear upon their occupation all that interest which is necessary to make of a chosen life work a success. Hence there really is no need to haggle over the respective merits or otherwise of different fire departments. The main point is that they are one and all imbued with the same fighting spirit, and one and all are allied against the same common enemy. But in the following pages will be found some description of the New York Fire Department, and the writer is quite content to leave to the verdict of others a decision as to whether or no the city is well protected against the fire fiend. Since, however, his is the honor of being its present chief, he must be forgiven for stating at once that it is, as regards personnel and apparatus, unquestionably the largest in the world. And well it may be, for it is called upon to guard property values beyond conception, from which certain local peculiarities are, in a measure, heaped together in a limited area, and which offer to the firefighter problems the solution of which are literally staggering in their immensity. It is well nigh impossible to describe with pen and paper, for the benefit of those who have not seen it, exactly what New York means. Most cities of renown convey certain vague impressions to those who have never visited them, and only know of them by repute or from what they have read. Thus, Rome conjures visions of a bygone era of imperial greatness, manifested in wondrous churches, palaces, and remains of historic interest. Paris speaks of a gay life, restaurants, pretty women, a continual effervescence of amusement, with the serious side of life carefully hidden away in the background. St. Petersburg visualizes mentally snow-capped domes surmounting fantastically constructed cathedrals, nihilists, an eternal carnival of disorder, and in the foreground thousands upon thousands of grey-coated soldiery. As for London, without any intention of hurting the feelings of the British, fog, royal display and pomp, old and venerated buildings, art collections, military music, and suffragettes. Now, each and all of these figments of the imagination possess that grain of truth which goes to show that years of descriptive writing have at least brought home to the public mind some regularly formed impression anent the places mentioned. Now, far otherwise is it with New York. As the foreigner who has never been to America, what are his impressions of this great city? He would probably promptly reply, giant buildings, and then pause. Perhaps, after a moment's consideration, he might add, with a half-apologetic air, and a very expensive place. Further than that he could not go. Although viewed in certain aspects, New York has the most strongly marked individuality of any city on the face of the globe. In the first place, it is as though some giant contractor had constructed a plaything for the gods, and had thrown vast piles of stone, mountains of brick, forests of wood, and lakes of mortar onto the surface of one small island, and had then fashioned therefrom buildings. There is no coordination, no attempt at architectural regularity. The wand of the magician waves, and instant a giant structure rises from nowhere, and in an inappreciable space of time a new skyscraper is silhouetted against the horizon. The skyline alone is worth a trip across the ocean, so replete is it with fantastic wizardry, and comparable only to the Organ Mountains as they loom out of the morning mist in the harbor of Rio de Janeiro. But these aspects are rather for the brush of the artist. There is the other and practical aspect, which in its way is as enthralling. The population of New York is roughly 5 millions, and every day in the year 1/2 of that number are on the move. They pour into a circumscribed area like water into a bottle, and as the number increases, so, like the aforesaid water, they mount higher and higher, as though they would overflow into the regions of the upper air. The office buildings lead the way in the race for height, and story by story climb, 5, 6, 7, and almost 800 feet in a search after floor space. There are about 140,000 separate manufacturing concerns in the city area, and many of these are housed in buildings 16 and 18 at a time, a perfect miscellany of diverse trades dealing in every conceivable article, inflammable, combustible, or burnable. Hotels there are by the thousands, theaters literally by the hundreds, 900 moving picture shows, some 500 miles of docking and wharfage, and innumerable ships and cargoes, the value of which it is impossible to assess, and in any case, after a certain point, the mind refuses to comprehend the meaning of the recurring ciphers. But billions of dollars, millions of pounds sterling, may approximate to the fire risks which have to be covered by the New York Fire Department. Multiply this enormous aggregate of values by the extreme climatic conditions, which in themselves invite the attention of the flames, and the magnitude of the task is enhanced. Then again, multiply the result arrived at by the fact that business with a capital B is the magnet which draws people to this center, the hunt after that elusive dollar which absorbs all the nerve power, the intellect, and the interest of the average individual, leaving him no time for the consideration of the casual outside occurrences of daily life, and tending to make of him a machine rather than a man. That is where the carelessness of the unit may be expected to evidence itself, and that in itself is one of the most comprehensive of fire risks imaginable. Thus it will be seen that the fire guardians of New York have enough to do in their daily battle against the fire fiend, and that personnel and equipment must both be of the best obtainable if the enemy is to be held effectually in check. Firstly, as regards personnel, the force is recruited from the state of New York, and since apparatus, without skilled men to operate it, is useless, the place of honor will be given to the means employed to attract the best material, and how the service may be entered. The following form the basic qualifications. No person shall be appointed to membership in the fire department, or continue to hold membership therein, who is not a citizen of the United States, or who has ever been convicted of a felony, nor shall any person be appointed who cannot read and write understandingly the English language, or who shall not have resided in the state 1 year immediately prior to his appointment, or who is not over the age of 21, and at the date of the filing of his application for civil service examination was under the age of 29 years. Every member of the uniformed force shall reside within the limits of the city of New York. Preliminary to a permanent appointment as fireman, there shall be a period of probation, for such time as is fixed by the civil service rules, and no person shall receive a permanent appointment who has not served the required probationary period. But the service during probation shall be deemed to be service in the uniformed force, if succeeded by a permanent appointment, and as such shall be included and counted in determining eligibility for advancement, promotion, retirement, and pension, as hereinafter provided. This is sufficiently exhaustive as showing the first main essentials to be covered by the applicant for fire service. In addition to the foregoing, however, candidates must take a civil service examination, the physical and mental tests of which are as follows. As might be expected in such a calling as the fireman's, the physical test is in itself severe and searching. It may be said to be divided into 2 parts, the medical and the muscular development examinations. These are widely divergent, as the following shows. For the former, the candidate faces the doctors nude, prior to his entry into the examination room, having taken his oath that he is who he states he is, and that he has answered all questions which have been put to him truthfully. The applicant is then carefully examined for such defects as varicocele, hydrocele, or any other kindred blemishes, while, needless to say, any signs of venereal disease are met with peremptory rejection. Should he have any obstruction to free breathing, chronic catarrh, or even offensive breath, he may fail to pass. The teeth must be clean, well cared for, and at least 20 natural teeth must be present. In addition, any affections of the joints, sprains, or stiffness of the arms or legs, hands or feet, ingrowing nails or hammer toes, are especially looked for, and promptly bar the applicant, since they would effectively prevent him from performing his duties in the manner demanded. It seems scarcely necessary to add that a rupture also receives particular attention, and any signs of incompletely healed laparotomy are noted against the applicant. Finally, the body must be well developed and nourished, and show careful attention to personal cleanliness. Following this, the candidate next visits the first physical examiner, who tries his eyesight and takes his chest and other measurements. The minimum weight required is 140 pounds on a height of 5 feet 8 inches. Then comes a stringent examination of the heart, and, incidentally, it is surprising, considering the age and physique of the applicants, how many have murmurs or some heart symptom, which, in themselves probably not serious for most careers, are quite sufficient to prevent entry into the ranks of the fire department. This concludes what may be called the purely medical aspect of the case, with the addition of certain questions regarding past medical history, framed on a plan not unlike that drawn up by insurance companies. The hour for the active physical test has now arrived. That it is severe may be gathered from the following particulars. Firstly, the strength of the upper arms is tested by the pull-up, or chinning as it is called. The candidate is required to hang in a suspended position from the rung of a horizontal ladder by his hands, and pull himself up until his chin is above the rung. A limit of 14 times has been placed upon this operation, which would give a sufficient grueling to most professed athletes. Next comes the dip, or supporting the body by arms on horizontal bars, and then lowering till the chin is level with the hands. This must not be accomplished more than 6 times. A dynamometer is used to test the strength of the forearm, pectoral muscles, joints of the knees, back, and legs. Considerable importance is attached to these readings. A 60-pound dumbbell must also be lifted to the shoulder, and thence above the shoulder with each hand in turn. Finally, the agility of the candidate is tested in a variety of ways, jumping being that most usually employed. Now, it might be imagined that the only result of this extreme physical trial would be the elimination of all except giants and abnormalities, which most assuredly are not wanted. What is required is all-round physical excellence, and to this end marks are given according to the stamina shown by the individual in the different tests and his familiarity with the same. But the outstanding point to be made is that, obviously apart from being in sound health, it is not by any means the strongest man who always makes the best rating. The youth who has been gymnastically inclined will be familiar, of course, with such exercises as chinning and dipping, and in that way will score. But it also shows that he has been in the habit of taking the best form of exercise, and this in itself promises a deal. Mens sana in corpore sano might not inaptly be applied to the department, since the science of firefighting is a profession demanding brains as well as brawn. As has already been stated, the mental examination is reasonable considering the training which is to follow. It consists of a thorough knowledge of the 3 R's, reading, writing, and simple arithmetic. The examinations are, however, competitive, and are rated on a basis of 50 to 50, that is, half for physical and half for mental. It has been the practice during the last few years to appoint from these candidates in numerical order. Although the Fire Commissioner has some discretionary powers under the law, and may reject a certain percentage of the names certified for appointment. Unless a candidate has developed some serious defect between the promulgation of the list and the date of appointment, The plan of accepting men in numerical order is followed. In order to detect whether such defect exists, the applicant is thoroughly examined by the medical officer of the fire department at the time he is about to be appointed. Should he pass all tests, he is appointed on probation for a period of 3 months, and is immediately assigned to a company. It is thought best to assign probationers to active duty at once, and in the heaviest and hardest districts of the city. A 2-year service is required in these districts before a fireman is permitted to transfer to a lighter one. He is required to attend daily between certain hours at the college training school for probationers, there to undergo a thorough course of instruction in the use of scaling and other ladders on a building more than 100 feet in height. He is taught the use of every tool in the 8 branches of the service: hook and ladder and engine companies, water towers, hose and chemical wagons, fire boats, and so forth. Besides this, he is instructed in the use and making of approved knots, such as the bowling knot, rolling hitch, the half hitch, and others. Also, he is instructed in the use of life-saving apparatus and jumping nets. In addition, he must learn and become proficient in sending and receiving all fire alarm signals. In some countries, it is thought best to instruct the men before sending them to companies for regular duty, and even officers, as already stated in this volume, attend fires as spectators. To the writer, this system does not appear to possess any advantage. In fact, practical experience has proved that it is better to throw the men at once into the thick of the fight. If they have any tendency to show the white feather, this method speedily brings it out. But to the credit of the New York firemen, be it said that in more than 20 years, during which time over 5,000 men have been subjected to this ordeal, not more than 10 have jibbed. The reason why so few are found deficient in these tests is simple. They are aware of the conditions beforehand, and this fact eliminates the cowardly and the timid. Once appointed to membership in the uniformed force, a young man can reach the highest position in the department, always, however, subject to competitive examinations. In these examinations, record and seniority count 50%, and mental qualifications the same. As regards the former, rank takes precedence of service. A mark of 80% is given for the first 6 months in a grade, and 0.5% for each 6 months thereafter, up to 8 years, when a full mark is given. This brings the rating to 96%. The additional 4 points being reserved for merit marks, Class A or 1, and a medal receiving 3 points, Class B or 2, equaling 2 points, and Class C or 3 equaling 1 point. These points are subject to change by the Municipal Civil Service Board with the consent of the Mayor and the State Civil Service Board. The total strength of the uniformed force of the department amounts to 4,995 men of all ranks, including, besides the chief, 15 deputy and 47 battalion chiefs, 11 medical officers, 298 captains, 413 lieutenants, 20 pilots, 496 engineers, 6 marine engineers, and 3,687 firemen of all grades. There are, in addition, 1 chief of construction and repairs, 2 Roman Catholic and 2 Episcopalian chaplains. Upon being appointed to 4th grade firemen from probationers, men receive $1,000 per annum, being a year later advanced by law to the 3rd grade with the same salary, and thereafter by law to the 2nd grade with $1,200 a year, and thence to the 1st grade, then receiving a salary of $1,400 a year. Thenceforth, the progress of the individual is strictly dependent upon his success in competitive examinations. Thus, by taking practical tests, he may qualify as an engineer with a salary of $1,600 a year. A fire engine is taken to the waterfront and placed at the dock, drafting water. Candidates are required to operate the engine in the presence of engineers representing the civil service, and are rated up to 50% according to the ability shown. A mark of 70 is required to pass this test. The mental test which follows is a written examination counting 50%, a passing mark of 70% being required. When both tests are combined, the candidate must have at least 80% to entitle him to be on the eligible list. Or, again, he may follow the mainstream of promotion, becoming first a lieutenant with $2,100 a year, and after 6 months may rise to be a captain with a salary of $2,500 a year. With 6 months' service to his credit in this grade, he is eligible as chief of battalion, in which position he takes charge of 6 or 7 companies and receives a salary of $3,300 per annum. Ranking with the latter are doctors, chaplains, and the chief of construction and repairs. Incidentally, it may be of interest to note that the chaplains are provided with a departmental horse and buggy for the purpose of attending fires at which their services on occasion are greatly appreciated. The next step of promotion is to that of Deputy Chief of Department, with whom rank the 2 veterinary officers and the Chief Medical Officer. The Deputy Chief of Department in charge of the boroughs of Brooklyn and Queens, owing to his greater responsibilities, receives a salary of $7,500, the chief receiving $10,000. Since the vacancies in each rank are limited, a list of candidates eligible for promotion is drawn up and remains in force from 1 to 4 years, when the list is closed. This is to enable the younger men to have their chance and to prevent their promotion from being blocked indefinitely. Without going too deeply into the subject of examinations, it may be not without interest to give 2 or 3 specimen questions taken from the examination papers for promotion to lieutenant, which will be sufficient evidence of the thoroughness and searching nature of this examination. 1. Assume that a fire has broken out on the 12th floor in the rear of a modern 20-story fireproof building, 100 feet deep, elevators 30 feet from the front. The room where the fire started is 30 by 50 feet and is filled with a number of old desks, rugs, partitions, and other furniture of a highly inflammable nature. Intense heat has developed before the firemen reach the scene, and the fire has worked its way into adjoining offices on the same floor. A. What are the special dangers to be apprehended from such a fire? B. What special precautions would you take to avoid loss of life? 2. In answering the following, candidates will show the methods used in arriving at the answer given. There is a large fire in a building 100 feet high from the curb to the cornice. The sidewalk is 10 feet wide, and the street from curb to curb is 30 feet wide. A pipe holder is placed against curb on the opposite side from the fire. You are required to deliver an effective stream of water to the top floor. You are using 300 feet of 3-inch hose with a 1.5-inch nozzle. What is the approximate distance from the nozzle at the curb to the top story windows, allowing 10 feet to a story? What pressure would you require on the nozzle? How many gallons of water would the nozzle discharge per minute? And what would be the required pressure on the engine or hydrant to maintain this discharge? 3. What is the duty of the commanding officers upon arriving at fires where the buildings have automatic sprinkler equipments? After the first line of hose has been stretched in at a fire by an engine company, and a second line of hose is required, what do the rules demand commanding officers to do? It goes without saying that such technical knowledge cannot altogether be acquired by practice alone. There must be a sound theoretical training to amplify the latter. And to this end the Fire College was instituted in the year 1911. It may not inaptly be compared with the Staff College of an army, since all those joining it must be officers who wish to qualify along certain highly specialized lines. But the simplest method whereby an idea may be gained of its scope is to quote from the words of its charter: "To disseminate knowledge of firefighting, to establish and maintain the highest professional standards, and to afford to men starting in the profession of firefighting the experience of men who have devoted their lives to the profession." Included in the courses are general firefighting, use of apparatus and tools, engines and boilers, high-pressure system, marine fires, care of horses and hose, high-tension electric currents, combustibles and explosives, gasoline and motors, fire alarm telegraph, auxiliary fire appliances, first aid to the injured, discipline and administration. Instruction is given by a detail of officers, but special lectures are delivered by distinguished professors from New York colleges, while the president is always the chief of the department. As a company is the unit of action at a fire, and as collective work is of more value on these occasions even than in war, the company school has been made a feature of the college work. From this it must not be gathered that the intelligence of the individual is not taken into account. Many times a man is thrown upon his own resources, where he can neither see nor hear the signals of his superiors, and care is taken in his training that his individuality and initiative shall not be repressed. The school is attended by companies, and complicated evolutions are performed. Each year a competitive drill is given which is required to be accomplished within a specified time, and the men of the company most successful in time and form receive a college medal, while the captain is given a special medal for the best drilled and most effective company. Some idea of the evolutions in one of the recent tests can be gleaned from the following. There were 20 tests which took place on and in a building 100 feet in height and of 9 stories. A. Stretch a 3-inch line from high-pressure hydrant, connect to the standpipe floor valve inside of the building. The outside connection is out of order. Winning time, 41 seconds. B. Raise and operate an aerial ladder. Winning time, 50 seconds. C. Hoist a line to the roof from the outside of the building. Make the line fast under the cornice and on the roof with approved knots. Winning time, 1 minute 13 seconds. From these figures it can be gauged that the New York fireman is second to none in speed of operating apparatus. There is, in addition, a large civil department, which is responsible for such auxiliary bureaus as the Fire Alarm Telegraph Bureau, which totals 133 men, including 30 telegraph operators, 14 battery men, and 32 linesmen. The Fire Prevention Bureau, which is charged with the making of inspections, the cleaning away of rubbish, etc., and includes within its scope the division of the fire marshal, who is responsible for inquiring into the causes of fires and for procuring evidence in cases of arson. In addition, there is a large Bureau of Repairs and Supplies, which totals no less than 251 employees, ranging from clerks and stenographers to painters and even a sailmaker. The administrative head of this vast organization is the Fire Commissioner, who is a nominee of and appointed by the mayor. In fact, he may not inaptly be compared with the departmental secretaries of any national administration. That is to say, with a change of municipal government, ipso facto he vacates his position. Quarters are provided for all members of the uniformed force at the stations to which they are attached, 4 hours daily being allowed for meals. In addition, every fireman is entitled to 14 consecutive days vacation leave in the year, together with 24 hours each 5th day, while company commanders have it in their power to grant extra leave of 12 hours 4 times each month, should the exigencies of the service permit. The regulations regarding pensions are both comprehensive and generous. Any officer or member of the uniformed force who may, upon an examination by medical officers, be found to be disqualified, physically or mentally, from the performance of his duties, shall be retired from the service, and shall receive an annual allowance as pension in case of total disqualification, or as compensation for limited service in the case of partial disability. In case of total and permanent disability caused or induced by the actual performance of the duties of his position, or which may occur after 10 years' active and continuous service, the amount of annual pension allowed shall be 1/2 of the yearly compensation given as salary at the date of his retirement from the service, or such less sum in proportion to the number so retired as the condition of the fund will warrant. This fund is formed of certain revenues allocated for this purpose, and any deficit is supplied by an appropriation from the city. In any case, widows and children of men killed in the execution of their duties are cared for, and members wishing to retire after a period of 20 years' service receive a pension equal to 1/2 of their salary. The city of New York is divided into 5 boroughs: Manhattan, the Bronx, Richmond, Brooklyn, and Queens, the 2 former being separated from the 3rd by the Bay, and from the 4th and 5th by the East River. For fire protection, the department consists of 298 companies equipped with 877 pieces of apparatus, including engines, hose wagons, hook and ladder trucks, fire boats, searchlight engines, water towers, etc. Motorization of all apparatus is proceeding rapidly, and by the end of 1914 the horse will be practically superseded. Of the operations of the department as a whole, some idea may be gleaned from the fact that between January 9th and March 1st, 1912, New York literally burned day and night. One period of 24 hours in February of that year witnessed 100 calls. This tremendous activity on the part of the fire fiend was due to some extent to the extreme cold, the thermometer registering 0 practically the entire time. But judging from the revelations recently made, the firebug played no inconspicuous part in this state of affairs. It is the custom of the New York Fire Department never to leave a fire station uncovered, and in case of outbreaks of any magnitude, apparatus from distant stations takes up its position in the station vacated. This system will be understood by an examination of the accompanying card. All companies in the first horizontal line respond on the first alarm, that is, when the street alarm is pulled by a citizen or a policeman. All companies and officers on the second line respond on the second alarm, which is transmitted in the following manner. Should the chief in charge at a fire find the outbreak to be beyond the control of the apparatus of the first assignment, he then orders the transmission of a second or third alarm. This is always done by an officer or by an aide to the chief officer. For though the alarm box may be opened and pulled by a citizen, in order to send additional calls, an inner door must be opened, to which none but officers or aides have access. The mechanism within this door resembles the apparatus in use in a telegraph office, and the officer will send in his call by tapping 22279, meaning a second alarm at station 279. A third, fourth, or fifth alarm is sent in the same manner, merely changing 22 to 33, and so on. It will be seen by the card that on the third alarm, in this instance, Engine Company 16 takes the places of Engine Company 17 in the latter's station, and Engine Company 26 fills up the gap left by Engine Company 14. Similar changes occur on the fifth alarm, and Hook and Ladder Company 21 covers in for Hook and Ladder Company 3. If the fire happened to be of such magnitude as to demand an even greater force than would respond on the fifth alarm, distant companies in the same borough can be summoned by sending what is known as a simultaneous call, or what firemen term the 2 9s. The call is, to give an example, 99279-33582. This means that all companies due on the third alarm at signal box 582 would immediately respond with all apparatus to signal box 279. In lieu of this can be sent the borough call, which has exactly the same effect, but the signal is varied to denote the borough from which the apparatus is required, which, in the case of the Equitable fire, was Brooklyn. In this instance, it will be readily understood that there is no object in sending 5 miles north on Manhattan Island for companies when the same force was just 1 mile away across the Brooklyn Bridge. Should the borough call be used, it would be 77279-33394, indicating that the companies assigned on the third alarm at Station 394 Borough of Brooklyn would immediately respond to Station 279 Borough of Manhattan. 66 denotes Manhattan, 77 denotes Brooklyn, and 88 Richmond. There are 3,176 street fire alarm boxes and roughly over 5,500 special and automatic signal boxes located in factories, public buildings, theaters, etc., and approximately 1,969 miles of underground conductors, while by the end of 1914, the 2,530 miles of overhead cables will also be laid in the former way. The fire alarm stations are situated as far distant from the scene of any possible outbreak as is practicable, those at present in the course of construction being located in the public parks of the various boroughs. The department is housed in 326 buildings, and every year sees an addition to their number. In 1912, there were 15,633 fires, as against 13,868 in the previous year, the total fire loss for the former year being $9,069,580, as against $12,470,806 for the latter. Occasionally, in the preceding pages, the reader may have thought that the writer was complaining of the position held by the firemen in the public esteem. Certainly it is true that the profession is of modern growth, and as such has not behind it those centuries of glorious record which make citizens of every nation proud of their army and navy. But inasmuch as New York possesses the largest fire department in the world, and inasmuch as its uniformed force is called upon to combat a greater fire risk than anywhere to be found, then most assuredly is this fact recognized by its inhabitants. It is no exaggeration to say that no force in the United States, federal, state, or municipal, stands in more sympathetic relationship to the public. An English friend of the writer's, who knew the department well, was asked what he thought of it as a whole. He replied, "Well, the greatest compliment I can pay is to put them on the same plane with the London police, whom I consider the most efficient, best-mannered, and with all the kindliest force it is possible to imagine." It goes without saying that the writer is proud of his command, proud of their actions, which are engraved in the hearts of the people, and proud to think that Providence has permitted him to be their chief. End of section 18. Recording by Maria Kasper. Section 19 of Fires and Firefighters by John KENLON. This LibriVox recording is in the public domain. Chapter 18. Seaport Problems. The problems confronting fire departments in seaport towns in America are of a nature so widely divergent from those needing solution in Europe that a few explanatory words are rendered necessary. As a general rule, tidal influences and depth of water play so important a part in Europe that it has been obligatory to construct docks which shall always be possessed of a certain depth of water. There is no need to labor the obvious point that this has entailed harbor construction on a gigantic scale, involving in many cases the expenditure of millions of money. In this respect, the Atlantic seaboard of the United States has been peculiarly fortunate, and it is possible, with rare exceptions, to berth the average steamer alongside a wharf projecting directly from the shores of the river, bay, or estuary. This, of course, spells cheapness, celerity in dealing with cargo, and a certain amount of convenience for passengers in transit. But on the other hand, it has tended most distinctly to increase fire risks. In the designing and building of docks, the greatest of care and forethought is naturally exercised in the safeguarding of buildings from fire, if for no other reason than the difficulty that must be experienced in successfully mastering outbreaks in congested areas dependent upon their ingress and egress for the state of the tide. Shallow draft fire floats have been constructed for this special purpose, but their capacity and radius of action are obviously limited, and hence any comparison between American practice and European methods is out of the question. The sheds or wharves common to America form about the most dangerous structures of their kind in existence. Built on wooden piles with wooden superstructures, they are comparable to nothing but horizontal flues, through which flames rush with a lightning-like rapidity, rendering abortive any efforts on the part of the fire department unless the greatest promptitude is shown by all concerned, and demanding the use of fire boats with specially designed and extraordinarily powerful equipment. Fill these sheds with every sort of combustible material imaginable: hogsheads of resin, bales of cotton, crated furniture, barrels of pitch, stacks of dry goods, and such unconsidered trifles as a few boxes of celluloid toys and novelties, and can the mind of man conceive a collection of heterogeneous merchandise more calculated to provide the wherewithal for a conflagration, and matter enough to assuage the thirsty pens of all the newspaper reporters in the town? Yet this represents an everyday condition in an American port, and it is perforce necessary not only to guard this property, but to calculate the even more important risk, namely, should fire occur, the danger of its spreading to adjacent dwellings. Hence, even the inexperienced lay mind can easily grasp the vital significance of fire prevention under such circumstances. But incidentally, there is yet a further consideration demanding attention: the possibility of a fire occurring in a vessel moored alongside one of these piers. Fire risks on shipboard are appreciably greater in harbor than at sea. Discipline is relaxed, and sailors and stevedores are human. After a hard morning's work, a pipe of tobacco or a cigarette is a welcome solace to the most ascetic of individuals, and a carelessly thrown match, or the residue of a finished pipe, is all that is necessary to start a blaze which shall, in one fell swoop, destroy ship, cargo, wharf, and men. In addition, though this may be scarcely credited, merchandise, particularly cotton, is often on fire before it is loaded, in which case it is absolutely a matter of luck where the outbreak occurs. Therefore, it behooves wharf masters and captains to exercise the most stringent supervision over the goods they are handling. These are some of the complexities which face the master mind of the fire department, and be it remembered that no matter whose the initial responsibility, if a fire gets out of hand, criticism and perhaps blame will be apportioned liberally to the department whose services have been requisitioned to overcome the errors and carelessness of others. To meet such contingencies, the first essential is a flotilla of well-equipped fireboats, numerically sufficient for the demands of the harbor they are to defend. Much depends upon the architect chosen to design them, and he should be given a free hand and be untrammeled by petty restrictions, though, needless to add, he should be a master of his craft, while too much emphasis cannot be placed upon the prohibition of untried innovations. These latter may result in serious loss of life and property. It is commonly held that fireboats should be of the twin-screw type, this as rendering them more handy for maneuvering in narrow, crowded channels. But the twin-screw boat is more expensive to maintain and operate, and since economy is the watchword of municipalities, it has been found expedient to evolve a design the turning circle of which, with a single screw, approximates to that obtained by two screws. Shorn of scientific formulae, this consists in constructing the keel of the vessel from the midship section aft along a rising gradient, thus bringing the turning point well amidships, so that the boat can answer her helm almost as though she were on a pivot. In practice, this type of construction has proved eminently successful, eminently economical, and in all respects satisfactory. The writer has had little experience with the turbine engine as a method of propulsion, but at present, while excellent for driving pumps, certain difficulties over a satisfactory reversing gear render this system, in its existing state of development, useless for propelling fireboats. Naturally, of greatest interest to firefighters is the question of the pumps, their style and capacity. For as long as the driving engines are of the best compound type, engines of this construction are more easily heated than those of triple expansion, and hence are of more general use in fireboats, there is no particular specification of propelling machinery to be recommended. Many boats of old design are fitted with reciprocating pumps and have done and are doing excellent work. But it is almost impossible to obtain boilers capable of operating the latter at their full capacity, say of 10,000 gallons a minute. It resolves itself into a question of piston speed, and it has been found that under working conditions the steam supply estimated to obtain the same as predetermined rarely accomplishes its task. Now, centrifugal pumps can do the same work with half the steam, and hence, with care, this should enable a boat to maneuver and at the same time to run her water battery to full capacity. The total volume of the streams per minute, in the opinion of the writer, should amount to 7,500 gallons of seawater at a pressure of 185 pounds per square inch. As far as actual deck equipment is concerned, the main feature is the emplacement of two circular turrets, each operating 9 separate streams of water and surmounted by a turret pipe, through which a powerful jet of from 2 to 3 inches can be thrown. The old style of running a water circuit around a boat represents considerable weight, causes confusion, and adds to labor. The turret concentrates the work and is better adapted for the supervision of the officer in charge. Provision for a water tower can be arranged by constructing the mast on the military lattice girder system, surmounted with a fighting top platform, so designed that not only can 2 turret pipes be operated therefrom, but also a number of smaller jets, which may not inaptly be compared with the machine guns of the battleship. This system has been found most effective in fighting warehouse and pier fires. Boats should be kept under steam at all time in order that there be no delay in starting. In New York, where there is a large fire flotilla, it has been found necessary to organize the same into a homogeneous unit, the better to ensure its efficient cooperation. The chief of this marine battalion responds to fires in a steam launch and commands on the water side. A code of signals has been established by means of the siren whistle, and in this way orders are transmitted from the chief over a considerable distance, even though the smoke be heavy and the boats invisible. Above all, the personnel of these craft should be accustomed to the handling of boats, if not actually sailors. They must be alert, active, and intelligent. While it is obvious for economical reasons that the engineers and their assistants should be highly qualified, otherwise constant repairs will keep the boats out of commission and entail vexatious expense. One of the most terrible disasters which well exemplifies the perils of wharf fires occurred on Saturday, June 30th, 1900, at the Jersey side piers of the North German Lloyd in New York Harbor. At 4 in the afternoon on that eventful day, while hundreds of curious visitors were inspecting the 4 latest additions to the German line, a fire broke out amongst some merchandise on Pier 3, alongside of which the steamer Sail was moored. The origin of the outbreak is obscure, but it was probably caused by some unconsidered act of carelessness, either on the part of an employee or of one of the sightseers. Be that as it may, in less than 15 minutes, the flames, fed by stores of cotton, turpentine, and oil, which were lying unprotected on the docks, swept with inconceivable speed from pier to pier, and before the immensity of the outbreak could be realized, an area 1/4 mile square had been devastated. A strong breeze was blowing from the southward at the time, and to this the staggering rapidity of the conflagration was no doubt partially due. Now, it must be clearly understood that, owing to a curious anomaly, the New York Fire Department, including its fire boats, had at that time no jurisdiction in the state of New Jersey, and hence was unable to afford any assistance to the vessels in distress until they were in the open stream and upon, so to speak, neutral waters. Then everything was done which science, skill, and daring could suggest. In view of the disastrous turn of subsequent events, this fact should be borne in mind. The first intimation of something wrong reached visitors in the Kaiser Wilhelm der Grosse, the then Ocean Greyhound, through the appalling noise of hundreds of barrels filled with pitch exploding from the heat, like salvos of heavy artillery. A wild rush for the gangways followed, but the ship's officers, with consummate coolness, averted a panic by announcing that the vessel would proceed immediately into midstream, happily having a sufficient head of steam to accomplish this maneuver. The seamen hastily cast off, but so intense was the onrush of the fire that one man, slackening a stern hawser, found the wire already glowing from the heat. With her decks ablaze, her woodwork crackling, and clouds of steam roaring through her exhaust pipes, she presented a terrifying spectacle as she made her way slowly to safety. Tugs immediately went to her assistance, her guests were rapidly transferred, and the fire was extinguished, but not before considerable damage had been done to her splendid and luxurious cabin appointments, which had been the talk of both sides of the Atlantic. Alas, not so fortunate were her sisters, who, not having their steam up, were powerless to escape. To depict exactly what occurred upon these vessels, at such a time of confusion and horror, would in any case be almost impossible, and in addition, of the few survivors, none could give a coherent narrative, since, practically imprisoned upon the lower decks, they were able only to realize that death in some form was threatening them. The Sail, in the very heart of the flames, was cast loose and drifted slowly into the stream, a menace to shipping and a veritable funeral pyre to those on board. Hundreds of desperate creatures jumped overboard and were picked up by passing boats. But hundreds of others were less lucky and were roasted to death in the depths of that floating inferno. Little could be seen of their plight, but as fireboats surrounded the smoking hull, faint cries from the lower ports attracted attention. Suddenly a naked arm shot out through the murk, and a voice, cracked with terror, screamed for help. Rescuers placed a hose line in the grasp of the quivering hand, and as the water brought temporary relief, the crazed sufferer was understood to say that with him were 40-odd men and women awaiting their doom. A desperate effort was made to haul him through the port, but his shoulders prevented his escape. And even as he was making one supreme attempt to dodge death, a wisp of flame shot wickedly out from behind him and branded him with its fiery tongue. With a shriek of demoniacal laughter, he surrendered himself to his agony and fell back to be seen no more. Another belch of smoke from the port, and then a horrid silence. The little band of prisoners were beyond human aid, and had journeyed to that bourne from which no travelers return. Slowly the sail drifted down the Hudson, a moving emblem of the vanity of life and the evanescence of all things. Before it finally grounded off Ellis Island, another incident replete with painful tragedy was to occur. A woman's voice was heard calling from one of the ports of the main deck cabins, and rescuers could plainly see and converse with its owner, a stewardess. Again, the narrowness of the ports spelled her death, a death so supremely horrible in its essentials that it scarcely bears narration. The fire was just eating its way through the paneled door of the cabin, and with the aid of a hose length from a tug, the woman fought gamely for her life. Needless to say, the odds were all on one side. To escape was impossible, but nonetheless the unequal contest continued until, with her hands blistered, eyes blinded, clothes burning, with a cry for mercy to her Creator, this brave soul passed to her reward. The case of the Maine was equally desperate. Although 1,000 feet away from the outbreak, she caught fire almost instantaneously, and her decks were swept bare as though in the path of some giant tornado. There was no time even to cast off, and until the flames had eaten through the connecting hawsers, she weltered in a whirlpool of fire. A few persons had jumped overboard at the first alarm, and were seen clinging to her propellers. Then, one by one, they were overcome and dropped off into the muddy eddy which lapped the dock wall. Thus she lay for some hours, and it is indeed surprising to relate that even 16 persons out of her complement of 150 managed to escape. And the story of their escape is indeed miraculous. They were all coal passers or engineers, engaged in their professional duties about the engine room. Upon the alarm being given, they had found all means of exit to the deck cut off by the flames. They had consequently retreated to one of the coal bunkers, the door of which they closed. For 8 hours they remained there, uncertain of their fate, ignorant of what was happening, and in a temperature which made it painful to breathe. For some considerable time the electric lights burned steadily, a sardonic reminder that a supernatural stoker had taken charge of their duties and was generating the steam necessary to keep the dynamo running. Then came a flicker. The lights shone with an uncanny brilliancy, and then there was darkness. The silence was still broken by the monotonous hum of the ammonia pumps connected with the refrigerator plant. It seemed as though their speed were being increased by some ghostly mechanic, for the hum developed into a mighty roar, culminating in an explosion, and then there was silence. It was 11:30 that night that the poor, helpless Maine was grappled by a fireboat, the crew of which, hearing voices, located these prisoners and succeeded in hauling them one by one through a coal port. Their condition was desperate, but ultimately they all recovered, with the exception of one man who had been partially blinded by steam and died in hospital. The plight of the fourth liner, the Bremen, was not quite so critical, as the fire did not succeed in getting a good hold below decks. She was, however, crammed with visitors, which would account for the fact that 74 persons perished aboard her. Like the others, she drifted away from the burning docks, and it was some considerable time before tugs and fireboats had succeeded in getting her under control. Meanwhile, she was acting as a veritable torch to all shipping and wharves with which she came in contact. Carried by the current toward the New York shore, she imperiled all the docks from 33rd Street to the Battery. In fact, so serious was the menace that alarms were sent into the city fire stations, and men and apparatus stood by ready for all eventualities. One lighter passed her, caught fire, and drifted alongside the Baltimore and Ohio wharf, which promptly in its turn took fire. Fortunately, this outbreak was quickly suppressed, but the same thing occurred at several points, a sufficient indication of the peril which was threatening the whole riverfront. However, the danger was averted, and the Bremen secured and later beached in shallow water. On the Jersey side of the river, the desperate work of the firefighters had had its effect, and the Scandinavian-American Line docks, which adjoined the North German Lloyd, escaped with the inevitable injury caused by burning embers starting subsidiary fires. At one moment it was seriously feared that they, the Hamburg American Line, the Holland America Line, and the Wilson Line sheds would all become involved, together with the vessels moored alongside, which would have constituted one of the greatest disasters in the history of maritime conflagrations. Happily, however, such a catastrophe was avoided, and in spite of the enormous damage, the fire was practically under control within 6 hours of its inception. But to the day of their death, those who saw the Hudson River in that summer twilight will never forget its fantastic appearance. The 4 great liners, vomiting flames and smoke, and surrounded with puffing tugs and busy fireboats, while a couple of dozen smaller craft floated hither and thither on the most congested waterway of the world, aflame from stem to stern, and reminiscent of nothing so much as an armada of old-time fire ships intent upon destruction. Doubtless, human forethought, energy, and determination in no small degree vanquished this enemy, but Providence must have been watching over New York that day. The actual extent of the pecuniary loss entailed by this conflagration has been assessed at $6 million, a mere bagatelle in comparison with the 400 lives which were sacrificed. There have been, of course, bigger disasters of the same nature financially, such as that of Hamburg, where it is estimated that fire destroyed $45 million worth of property, but none has approximated to this in its sheer horror, and in bringing home to the lay mind just what may occur as the result of a small outbreak upon a wharf. It is almost as though human nature required the sacrifice of life, grief-stricken homes, and the poignant realization of the grimness of death in order to bestir itself towards the adoption of fire prevention in its most simple forms. Even the uninitiated will realize readily that the methods of coping with fires on board ships must differ radically from the systems commonly in vogue on land. In the first place, the construction of a ship is such that successfully to deal with an outbreak bespeaks a rough general knowledge of naval architecture, without which the most intelligent officer must be hopelessly nonplussed. But under any circumstances, it is the business of the fire chief upon arrival alongside the vessel to consult with the captain, or whoever may be in charge, with a view to ascertaining, if possible, the location of the fire and the nature of the cargo, upon which latter much depends. In addition, on all large steamers, a plan of the vessel is placed in the chart house, and this will show, in diagrammatic form, the various holds, with distances from one bulkhead to another, the ventilator shafts, and other details of the greatest value in deciding upon the plan of attack. The location of the outbreak having been ascertained, which should only occupy a few minutes, all hose lines should be stretched and in readiness before removing the hatches. Also, if steam is being already used to hold the fire, a common method on board ships, it should be shut off as soon as the preparations outlined have been made, as it seldom happens that men can enter either the holds or the 'tween decks of vessels where resort has been made to this plan without allowing time for the atmosphere to cool. A matter of moments, perhaps, but in such cases it is the seconds saved which count. Everything will now depend upon the location of the blaze. If it is in the lower holds, the best thing to do is to remove a hatch in the lower deck, drop the hose line through the opening, and simply flood the compartment. Should the fire, however, be 'tween decks, a different means of attack may be successfully employed, providing there be port lights in the ship's side. These should be stove in about 12 feet apart. A fireboat should be run alongside, and should bring into play her lines armed with distributing nozzles, which latter should be forced through the ports, water being pumped in at a pressure sufficient to give about 50 pounds to the sprays. If it is possible to reach the ports on the other side of the ship, similar tactics should be adopted, and in most cases the fire will quickly be under control. Then a ladder should be placed down the hatch. As a rule, there is a built-in ladder in every hatch, but failing this, a regulation fire ladder should be used, providing solid foundation can be discovered for it. Further, all men employing the same should have a line around them in order that they may be hauled out to safety in the event of any accident. Ventilators leading from the deck on fire should be utilized for dropping down hose with distributing nozzles into the affected area, which will render valuable assistance in cooling down the compartment. Finally, amongst preliminaries, if the pipes used for sub-cellar work are long enough to operate, they should be utilized down the hatchway. An important point to be remembered now is that all cargo ports must be closed. This is rendered absolutely necessary, since the water being pumped into the vessel is bound to give her some list, and if the ports are left unclosed, there is the strong possibility that she may heel over, and consequently fill and sink. But this by no means concludes the long list of precautions to be taken or knotty problems to be solved. Since such great volumes of water are being steadily and persistently pumped into the ship, it stands to reason that her draft will rapidly increase, and if she takes to the ground, she will instantly list heavily and probably endanger the lives of everyone assisting on board, let alone rendering the actual firefighting 10 times more difficult. To keep her on an even keel is the primal necessity of the situation, and this demands as much scientific diagnosis of the needs of the moment as ever a medical man was called upon to expend over an unknown patient suffering from an obscure complaint. To those who know them, ships are almost human in their idiosyncrasies, and the slightest mistake in their treatment may spell irretrievable disaster. First and foremost, if the vessel seems likely to take to the ground, by hook or crook, get her off into deeper water, and should she be light, fill her ballast tanks. An expedient at times resorted to, but by no means to be recommended under ordinary conditions, is to flood the lifeboats on the weather side, thus, so to speak, levering her back into position. But this is obviously dangerous in the extreme, and should never be resorted to unless those superintending the operation are experts and understand shipcraft from A to Z. Again, should the fire be gaining ground, and it seem as though it were getting out of control, it is impossible to avoid heroic methods, and she must be towed to shoal water and beached, care being taken that her decks will no more than lie awash. Admittedly, this is a last expedient, but it will save her from total destruction, providing she is sunk in shallow water, which will of course make it possible to pump her out and float her again. It might be imagined that such total immersion would subdue any fire known to man, yet the fact remains that cotton is so obstinate in its resistance that the writer has seen bales which have been a whole week under water at a depth of 40 feet, that upon being examined shortly after coming to the surface were not only smoldering inside, but upon being prodded burst into flame. This gives some idea of the stubbornness to be encountered in dealing with some cargoes, and it is small exaggeration to hazard the statement that raw cotton requires as much attention as gun cotton from the skipper's point of view, that is, the safety of his crew and himself. A vessel reaching port already on fire, and which has signaled for assistance, offers again a rather different aspect of affairs with which to cope. In this instance, steam should be kept playing on the affected area, and the hatches kept battened down until all the passengers have been taken off. Anything likely to cause a panic would be fatal and quite unnecessary. Under the conditions named, there would be no danger of an immediate and fatal spread of the outbreak, such as in the case of a building, where it might cause the loss of life within a few minutes. As mentioned elsewhere in this volume, it cannot be emphasized too strongly that in the opinion of the writer, steam alone will rarely extinguish a fire. In itself, it has already absorbed a great quantity of heat, and its transformation from a liquid state into vapor has been due to just such elemental activity as it is now called upon to subdue. Hence, how can it be expected to exercise a cooling effect, which after all is what is needed, when itself is over boiling point? All that can be expected is some temporary check, consequent upon the moisture, but as a permanent and real stay to flames it is comparatively useless. It seems almost needless to say that in bringing fireboats alongside steamers unmanageable on account of fire or whose steering gear is in danger owing to its becoming affected by great heat, the former should take up a position on the quarter from which it is possible to control and steer the latter. In addition, in all open waters, care should be taken so to handle the burning vessel that the flames may be prevented from sweeping the decks, as undoubtedly would occur were she forced head-on into a strong breeze, the fire being forward, or vice versa. In either case she should be kept before the wind, thus minimizing the area open to attack, and at least giving the operators some deck room upon which to organize their defense. Though strictly perhaps not within the scope of this chapter, the writer is strongly of the opinion that the time has arrived when all ships should be compelled to carry some simple and effective form of automatic fire-preventive apparatus. The sprinkler system would appear to offer many advantages, and to be easy of installation in vessels of new construction. This might be controlled either from the chart house, where exists at present the smoke pipe designed to warn the officers of a fire in any hold, when upon being definitely located, the system might be brought into operation, the flow being controlled by the ship's pumps. Or, alternatively, the installation might be arranged on lines broadly similar to those in use at theaters. This would demand a fusible plug, which at a certain temperature would melt, allowing a heavy and constant stream of water over a certain defined area, the pressure, of course, being constantly maintained by the ship's pumps, as in the other case. No doubt expense would be urged as a deterrent to the introduction of any such appliances, but it does seem passing strange that when precautions without number are now being taken to save the careless from the comparatively rare peril of the iceberg, so little attention is given to the ever-present menace of that most ghastly enemy at sea, the flames. Or can it be, as has been suggested, that what is wanting is the lurid lesson of a great fire in mid-ocean? In conclusion, a few words may not be amiss anent the position the fireboat may conceivably play in any municipality boasting of a waterway, without which the necessity for such a costly accessory could not exist. It is commonly presumed that a fireboat, as such, must confine its attentions to its own element, and can in no wise be regarded as amphibious. This is an error which has been practically demonstrated by the writer. Properly handled, the fireboat becomes a most powerful and useful auxiliary to land apparatus. During the San Francisco conflagration, it is reported that from a government revenue cutter a line of hose was run for half a mile, and that its cooperation even then was valuable. The words "even then" are inserted, since with the limited pressure available from the pumps of such a vessel, and with no natural aid such as gravity, the nozzle power of such a stream could not be seriously considered as of particular importance, unless water was altogether lacking, as in the case mentioned. But from tests made in New York, it was conclusively proved recently that it was feasible and caused no undue strain on apparatus to discharge a jet through a 1 1/8 inch nozzle at about 2/3 of a mile from the fireboat acting as a pumping station, the nozzle pressure approximating 50 pounds to the square inch. There were 2 relay engines in the shape of 2 ordinary steam fire pumps, and when the pressure on the fireboat registered 280 pounds, the further engine maintained a nozzle pressure of 59 pounds, giving 291 gallons a minute. Not a great stream, but considering the conditions of the experiment, sufficient to show the possibilities attendant upon the introduction of the fireboat as a land auxiliary. The distance for effective relay of water can be proportionately increased by multiplying initial fireboat lines and Siamesing them. One New York fireboat can furnish 12 3.5-inch lines, sufficient to supply 24 engines under conditions similar to the test. That in itself is sufficient for the handling of a large fire. Thus it will be seen that in great emergencies, here is an auxiliary to the fire force on land which is at least impervious to the breaking of mains, climatic or seismic interruptions, and hence not lightly to be neglected. End of section 19. Recording by Maria Kasper. Section 20 of Fires and Firefighters by John KENLON. This LibriVox recording is in the public domain. Chapter 19. Fire Strategy in the Homes of the People. To prevent a fire is one thing. To fight it is another. And since this volume deals with all aspects of the subject, some consideration must be given to fire fighting in its active sense. That is, how to deal with outbreaks when an alarm is turned in, and the best method of using apparatus. This may sound to the lay reader stale and unprofitable reading, but if he will take his courage in both hands and dip into the subject in ever so small a degree, he will find much to give him thought, much that will be of value to him, and a certain number of useful hints which should be of assistance to him should he ever be unfortunate enough as to be involved in a fire. The fire risk becomes more apparent as soon as it is realized that it is a menace to the home, and that the flames are no respecters of persons, and are as likely to visit the mansion or the tenement as the factory or the warehouse. It is hard to realize when reading newspaper reports of some great conflagration quite what it all means. It seems so far away, so remote from the happenings of daily routine, that it is perused with passing interest and forgotten. Then comes the day when suddenly the menace appears in all its lurid horror, and behold, the occasion when an ounce of knowledge regarding fire and its usual course of progress may be the means of preventing the advance of the enemy and of saving human life. Of course, prevention is better than cure, but even as the hypochondriac occasionally falls a victim to the ills the flesh is heir to, and has to invoke scientific aid in order to regain his health, so it is with fire. With all the precautions in the world, it is impossible to guarantee that an outbreak will never occur. But it is within the ken of man, what then to do? And though the professional will be needed to fight with the sufferer as the doctor does with his patient, the individual who is prepared for the onset and knows just what course the attack will probably take is doubly armed against the foe. It is for this reason that the writer is hopeful that the general reader will persevere and glance through the following pages. Certainly, if a person of discernment, the previous chapters will have shown him how life has often been unnecessarily sacrificed at fires, when well-directed action would have saved the situation. In all countries, responses to fire calls, particularly those turned in from street boxes, are usually very prompt. As a rule, about 20 seconds is consumed in hitching up and getting the apparatus out of quarters. Horses are trained to come to their places at the pole on a gallop, and all harness is hung with an open collar which locks with a snap. Commonly, 3 engines and 2 hook and ladder companies are designated to respond on the first alarm, and in making the assignments, the company nearest the spot from which the call was sent in is expected to be the first to reach its destination. In forwarding reports of operations at fires, the officers must state the order of their arrival and also which company gets to work quickest. It will be easily deduced that this creates a spirit of the keenest rivalry, and to be beaten in a dash to an outbreak at which a company is first due is considered a humiliation. If it happens twice in succession, the commander of the defeated company is asked for an explanation, allowances being made for gradients and traffic, and should it appear that the company is lacking in energy or vim caused in any way by indifference on the part of officers or men, a reorganization is sure to follow. This, then, is the primal step towards the formation of a good company, which is the unit of organization. Horses must be carefully trained, for a few seconds lost in getting away from quarters cannot be made up en route, particularly when the other companies have had a better start. The driver is as important as his animals, and should be a man trained to the hour, and one who knows every inch of the streets, and every fire hydrant in the district to which his company may be called. Many an occasion can be recalled by the writer, when, on the way to a fire, he reviewed the whole district surrounding the box whence the alarm was received, and had the hydrants clearly in mind as the engine approached its destination, often pulling up in front of one completely shut off from view by obstructions, secure in his knowledge of its existence. The engineer should be equally well informed, and should know the size of the main on which the hydrant is situated, and how much water can be drawn therefrom. This prevents the mistake of having too many engines located on small mains with low pressure. When approaching the fire, the engineer should jump from his engine, run ahead, and have the cap off the hydrant as the apparatus pulls up. With the change from horse to motor as a means of propulsion, the department has been shorn of some of the spectacular features which in the old days added to the picturesqueness of the proceedings, but the dangers of injury in responding to a call through crowded thoroughfares are greatly increased. Stretching in hose lines at fires has been the subject of many orders and lectures, but when celerity is paramount, hose cannot be measured by the foot, as can be done in a classroom. However, when the location of the fire has been ascertained, the commanding officer should have a fairly good idea of the number of lengths required, and it is slovenly and shows but poor judgment to see hose coiled in the streets in front of the site of the outbreak. Controlling nozzles should be used for inside work, in order that the stream may be shut off from this point, and at fires in tenements and private dwellings the greatest care should be exercised in the use of water, as the floors are not filled. In such cases the water runs through the floorboards, destroying the ceilings beneath and the furnishings of the lower floors. The best way to illustrate these rules is to assume an outbreak in an old-style tenement, where the blaze has started in a store on the ground floor. In addition to the main entrance and show window, the store has a door opening from the rear into a hallway where are situated stairs which lead to the apartments above. In this type of building there are usually 6 floors, including the store, with from 3 to 4 families on each. The stairs are of wood, and all partitions are stud covered with wooden lath and plaster. The ingenuity of man could scarcely devise a better fire trap than that which is afforded by this style of construction. To prevent the fire from reaching the stairwell, and by this means ascending to the top only to mushroom on the highest floor, is the first thing to be done. A line of hose should be taken into the hall to cover the rear door and transom to stop the fire spreading up the stairs, whereby that means of escape from the upper stories would be cut off. The second line should attack the fire from the front through the main door, while ladders should immediately be raised to the front fire escapes, and the floors over the store should be examined to make sure that the blaze has not mounted through pipe recesses or other vertical openings. Should the alarm have been sent in with promptitude, a fire of this nature can, and in all probability will, be confined to the store where it originated. But if there has been delay, and the fire has burned through the doors communicating with the hallway and stairs, and by means of these latter has swept through a crowded tenement, a very different problem awaits the officer in command upon his arrival. As in the former instance, the first line should operate in the hall to drive the fire back through the door leading into the store, and when that has been accomplished, the nozzle should be directed up the stairwell, which is usually about 12 inches wide. A stream sent up this opening will deaden the fire down on the upper landings, which at present it is impossible to reach in any other way. The second line should be opened on the fire in the store from the front, and the flames subdued to prevent them ascending on the outside of the building and enveloping people who by this time would be crowding onto the fire escapes. A few seconds should suffice to quell this portion of the outbreak, when the line should be taken to the hall in order to cover the first company, which by now should be ascending the stairs. In the meantime, hook and ladder companies would have placed ladders on the street side of the building and would have begun the work of rescue from fire escapes and windows. In cases of this nature, events move swiftly, and in far less time than it takes to write, a line would be rushed to the top floor by front or rear fire escapes, generally by the latter, as the landings are, in most cases, nearer to the back of the structure. This line is of the greatest importance, and if the position is reached quickly, the fire should be prevented from spreading on the top floors. One man should be sent by way of adjoining buildings to open the bulkhead door, which is found in all places of this type, and which leads from the highest story onto the roof, in order to assist in accomplishing this purpose. All possible effort should be made to force the advance line up the stairs, and here is where men must take their medicine if need be. Life depends on their grit, determination, and endurance, for work of this kind often entails severe trial. By this time, the second line in the hall should have killed the fire in the store, and should immediately follow in the rear of the other line on the stairway, in order to prevent the flames coming out behind them and cutting them off, or rendering their efforts abortive. It is essential in firefighting, as it is in battle, that companies or columns be supported, or in firemen's parlance, covered. To detach a column from the main army and direct it to attack a well-entrenched enemy without proper support would seem to the writer to be a tactical error. And similarly, to order an unaided company into a position where its retreat is cut off by fire would be a very dangerous proceeding. In war, the column would, in all probability, fall into the hands of the enemy and become prisoners. But fire takes no prisoners, and the battle cry is death or victory. Therefore it will be understood that companies must support each other, the more advanced being always assisted and covered by the other coming up the stairs or on the floors below. There is one more essential point to be guarded, namely the light shaft, which is usually between two of these buildings, and the windows opening into this space should be protected in order that the fire should not extend upwards on the outside or cross the shaft and ignite the adjoining buildings. This disposition of forces should successfully deal with a fire of such a character without loss of life, for during the operations described, the two hook and ladder companies would have been engaged in conveying all the residents to a place of safety. Every action or order cannot be foretold, nor would the writer attempt to say in what respect a commanding officer might find it necessary to deploy his forces, but he should use all possible efforts to outflank the fire. He should never neglect, when the flames have control of the stairway, to take a line to the top floor by way of the fire escape. In outbreaks of this character there is always danger of loss of life, and the risk is greatest on the top floors. But with a line following the fire and a stream above it, the enemy is placed between two batteries and his doom is sealed. The opening of the bulkhead door in the roof allows the heat and flame to escape, gives the men coming up the stairs a living chance, and permits the other company to effect an entrance from above in order to finish the work already well in hand. In dealing with an old-style tenement, it is important to look carefully around all pipe vents, and also the partitions near folding doors, as every stud partition is a vertical flue, and there are few fire stops. The lath should be stripped until it is satisfactorily proven that there are no nests of fire concealed behind the plaster. Above all things, a search should be made as soon as possible in every room for persons who might have been overcome by smoke, and the floors under the beds should be carefully inspected, for, as already stated, children will invariably take refuge in these places, and if not found and carried out at once to the open air, will die of suffocation. This is a brief outline of a fire presupposed to have started in a store, but it may have originated in the cellar, when, as the building has an inside stairway, this latter should immediately be covered to prevent the flames from mounting. Should it succeed, the outbreak is similar to the one described. Therefore, the first object, as stated above, is to confine the blaze, and then the cellar should be entered by the front or rear doors. When the outbreak has been located, distributing nozzles should be used through the floor over the section which shows the greatest heat. Rapid action is the keynote of success, and as fire spreads like lightning through these old buildings, a few seconds' delay may mean loss of life. By quick stretching in, and with good engines to give water to the lines, the fire will be suppressed, and it is just these qualities of prompt action and swift decision which have saved thousands of persons in New York City. Each year, 10,000 fires occur in these homes of the working population, making up 64% of the total number of outbreaks recorded. Much more might be written on old-style tenement house fires, though should such an occurrence originate on any floor and spread to the stair hall, the effect would be the same and should be combated in a like fashion. It is not the intention of the writer to lay down specific rules or to attempt to tell the chief in command at a fire that this or that should be done, since local conditions alter cases. For the same reason, no rule is given for life-saving, beyond the raising of extension and other ladders on the front and, if it be possible, on the rear of the tenement, in order to remove the occupants at different points. Extraordinary cases of peril, when all human ingenuity seems exhausted, often result in daring feats of rescue accomplished in a way that no one could foresee. In new-style tenements, the stair halls are enclosed in brick walls, the ground floor is fireproof, and the hall doors leading to the different apartments are calamine. There is usually a long private hall running the full length of individual flats, which, should a fire break out, would soon be heavily charged with heat and smoke. Should the fire originate at the end farthest from the door through which the firemen enter, great hardship is entailed in crawling the length of this narrow passage, dragging a line of hose. Water should not be started until the blaze is located, so that the stream may be played directly on the flames, instead of doing unnecessary damage by opening the nozzle when no fire is visible. In order to relieve the men with the line, hook and ladder companies should be active in ventilating the apartment, and if there be a fire escape on the front or rear, the windows should be opened. In circumstances where the fire has gained considerable headway, a second line should be taken up one of the fire escapes. Should a heavy flame belch forth from windows on the lower floors, there is always danger of the heat breaking the glass in those overhead, and in this way communicating the fire from floor to floor. This should be met with heavy streams from the outside to drive the fire back, using a water tower, mast, deck, or turret pipe, or if none of these be available, a street pipe may be employed, though these should be shut off when the flames have ceased to spread on the exterior. To locate and confine a fire to the smallest possible area is one of the first great principles of firefighting. As it is the tendency of flames to burn upwards, care must be exercised and attention given to the floors above the outbreak, though it should be understood that the floors below should not be neglected. Firebrands often fall through an elevator shaft or other vertical openings and start a blaze in the story below, so that attention must be given to all parts of the building involved, and even to adjoining houses. Before leaving the scene of an outbreak, the greatest care should be taken to see that all fire is really extinguished, since sometimes there is a tendency to overlook odd corners, resulting in a recall to the scene later in the day, an incident all firefighters regard as in some degree a reflection on their skill, and often causing embarrassing questions. A new style of apartment house is being erected in New York City and elsewhere, divided into so-called duplex flats. Each of these has one main entrance from the stair and elevator hall, while its upper floor is reached by an inner staircase with no means of direct exit to the main hall outside. In other words, it resembles a two-story house within another house. There are no outside fire escapes, no means of reaching the upper floor except by way of the inside stairs, and should a fire occur, the heat and smoke would immediately ascend, and all escape from the upper floor would be cut off. Firemen would be obliged to enter the apartment by the one door leading to the elevator, and would find that the flames had already extended to the floor above. 2 lines would be stretched either up the stairs, or if it be a building more than 85 feet high and the fire is above the 4th floor, from the standpipes, the engine being connected to the Siamese at street level. The first line should be opened on the fire to clear the way to the inner stairs. The second line should also be brought into play to kill the fire on the lower floor and to cover the first line, which should try to ascend. This may be almost impossible, as the heat and smoke will be confined above, unless the outbreak is of sufficient magnitude to melt the windows or blow them out, and if this occurs, the contents of that apartment will be destroyed. To ventilate the upper floor is the problem before the officer in command, and the only method of so doing is to use the hook of a scaling ladder or a telescope hook, which has recently been designed for just such cases. When this has been done, it will be possible to get the lines up the stairs. Should the fire occur on the upper story, it would back down and charge the lower floor with smoke, with a similar result. This type of building, while admittedly convenient for tenants, is most dangerous in case of fire, and people may be trapped 12 stories above the street. Personal risk can be obviated to a great extent by connecting each floor by means of a balcony fire escape on the inner court. In cases where it is impossible to attack the upper floor by way of the stair, the terracotta partition dividing the apartment from the hall should be broken through on a level with the upper story. This is not a very difficult matter, and a hole large enough to admit a man would soon be made, and a charged line should be introduced. After the room is cooled, it may then be possible to effect an entrance, when the line should be directed towards the stairs, in order that communication with the floor below may be re-established, and a thorough search for possible occupants should be made. It is remarkable how much more latitude is allowed in designing private dwellings than is given architects in plans for tenements, apartment houses, and hotels, and many disastrous fires, often attended with loss of life, occur in such structures. A common defect is the large open stairway. Elevators have recently been introduced, reaching usually to the top floor, and capped with a 4 or 6 inch stone slab, which, from the standpoint of fire control, is an extremely dangerous form of construction, as, should an outbreak occur, the flames will quickly ascend the shaft, and having no outlet through the roof, will inevitably mushroom on the upper floors, thereby entailing possible loss of life. Such a thing as fire, in any part of a house except in the furnace, is not thought probable or even possible. So when the unexpected happens, great masses of draperies, carpets, and heavily upholstered furniture soon turn the building into a roaring volcano of flame. Many dwellings of the wealthy stand in an enclosure, often surrounded by high iron railings, making it particularly difficult to get any kind of ladder near enough to be of service. This class of structure has no outside fire escapes, which increases the peril of people trapped on the upper floors. In such a case, a person should never attempt to descend the stairs, but should, if possible, reach a front window, or any that can be found smoke-free, and call for help. Every minute of waiting may seem an hour, but someone in the neighborhood will assuredly turn in an alarm. Above all, remember that jumping is the last resort of the desperate, and if driven to that final extremity, sheets, curtains, or blankets will provide some sort of assistance towards reaching the ground. On his arrival, the commander of the fire forces should at once stretch a line, taking it in through the main entrance and driving the fire away from the stairs. If by this time the flames have forestalled such an attempt, all speed should be used to follow in their path. And should there be a back stairway, this should be covered in the same manner. It takes but a few seconds to make a survey and to see in which direction the fire is spreading, when it should be outflanked with all rapidity and its progress stopped. The building should at once be covered with ladders, for while no persons may be visible, some may appear at any moment. An extension ladder should immediately be raised if the fire has control of the stairway, in order that a line may be taken in through an upper floor window to cut off the advance of the flames. Men should be sent to the upper floors to ventilate the rooms and to search for persons who may have been overcome. The size of the house and the extent of the fire should be the guide to a chief on his arrival in summoning additional aid, and no time should be lost in sending in further alarms where conditions are dangerous. It is earnestly suggested that owners should equip their homes with a few fire extinguishers to be used pending the arrival of the firemen, and it may be added that draperies are a prolific source of danger. The first floor, at least, should be fireproof, and in case of an outbreak in the living rooms, curtains should be torn down and the fire trampled out or beaten with rugs, using any means to hold it in check until the arrival of the trained firefighters. Telephones as a means of sending in alarms are untrustworthy, as under such circumstances excitement is liable to cause the message to be misunderstood. In the case of town houses, there is nearly always an alarm box in the vicinity. The most dangerous fires in private dwellings usually occur at night after the occupants have retired, and as the bedrooms are generally on the upper floors, the premises should be thoroughly searched the last thing at night by the owner or some responsible person, and if electricity is used as a means of lighting, the wiring should be frequently examined. Both owners and architects are loath to extend an elevator shaft above the house because of the inartistic effect of having an unsightly object protrude through the roof. But the shaft could be connected by a fireproof flue to one in the chimney, which would carry smoke and fire over the roofs and ventilate the floors, thus giving the occupants a chance of escape. There also appears no reason why the sprinkler system should not be installed in houses which possess elevators, in order that in the event of a fire, sprinkler heads might operate in the shaft and prevent the upward trend of the blaze. In all the foregoing classes of buildings, fire is always necessarily a great menace to their tenants, and deaths may result from the smallest of outbreaks in a crowded tenement or in a great mansion. It seldom happens, however, that the life lost is that of a fireman, with the possible exception that he may be suffocated by escaping gas in cellars. Here lies one of the greatest dangers to the force, and gas should be promptly shut off from the building involved, especially when the fire has begun in or spread to the basement. The above instructions are not difficult to comprehend or to carry out, that is to say, as applied to the layman. All that is demanded is a minimum of coolness and the avoidance of panic amongst strangers who may be on the scene and are unaccustomed to the realization of the dangers of unconsidered action. Of course, in large country houses remote from any professional firefighting force, a private brigade should always be formed from workmen on the estate. It is not difficult to instruct them in the efficient use of simple apparatus, while prompt and timely action would in many cases save fine old mansions of historic interest, which, alas, are annually lost by fire. Granted their construction is faulty, and that the architects of 3 centuries ago neglected to consider fire risks, still, even so, it is an error to give up the battle as lost before firing a shot. End of Section 20. Recording by Maria Kasper. Section 21 of Fires and Firefighters by John KENLON. This LibriVox recording is in the public domain. Chapter 20. Quick Burners. In Europe, no less than 350 years have been spent in building some churches, while in America 350 churches are built in 1 year. There, in succinct form, lies the cardinal difference between European and American construction, and it is this latter which possesses a profound significance for the firefighter. In the ancient cities of the Old World, from time immemorial, stone has played a chief part in the erection of buildings, with brick in recent years as a good second. But in America, use has naturally been made of that material most ready to hand, wood, and thus it is that the fire risk has grown proportionately to the population and the birth of new towns, both of which have been inordinately rapid and necessitating, in their turn, celerity of construction to meet the ever-increasing demands of the situation. Further, a man will decide to build a mansion for himself, premises for his business, or a factory for the production of some commercial article. He buys a plot of ground, selects an architect, chooses a set of plans and specifications, lets out the contract, and is in occupation 120 days after he first conceived the idea. Hustle with a capital H is the keynote of the scheme, and any questions of fire control, appropriateness of design, or structural stability are all swamped in one wild desire for haste and the speedy completion of the order. Contrast this picture with European methods, where the individual breaks fresh ground only after months, maybe years, of careful consideration, and where the great-grandson places the finishing touches to the conception of his forebears. Again, take the ingredients commonly in use for the mixing of mortar, that most essential adjunct to building operations. The writer has seen in Europe pails of animal blood and hair combined with the finest lime and sand, it having long ago been recognized that the binding qualities of this compound are unsurpassed. In America, it is often thought sufficient to employ mud with a sprinkling of cement, which may be cheap, but distinctly savors of jerry-building. It has sometimes happened that whole rows of buildings have collapsed because of the inferiority of the materials used in their erection, and often, weeks after bricks have been laid in this mud mortar, 2 fingers would suffice to pull them from the wall. True, some improvement has taken place of late, but buildings of the type mentioned, carelessly finished within and without, provide that class of construction generally described as quick burners. While on the subject, it may also be remarked that when a stipulation is made in a building contract for fireproof wood and finishings, the prospective owner of the premises seldom realizes that wood so treated loses its fire-resistant qualities from atmospheric moisture in a few years, while hardwood will only absorb 35% of the solution, and maple none at all. In discussing fire strategy in lofts and commercial buildings, entirely new conditions present themselves to those previously considered under the title Fire Strategy in the Homes of the People. The structures have large floor areas, usually heavily stocked with what may prove to be combustible material, and in many cases open stairways and elevator shafts, added to light shafts between two buildings, enhance the danger and the difficulty of efficient fire control. Bold indeed would be the officer who would attempt to lay down a set of strategic rules for fighting fires in places of this type, as so many factors enter into the problem that a prearranged attack is impossible. The fate of nations has often been decided by a successful or a disastrous campaign worked out by a military genius of the headquarters staff, and it is related of Field Marshal Moltke that on war being declared between France and Germany, he sent a telegram and went to bed, every possible detail of the war having been prepared months or possibly years in advance, even to the number of cups of coffee required at KENLON railway station for the arriving troops. Fire chiefs must evolve their plans on the instant, for they cannot calculate beforehand the strength of the enemy. Furthermore, fire is the only adversary which, on the battlefield, steadily increases in strength in the exact mathematical proportion of the resistance it meets, until the point is reached when it is actually held in check. This emphasizes the part played in modern firefighting by promptness of decision, good judgment, and rapid action on the part of those in command. Hence, it can be realized that the mere theoretician stands a poor chance of acquitting himself creditably, and that it is practice which tells. But notwithstanding these factors, there are a few general rules which can and must be applied under any conditions. On arriving at the scene of an outbreak in a commercial building of the quick burner type, the officer in command should be able to tell at a glance its height, width, depth, and style of construction, and for this 1 moment should be sufficient. Here is a most important point, for no matter to what part of the building the commander may be obliged to go thereafter, he has a correct map of it and its surroundings in his mind's eye. The next step is correctly to locate the seat of the fire, which can only be done by an instinct fostered by long training and experience, which becomes a sort of sixth sense, and is therefore outside the boundary of rules and regulations. Some possess this faculty to a marked degree, while others seem to lack it utterly, and, like an ear for music, it cannot be acquired, though it may be enhanced and quickened by practice. Approaching the problem under consideration from a broad standpoint, the plan of attack depends upon the condition of the building and the extent of the fire upon the arrival of the first assignment. If the outbreak is on one floor only, a line forced up the stairs to its origin may be sufficient, and it should be added that this line usually extinguishes more fires than the 3 or 4 which follow. In fact, it may be hazarded that 75 times out of 100 this will be all that is necessary. Should the flames be found to have control of several floors, the force should be deployed in such a manner as to confine the fire to the area it has already invaded, and should it be impossible to enter the building, a water tower may be brought into action to cover the front, though the street is usually wide enough to obviate all danger of fire crossing and igniting structures on the other side. The rear also must be covered, as there is infinitely more risk of the flames spreading to adjoining premises at that point, for such buildings are often within 10 feet of each other. Should a fire burst out of the rear windows, it will instantly cross this narrow space, and if not driven back by lines in the buildings behind, they too will ignite. Should a condition of this nature confront the chief on his arrival, he should immediately summon additional aid, and a common fault with some subordinate officers, which may cause fatal delay, is to postpone the transmission of further alarms. Precious moments are consumed before the fresh assignments can reach the scene and the fire has gained control. Therefore, it must be reiterated that a correct estimate of conditions to be met is of vast importance. Once the rear of the building is covered, the side exposures must be protected, as there are 4 sides to a fire, and the one to leeward is naturally the most dangerous. Seldom does a fire work to windward, as it did in the case of the Equitable,
and hence a line or two should be stretched to leeward, the probable route of the flames. When control of the outbreak is assured, with front, rear, and sides covered, it may be possible to enter the building, unless it be old and heavily stocked. Should there be fire escapes on the front, lines can be sent up by this means under cover of the water tower and turret pipes, and if lines are sent up the stairs, the roof should be opened. This latter is a prime requisite to relieve the building of accumulated heat and gas, which might explode and would certainly seriously hinder the actions of the firemen. As soon as the lines ascending the stairs and fire escapes have gained a foothold in the structure, the tower and turret pipes should be shut off, as there is no object in flooding the floors if the inside lines can control the flames. At this time, the force in the rear should be advanced across the space and effect an entrance. Everything now would depend upon the condition of the building, for as a physician skillfully prescribes to suit the strength of his patient, so must the chief cautiously advance according to the strength of the structure. If it is weak and tottering, after a fire such as has been described, and furthermore contains stock that has absorbed a quantity of water, thereby adding greater weight than perhaps the supports were intended to stand, men should pick their way. And if there is great doubt of its stability, lives should not be risked until floors are relieved of all possible weight. Many deaths have been caused by the collapse of weakened buildings during what firemen technically term washing down. As the first word was celerity, so the last word must be caution. For since the fire is practically extinguished at this point, there is no necessity to risk valuable lives. The fire protection of bonded warehouses offers a curious problem. They may not inaptly be described as quick burners, since their construction the world over is on the same lines and apparently framed with no consideration of fire risks. For obvious reasons, outside fire escapes are barred, the presumption being that their presence might encourage the enterprising burglar or smuggler. Similarly, the floors are of limited height, often with insufficient ventilation, economy of space counting for more than economy of fire risk, which all seems futile and the reverse of far-sighted, though it has grown to be a commonplace that governments are far behind municipalities in dealing with these common-sense features which are so largely responsible for the safety and convenience of modern life. In Germany, it is true, the matter has received consideration, and warehouses are constructed in such a manner that the minimum of damage is done to bonded goods in the event of a fire, by having the floors raked and by the structures themselves being built upon the most approved designs. But this refers only to recently erected warehouses, notably in Hamburg and Bremen. Now, it goes without saying that, as a rule, the contents of these buildings are highly inflammable, and hence every scientific nerve should be strained toward the adoption of some form of fire control which shall meet the immediate demands of the situation. The sprinkler system naturally suggests itself as the remedy, but here questions of space step in, since the nozzles of sprinklers are always of a certain length, and hanging from the ceiling would take up valuable room, let alone being peculiarly liable to damage during the shifting of goods. An alternative scheme has been evolved by the writer, which, if not perfect, at any rate offers some feasible method of meeting the danger of fire, and in construction is of a simplicity which speaks for itself. It has been christened the manifold system. Near the front entrance should be located a number of valves equal to the sum of the stories in the building. These should have pipe connections to each floor, the nozzles of the same being finished just below the level of the ceilings, and furnished with revolving sprays operated by water pressure. Most laymen are acquainted with the ordinary spray used on tennis lawns and grass plots. The principle is precisely similar. Upon an alarm of fire, all that would be necessary would be for the officer in charge to ascertain the location of the outbreak, and in case he could not reach it with a line of hose, promptly to turn on the valve controlling the nozzles of that particular floor. The pressure would naturally be obtained from fire engines, high-pressure mains, or, if sufficient, from the street mains, though in cases where there was an installation of the high-pressure system, the latter would be advantageous. In any event, the fire would speedily be damped down, admitting of the access of firemen to the building, while in many instances such means might in itself be sufficient to prevent further mischief. This system of automatic firefighting is only in its infancy, and the march of science will undoubtedly bring in its train increased efficiency of apparatus employed, and the lessened possibility of its operating out of season, which sometimes occurs with the sprinkler installation. There is a crying need for the perfection of the self-acting firefighter, since in spite of modern fire-resistive tactics, the enemy has itself kept abreast of the times, and each new preventive method is offset by the introduction of some fresh element which promises a splendid stimulant to the appetite of the flames. Thus, the introduction of the automobile has led to the common use of gasoline, in itself highly inflammable, and demanding special methods of storage. Scarcity of coal has turned the mind of the inventor toward the use of liquid fuel, while the advance of the photographic art has been responsible for the introduction of the cinematograph with its celluloid film. Most assuredly has this form of amusement come to stay, but equally its advent has not been an unmixed blessing to the firefighter, since the dangers connected with its operation are so diverse and ever-present that special precautions to meet the same have ever to be framed. And thus it is along all lines of advance. If the human brain is never idle, then most assuredly the fire-fiend is never quiescent, and is prompt to seize upon fresh opportunities of attack. Hence, in considering quick burners as a whole, it may not be inappropriate to include a few words anent the moving picture peril, since in all truth this strikes at the foundations of the social system, owing to the number of children who habitually frequent such places of amusement. Now, in the first place, if a panic in a theater is a tragedy, then a panic in a moving picture hall is doubly so, since it is hopeless to appeal to the self-control of the young audience, and the strong chances are that once a rush for the exits begins, nothing will prevent confusion and crushing. Aisle guards can accomplish little if the principals concerned are not in the bulk amenable to the dictates of reason, and if old heads are not to be found on young shoulders, and if amongst the former panic is not uncommon, then what can be expected from the latter? Hence it is that the picture palace should be as fire-secure as human knowledge can make it, which, in spite of municipal regulations, is seldom the case. From the nature of the entertainment, apart from the actual apparatus, all that is required is a white sheet upon which the pictures are displayed, and thus practically any sort of hall will meet the case. Old churches, disused stables, deserted chapels, in fact, any building which is good for nothing else is impressed into the service, and with a coat or two of paint blossoms forth under a new guise as a picture palace. So long as the requirements of the municipality have been fulfilled, there is no cause for interference, and so it continues to thrive until the day comes when fire sweeps along, laying it low like so much matchwood, and demanding a heavy death toll of women and children. Now, there is one point in this connection, which, small in itself, is really the kernel of the situation. 90% of film fires occur in the immediate vicinity of the operator, and yet the observant will have noticed that nearly always the box containing the apparatus is over the entrance door, or, where there are several doors, at the end of the hall where the entrances, which also serve as exits, are situated. There is no sufficient reason for this, and it would be just as convenient from a managerial point of view were the position reversed, and the apparatus located at the end of the structure remote from the entrance. The reason for this alteration is obvious. In the event of a fire, at present, the audience is obliged to pass out either alongside or underneath the probable seat of the outbreak, an unpleasant and dangerous task for grown people, an impossible one for children of tender years. Now it will be argued that the adoption of such an arrangement would spoil the performance, since the shadows of incoming patrons using the center aisle would be reflected upon the picture curtain. The answer to this objection is apparent. It would be an excellent move if the center aisle should be used solely as an emergency exit, sufficient width being allowed to the side aisles to render both ingress and egress easy. There are, of course, many other structures which, from the nature of the trade carried on within, may be well said to merit the epithet quick burner. In fact, in such cases it is a question of contents rather than construction, and in this connection a special chapter has already been devoted to the consideration of the storage of gasoline and the garage peril. There are, however, apparently harmless factories which provide the wherewithal for dangerous explosions, and it will be well to give some slight consideration to these. For the benefit of the layman, the simplest course will be to supply an illustrative parallel. Take an ordinary log and try to burn it. Short of placing it in a furnace, it is next door to impossible to incinerate it. Even after a severe fire, hardwood beams of some thickness are rarely burnt through, though naturally their outside surface is charred, perhaps to a depth of an inch or two. But split the log, and its component parts will burn more readily, while the smaller it is chopped, the easier it catches alight, until the point arrives when it makes excellent kindling. Reduce the log still further, and it becomes sawdust, which is not only highly inflammable, but under certain conditions actually explosive. Hence it follows that the greatest precautions must be adopted in all factories or warehouses in which large amounts of sawdust are liable to collect. This doctrine may be extended, and might not inaptly be termed the dust danger. Flour, ground grain of any kind, all belong to the same category and offer the same risks. Therefore, let every manufacturer or warehouse man beware of accumulated dust, which, should the slightest outbreak of fire occur, will become a potential explosive. Incidentally, there is no reason why factories of the nature mentioned should not be kept clear of this menace. As in so many other instances of aggravated fire risks, they are, as often as not, directly accountable to the element of carelessness inherent in human nature. It may come as something of a shock to the lay reader to know that drugstores, or chemist shops as they are called in England, are amongst the most difficult problems the firefighter has to handle. Heavily stocked with all sorts of acids and alkalis, no chemist on earth can precisely foretell what results may not follow upon some unforeseen chemical combination. An explosion may occur capable of wrecking a whole block of buildings, as was the case in the Tarrant building in New York in the year 1902. Or poisonous fumes may be generated, which will render it almost impossible for firemen to operate within a considerable radius of the spot, unless equipped with smoke helmets. It is no exaggeration to say that the harmless-looking little drugstore at the corner of the street is a factor of such danger that in New York City special regulations have been framed for fire prevention in such establishments. For consider the perilous possibilities of such a common chemical as chlorate of potash, an excellent remedy for sore throats and coughs, and under certain conditions of the greatest medicinal value. Yet the following details of the peculiar activities of this substance cannot fail to supply food for thought, when it is remembered that its characteristics are not uncommonly met with in other articles usually supplied by the local druggist. Chlorate of potash is a white crystalline body found in commerce in crystals or in a powdered form. It consists of the metal potassium and the gases chlorine and oxygen, chemically combined to form a potassium salt of chloric acid. The proportion of oxygen is large as compared with that ordinarily present in salts, and is very weakly held in the combination. This makes chlorates as a class dangerous compounds, as heat alone will liberate the oxygen, leaving behind potassium chloride, a compound similar to table salt. Danger arises from chlorate of potash in 4 ways. 1. When mixed or in contact with combustible substances and ignited, an explosion results which proceeds with tremendous energy and fierceness, making a bad fire and one dangerous to fight. This violence of action is due to the liberation of pure oxygen, which immediately attacks any explosives present. 2. When mixed or in contact with combustibles such as charcoal, sulfur, or sugar, particularly if both be finely divided, and abraded or struck, the result will also be an explosion. Spontaneous explosions may also occur, and near contact between chlorate and yellow or stick phosphorus is frequently followed by a violent explosion. 3. Strong sulfuric acid in contact with a chlorate will cause it to decompose and to give off heavy yellow gases which are explosive by even slight shocks or by contact with easily oxidizable material. These gases will spontaneously inflame phosphorus, turpentine, and other substances. 4. From the inherent character of the salt itself. Chlorates, for theoretical chemical reasons, are in one sense unstable compounds. The danger from the third source is obvious, although it is not imminent from the third and fourth as it is from the first and second. In the first case, it will be seen that the presence of any considerable quantity of chlorate in a building is a source of danger. It would give such impetus to a fire when once reached as to make the destruction of the property almost certain. When heated alone, it gives up its oxygen quietly, but in the presence of combustibles, an explosion will result from the rapid generation of highly heated gases. A fall of floors or of shelves might scatter the chlorate over a large surface already hot, or might mix it with highly combustible materials such as are usually present in drug houses. In either case, disastrous explosions will occur. In the case of the disastrous fire already mentioned at Tarrant & Company's warehouse, one of the great wholesale chemical houses in New York, this is probably what occurred, since tons of chlorate and sulfur were stored on one floor, and the ensuing explosion consequent upon the fire completely destroyed the building and several others adjacent to it. In the second case, there is danger from intimate mixtures of chlorate and combustibles. These will be found almost exclusively in torpedo and fireworks factories, and have the explosive force of dynamite and gun cotton, and in fact may be placed in the same category. The explosion is propagated through the mass by shock and is practically instantaneous, while in gunpowder there is simply a very rapid combustion generated by flame or heat alone. For full effect, a chlorate powder must be confined, or in such quantity as to produce the effect of confinement in the mass. In case of carelessness, such mixture could occur in small amounts in any drugstore or chemist shop, and if stepped upon would ignite. The danger is that while the explosion in unconfined portions of such mixture takes place usually only in the part under pressure, the action is continued in the remainder of the mass as a fierce and very rapid combustion resembling that of red Greek fire. The danger in the fourth case is a doubtful quantity, but there seems to be some grounds for believing that chlorate will of itself decompose with explosive violence if exposed to heat and shock at the same time. Alone and unmolested, chlorate is a perfectly safe and stable compound. The peril arises from surrounding circumstances. This brief description of one of the commonest of chemical commodities will give the layman some idea of the precautions which should be adopted to prevent fire in all drugstores, wholesale and retail, and in New York this fact has led to the adoption of a detailed standard as to the amounts of dangerous chemicals which may be stored on licensed premises. In the first place, those entering the chemical business must obtain a permit from the Fire Commissioner, who, with the Municipal Explosives Commission, considers each application upon its individual merits. In the event of any disregard of regulations, licenses may be immediately revoked. The following are some of the details of the regulations regarding retail drugstores. Firstly, it is unlawful to manufacture, compound, dispense, or store upon such premises any of the following substances: colored fire in any form, flashlight powders, liquid acetylene, acetylide of copper, fulminates or fulminating compounds, gun cotton, gunpowder, chloride of nitrogen, amide or amine explosive, picrates, or rubber shoddy. Potassium chlorate in admixture with organic substances, phosphorus or sulfur, is forbidden, but this restriction does not apply to the manufacture or storage of tablets of this chemical when intended for medicinal purposes. Much the same applies to nitroglycerin, which is rigidly barred except in medicinal form as approved by the National Pharmacopoeia. A schedule has been arranged limiting the amount of combustible chemicals and fibers, some of which it may be of interest to quote. Thus, carbonic acid 100 pounds, collodion 5 pounds, turpentine 1 barrel, essential oil 100 pounds in all, phosphorus red and yellow 3 ounces, magnesium powder and ribbon 16 ounces in all, powdered charcoal 10 pounds, rosin 10 pounds, lint 10 pounds in closed boxes, potassium permanganate 5 pounds, silver nitrate 1 pound, glycerin 500 pounds. Hence it will be seen that a limit is set upon the storage of even the commonest commodities, due regard being taken of their possible combinations in the event of accident or fire. The next official regulation might well find a place in chemist shops the world over. It shall be unlawful for any person to store or accumulate broken wood, waste paper, or waste packing material of any kind in any part of the premises where goods are packed or unpacked. Such materials shall be removed at the close of the day. In addition, the following restriction is an admirable one and might well be extended. It shall be unlawful for any person to smoke, or to carry a lighted cigar, cigarette, or pipe, or any lighted substance, within a packing room, cellar, storeroom, or that part of the laboratory where volatile inflammable oil or liquid is used or handled, and a notice bearing in large letters the words "Smoking Unlawful," together with a copy of this section in smaller letters, shall be conspicuously displayed in one or more places on each floor. Furthermore, basements and cellars must be properly lighted by electricity, and persons neglecting this and the above regulations are guilty of misdemeanor. It may seem to some that these ordinances are stringent to the extent of being irksome, but it cannot be too strongly emphasized that the everyday fire risks of a community are in themselves amply sufficient with which to deal, and that those exceptional hazards demand exceptional precautions, owing to the unknown character of the outbreak which may result from accidents thereto. There is one last example of the genus quick burner that the writer would like to mention. There is a craze nowadays in all parts of the world for the small suburban home which, with its ornamental exterior, tessellated pavement, and brightly painted front door, appears to the average purchaser an epitome of desirability. By the firefighter, however, these rows of jerry-built cottages, hastily run up by an unscrupulous contractor, are rated at their true value. As a rule, examination will show that there is a common bearing wall between each two houses, rarely, if ever, extending to the top of the attic. Thus, the whole length of these attics, unpartitioned off in any way, forms a huge horizontal flue, and an excellent ally to the flames. In dealing with an outbreak of fire under such circumstances, it is therefore necessary to take lines in 6 or 7 houses away from the actual scene of the blaze, in order to fight the flames back and to prevent them from gaining complete control and sweeping all before them like so much waste paper. The structural disabilities of such a system are vexatious enough, since tenants are unable to effect any architectural alterations, but the fire risks are tremendous. It is another example of that get-rich-quick policy which does not concern itself with such elemental factors as fire risk and human safety, and is occupied solely with its own selfish ends. In fact, it is no exaggeration to say that the greater portion of fire legislation is concerned with the protection of the individual against the egotistical indifference of those who are ready to exploit him. Fire-resistive construction costs little, if any more, than jerry-building, due regard being taken of durability, security, and reputation, though apparently the latter counts but little in comparison with lightly earned gold. The public, however, is happily commencing to take an intelligent interest in fire control, and the day is drawing to a close when it will be possible to gull the unwary by means of cheap ornamentation and a prolific use of paint. Or perhaps a hint might be taken from Germany, where owner and occupier are held jointly responsible for outbreaks of fire. End of Section 21. Recording by Maria Kasper.
Section 22 of Fires and Firefighters by John KENLON. This LibriVox recording is in the public domain. Chapter 21. The Problem of the Skyscraper. Increasing land values due to congestion in large cities, coupled with advances in the mechanical arts and steel skeleton construction, have ushered in a new and perplexing problem for the firefighter. In American cities, there is no restriction placed upon the height to which an office or commercial building may rise, as long as certain regulations are complied with in regard to the material used. Height is not prescribed by law, but by economic conditions. Were it possible to provide inexpensive elevator service, there is no reason to doubt that buildings in New York would now have 100 stories, as there are already several with 40, and one with 57 floors. In the old type of factory or commercial building, ranging from 1 to 6 stories, the ordinary way of stretching hose lines by stairs and fire escapes provided all the necessary means for the firemen to reach the seat of an outbreak. But in these higher buildings, other methods had to be evolved. Standpipes running from the lowest to the highest floors were introduced. At first, these were crude affairs, often misplaced and also deficient in size. However, experience soon discovered these defects, with the result that in New York an ordinance was passed, which it may be well to quote. In every building now erected, which exceeds 100 feet in height, unless already provided with a 3-inch or larger vertical pipe, and in every building hereafter to be erected exceeding 85 feet in height, and when any such building does not exceed 150 feet in height, it shall be provided with a 4-inch standpipe running from cellar to roof, with one 2-way 3-inch Siamese connection to be placed on street above the curb level, and with one 2.5-inch outlet with hose attached thereto on each floor, placed as near the stairs as practical, and all buildings now erected, unless already provided with a 3-inch or larger vertical pipe, or hereafter to be erected exceeding 150 feet in height, shall be provided with an auxiliary fire apparatus and appliances consisting of water tank on roof or in cellar, and such other appliances as may be required by the fire department. Standpipes shall not be less than 6 inches in diameter for all buildings exceeding 150 feet in height. All standpipes shall extend to the street and there be provided at or near the sidewalk level with the Siamese connections. Said standpipes shall also extend to the roof. If any of the said buildings extend from street to street or form an L shape, they shall be provided with standpipes for each street frontage. As will be seen, this sets a minimum requirement of 4-inch standpipes for all buildings over 185 and up to 150 feet in height, and 6-inch for all buildings over 150 feet. In practice, it was found that a greater diameter was necessary in order to give more water for firefighting, and recently the diameter was increased to 8 inches in buildings over 150 and 6 inches for buildings under that height. At this point, a brief description of a standpipe, its equipment and operation, may not be out of place. The material used is generally galvanized, sometimes ordinary, black pipe. In the case of very high buildings, the main line must be connected by a Y at the street level, giving 4 3-inch inlets. These inlets to the Siamese have clapper valves, serving as checks to prevent the water from backing out. There is also placed a swing check to prevent the water in the pipe from backing out to the street connection when the line is not in use. This is to prevent freezing in wintertime. The object of the pipeline, being connected to a tank on the roof, is to ensure a supply of not less than 3,500 gallons of water, which will enable the occupants of the building to hold in check an incipient blaze prior to the arrival of the department. All house supply lines for domestic purposes attached to the tank must be tapped in at such a height as to ensure at all times the quantity of water mentioned. A check valve is placed at the bottom of this tank on the standpipe line, set to permit a downward flow and to prevent an upward flow in case a fire engine or high-pressure lines are connected at the street level. The omission of this check would prevent pressure on the floor below, as water pumped in would merely overflow from the tank onto the roof. An open hose outlet on the roof will have the same effect, as the writer has more than once observed. Officers should carefully note these points in making inspections. Templates should be provided, and connections at street level, and also those on the outlets on floors, should be tested to see that they comply with department standards. It is a very serious matter, when a dangerous fire is raging in the upper stories of such structures, to find that the connections will not fit the hose, and that water cannot be forced through the standpipes except through the medium of inside connections, a somewhat ineffectual expedient, but that hose lines must be stretched 12, 14, 16 or more stories. To the unthinking, this may represent little, but to the experienced firefighter it means much. Very few men would be able to walk up 14 flights of stairs and then be fit for work on their arrival. Firemen in New York must often climb more than 150 feet, but it is impossible to drag hose lines up to such height. Also, the hose cannot stand the excessive pressure necessary to force water up to this elevation, and even if it were possible, the time employed in doing so would permit the fire to extend to such proportions as to destroy the building. With sufficient material on which to feed, a fire will extend in geometrical ratio to elapsed time, which again proves the necessity of speed in order properly to control an outbreak. All signs regarding pipes should be properly placed. Where there are 2 lines of pipe, one for the sprinklers or perforated pipe system and the other for the standpipe, a mistake or misplacement of the signs indicating their nature will cause serious delay and often great damage. At this point, it may be well to state that perforated pipes are a poor substitute for sprinklers, and should be taken out of all buildings, and the latter installed in their place. The street connections should not be less than 2 nor more than 3 feet from the sidewalk level and at right angles to the building, which facilitates the work of connecting up. Should these connections be out of order, lines can be connected to the outlets on the lower floors by means of a double female connection. The method of procedure is to disconnect the house line, put on an increaser 2.5 to 3 inches, leaving a 3-inch male thread, and this connect to the double female. This will give a 3-inch female connection for the male end of the hose stretched from the engine or high-pressure hydrant. As soon as connection is made, open the valve and start the water. All outlet valves on floor outlets should be of the gate type, which gives a free waterway, whereas the globe type materially reduces the flow. Where several lines are being used on the upper floors of a building, and the 2 or 4 lines connected to the Siamese are overtaxed, the supply may be augmented by connecting to the lower floor outlets as previously described. In New York, standpipes are used in buildings so equipped when the fire is on or above the 5th floor. Below this point, the ordinary method is preferable. The hose provided in these buildings should be of good quality, capable of sustaining the pressure of 200 pounds, and be fitted with 1 or 1.1/8-inch nozzles. In many cases, through lack of attention on the part of owners or agents to keep the hose in proper condition, the firemen fear to trust it and connect up a department hose using their own controlling nozzles for inside work. In order to describe the actual use of these standpipes and the pressure required to force water to the upper floors of buildings on fire, let it be assumed that there is an outbreak on the 16th floor of a 20-story building. The companies arrive and connect to the standpipe, and as the fire is a threatening one, 4 lines are led to the Siamese. Hook and ladder and engine company men proceed to the floor directly beneath the fire, by order of the chief, using the elevator for this purpose. The ordinance requires that night and day elevator service must be provided in all buildings over 150 feet in height. Each company has its instructions, and a battalion chief, in command on the inside, accompanies them. As soon as connections have been made to the Siamese, the chief officer must determine the pressure necessary to furnish effective fire streams on the 16th floor, or an approximate height of 170 feet. The formula for this procedure is to multiply the height of the building by 0.434, but here there is no time for pad and pencil. The best method is to allow 5 pounds for each floor of elevation, and at the height above mentioned it can be readily grasped that the result is 80 pounds, 7 pounds more than the exact formula, but which will be needed as the standpipe goes from the sidewalk to the basement and perhaps to the sub-basement. This gives the column additional length, and as the standpipe often makes a right-angled turn at the basement level, there is an additional loss of pressure at that point. Also, there is a nominal friction loss in the pipe itself. The writer's purpose is not to weary the reader with technical details, but it is necessary to explain this procedure for the benefit of commanding officers at fires at greater length than many other subjects with which firemen are more familiar. Therefore, 5 pounds will be allowed to each story for weight, about 4 pounds friction loss for each 50-foot length of 3-inch hose, 5 pounds loss at Siamese connections, and 10 pounds for entry head at the valve outlet on the upper floors. It will be assumed that there are 2 lengths of 3-inch hose in each line, giving 8 pounds, 5 pounds for Siamese, 80 for weight of water column, and 10 for entry head, making 103 pounds in all. Add to this the force necessary to give effective nozzle pressure, which would be from 50 pounds and upward according to the extent of the fire, and the result is 153 pounds. This, of course, might be varied if a number of streams were taken off the standpipes, as the friction loss in hose and pipe is as the square of the velocity. That is, if water is traveling at the rate of 10 feet a second, the square of 10 is 100, but let the flow be increased to 20 feet per second, and the square is 400, or 4 times as much. Therefore, while the velocity would only double, the friction loss would be 4 times greater. Officers arriving at an outbreak find, as by a predetermined order, that the pressure on the mains is 100 or 125 pounds. They must judge instantly if additional pressure is required, and order it promptly, though it must be remembered that much damage may be done by excess in this direction. The writer once arrived to take command at a fire in a 5-story commercial building. The structure had 50 feet frontage and was 200 feet deep, and the fire had control of the 3 upper floors and was threatening surrounding property. The officer found in charge was asked what he had done and if additional companies had been summoned, as there was but a first alarm assignment at work. The reply was, "No, sir, I did not send out a second alarm, but I ordered 250 pounds pressure on the high-pressure pumps." This was soon after the installation of the high-pressure service, and officers had not yet mastered its proper use. In this case, 125 pounds was quite sufficient, or at most 150, to which point the pressure was immediately reduced and additional forces summoned. The very high and unnecessary pressure might have caused damage to hose, apparatus, pumps, or even men. Officers who wish to master these technical details should study them at leisure in their offices, so that they may be available for instant practice at a fire. The best method of fighting fires in lofts or office buildings of great height is to connect the first line at the outlet floor below the fire, lay the line out free of kinks, and stretch up the stairs. Charge the lines. Never be caught with an empty line in hand when the door is opened. Here is where many a man is injured, for his old enemy, backdraft, is just inside, and the moment the door is opened, it rushes out with superhuman force. Lie low, and like a pugilist duck the blow, and open up the pipe at once. Without going into a scientific discussion of the causes of backdraft, it may be well roughly to define it and to describe its action from a fireman's viewpoint. Plainly stated, it is an excessive pressure on a floor where windows and doors are all tightly closed. As the heat increases, the air expands, causing a greater pressure on the floor than the surrounding outside atmosphere. When a vent is given, there is a blowout, resembling an explosion, for the pressure must be equalized. In other words, the pressure on the floor must be brought down to the corresponding atmosphere on the exterior. The first explosion may be slight, but is often followed by a more dangerous outburst, depending upon the degree of heat on that floor. The influx of fresh oxygen supplies abundant fuel for the flames, and the smoke, which is part of the goods imperfectly consumed, bursts into flame and shoots through the opening. This condition must be guarded against, as men may be caught on the stairs and literally roasted. The sudden outburst of flame may also blow out windows on all sides, endangering surrounding property or the floors above. Another and still more dangerous form of backdraft is where a slow-burning fire consumes the oxygen in a building tightly sealed. A gas much lighter than air results, and this is particularly aggravated by the nature of certain kinds of goods. As is well known, different chemical changes take place in different kinds of material. A vacuum is formed inside the building, and as soon as the latter is opened, there is an inrush of air, which, coming in sudden contact with the gas, causes an explosion. The writer has often seen this peculiar phenomenon. The explosion is preceded by an awe-inspiring silence. Nature seems suspended for the moment while the two elements meet. In an instant, all is wreck and ruin. Men of experience instinctively feel this condition, and the order to back down and out is instantly given. Though, if in a position where they cannot get away at once, men should drop on hands and knees, covering their faces from the wave of flame,
it may pass over without doing damage, when they should instantly arise and keep the pipe open while backing out of danger. Perhaps in all the science of firefighting, no part requires more care and attention than the opening of buildings on fire. Many brave men have lost their lives at this dangerous work. At a fire in the stockyards in Chicago, Chief Horan and 23 officers and men were killed just as the door was opened. There were no windows in the building through which the pressure could be relieved, and the wall gave way under the strain, burying all who were in front of it. Wherever such conditions are suspected, an opening should be made in the roof. This will relieve the pressure and is a fairly safe method. A brief reference must be made to the following important point. In cases where fire has complete possession of 1, 2, or 3 floors in a high building, beyond the reach of towers or turrets, great care should be exercised in placing lines above the outbreak. Companies of men with good streams should be at the doors below in order that the fire may not come out and cut off the retreat of the men above. Buildings of this class have more than one stairway and more than one standpipe, and the least exposed position should be chosen in advancing lines to the upper floors. No line should be sent to an upper floor until the companies operating the one below have gained a foothold inside the door, with a reasonable assurance that they can hold that position. Give as much ventilation as possible in order that the ascending smoke and heat may be minimized. Chiefs should avail themselves of rear fire escapes and every other possible point to get ahead of the fire, for should it once become uncontrollable on the upper floors, men cannot be kept in the building, and a collapse may momentarily occur. In all buildings of this class, fire towers should be provided. These are separate and distinct from the main building, and in order to reach them it is necessary to pass from the floor through a fireproof door onto a balcony outside the building, and through another fireproof door into the tower itself. Or, as a variant to this system, there is a plan whereby every building is to be divided into 2 sections by means of a firewall running from cellar to roof. This firewall would have fireproof doors on each floor, and there is almost no chance of a fire starting simultaneously in both parts of a building so divided. In case of an outbreak in one section, the people on each floor would walk through the fire doors to the other section, shut them on the fire, and take their time to reach the street, and firemen could easily gain a foothold on a floor subdivided in this manner. A standpipe in the former case should run from lowest floor to roof through the tower. Firemen could pass ahead of a fire and attack it on each floor with perfect safety. For rescue of occupants, this means, combined with the aforesaid horizontal fireproof partitions subdividing the floor area, would make these buildings safe for public and firemen alike. Add to these 2 indispensable requisites a thorough installation of automatic sprinklers, and the high building would be shorn of its terrors. In conclusion, the writer feels that after the foregoing pages, with their somewhat technical details from the layman's point of view, it may not be without interest to give some slight description of the greatest skyscraper in the world, the Woolworth Building of New York. Incidentally, this gigantic block of masonry was designed by its namesake as a memorial of his earthly success and to the glory of the commercial enterprise of America. Including basement and sub-basement, it consists of 57 stories and rises to a height of 790 feet above sea level, with a main frontage of 150 feet. Thus it will be seen that its height is 5 times its own width, and it is less than 500 feet short of the Eiffel Tower. It is, of course, of fireproof steel frame construction. The preparations for the foundations were begun in August 1911. On May 1, 1913, the doors were thrown open to tenants. This represents a period roughly of 20 months, during which time nearly 3 stories must have been added every 30 working days. Besides containing business premises,
which incidentally are arranged as regards floor space to suit the wishes of the tenants, it is equipped with 2 restaurants, one in the cellar and one on the 29th floor, Russian and Turkish baths, a swimming pool, and an ice plant. All window frames within 30 feet of any other building are of hollow copper glazed with wire glass. It has 4 enclosed stairways of iron and marble, though only one extends to the top of the tower. There are 28 passenger elevators built on the most up-to-date fire-resistive principles. For the protection of the building, the following equipment has been installed. There are 6 6-inch risers running from the sub-cellar to the 30th floor, 2 from the 31st to the 41st floor, and 1 from the 41st to the 55th floor, fed by tanks on the following floors. 1 tank, 6,300 gallons, on 14th floor, feeds from sub-cellar to 12th floor. 2 tanks, 10,000 gallons, on 26th floor, feeds from 13th to 24th floor. 1 tank, 3,100 gallons, on 37th floor, feeds from 25th to 34th floor. 2 tanks, 1 6,700 gallons, 1 3,200 gallons, on 50th floor, feeds from 35th to 48th floor. 1 tank, 1,200 gallons, on 53rd floor, feeds from 49th to 53rd floor. There are 4 outlets above this tank with no supply. The main riser, 6-inch, has checks on the 14th, 27th, 37th, 50th, and 53rd floors, with checks on the horizontal run. There are 2 suction tanks in the sub-cellar, 1 30 feet by 9 feet by 9 feet, 1 15 feet by 9 feet by 9 feet. There is a swimming pool in the sub-cellar Turkish baths, which can be used as a suction tank, with a capacity of 30,000 gallons. There is 1 Dean electric pump, 3.5 feet by 6 feet, with a capacity of 300 gallons per minute. There are, in addition, 5 Worthington steam pumps as follows. 1 20 feet by 9 feet by 18 feet, 500 gallons per minute. 1 20 feet by 10.5 by 15 feet, 500 gallons per minute. 1 14 feet by 6.5 by 15 feet, 150 gallons per minute. 1 14 feet by 6.5 by 10 feet, 150 gallons per minute. 1 12 feet by 4.5 by 10 feet, 80 gallons per minute. All pumps can be operated singly or collectively, and are supplied by street mains as follows: 1 6-inch from Broadway, 2 3-inch from Park Place, 2 3-inch from Barclay Street. Such are a few details of this extraordinary structure, which may be expected to house daily some 10,000 souls, and there is no reason to believe that finality has been reached. Room must be found for the teeming thousands who throng to the business section of New York, and expansion must occur by the way of least resistance, upward. End of Section 22. Recording by Maria Kasper. Section 23 of Fires and Firefighters by John KENLON. This LibriVox recording is in the public domain. Chapter 22, Apparatus for Firefighting. Not since the first fire department was organized in ancient Rome has there been such an awakening as at the present time, and all countries are vying one with the other in the development of fire-controlling and fire-preventing appliances. In fire control, the greatest effort is being made to develop motor-propelled apparatus and motor-driven pumps. The method of propulsion is almost perfected, as all that was necessary was to apply the principles so successful in moving pleasure and commercial vehicles to fire apparatus. But with the motor-driven pump, matters are somewhat different. Perhaps no mechanical device used in the control and extinguishing of fire has reached such a high state of perfection as the steam pump. To discard this time-honored and often severely tried machine for a practically untried device, untried at least under severe conditions, such as being forced to deliver water under high pressure for 35 or 40 hours or longer, would be unwise. Many American cities have a fire hazard due to old and faulty building construction, narrow streets, and severe weather conditions, where it would be almost criminal to install a new type of apparatus until it had been tested in places where the risk would be limited. It was the feeling that absolute reliability must be guaranteed which caused many cities to hesitate in adopting the motor-driven pump. An extensive field was found, however, for this type of apparatus in suburban settlements and in small towns. In these places, the fire force is usually a voluntary one. Horses are not always available, nor can fuel be easily supplied, and should it happen that there is not sufficient water pressure in the mains, a motor-propelled and motor-driven pumping machine is a great boon. It requires but one man to take the machine to the scene, and it can be accomplished in 1/10 of the time required for a horse-drawn or hand-pulled engine. Time is all important in such cases, and as the run is often long and the gradients heavy, great damage may be done before the arrival of the firemen or apparatus, which usually results in the total destruction of the building involved. Therefore, in such places and under such conditions, motor-propelled apparatus is, and motor-propelled pumps may be, desirable. But in large cities, where great congestion intensifies the fire hazard, the first efforts of manufacturers were not successful in producing a motor-driven pump to meet the requirements of the fire department. The scrap heap was large in those days, but there is some evidence that it is diminishing. Manufacturers found by the only reliable method, that of experience, that some of their pet ideas were not feasible. Chiefs of fire departments discovered this to their cost, but out of the confusion is being evolved a fairly good motor fire engine. Naturally, it is still lacking in the perfection of the steam pump, but when it is considered that 50 years were required to develop that apparatus, it must be allowed that in possibly 1/4 of this period, a most excellent motor-driven pump will be in use. The steam pump was brought to perfection along the line of reciprocating motion, steam being particularly adapted to this movement, as shown in all kinds of steam engines, marine, stationary, etc. But the application of a somewhat different force, that of gas explosions, to a piston, developing what is practically a rotary motion, the writer is inclined to think will not be so efficacious. For any man to attempt to condemn the reciprocating system would be folly. It may work, and as a matter of fact does work fairly well, several firms having turned out average machines of this type. But in converting one motion to another, there is necessarily the introduction of more complicated gears and a multiplicity of parts, often hard to reach in case of repairs, and there is in any case a loss of power in transmission, which would seem to militate against the piston pump. As some pin their faith to the reciprocating style, so others favor the rotary. This type seemed to promise success, as there was no conversion of motion, and the gear was much simpler. However, some new and many old defects showed up, and the great fault of excessive slip, known to exist in all rotary pumps when run at high pressure, was still apparent. Close-fitting casings, with the introduction of improved springs behind the gibs, seemed to promise success, but under severe trial were glaringly defective. No chief of experience could be satisfied with this. The manufacturers greatly improved the old rotary type of 25 years ago, the diameter of the shaft being increased to take out spring under a high pressure. The shafts were shortened for the same reason. Water pockets between the gears, which gave a back pressure, were changed by tapping into the pocket or hollowing out the casing and piping around to the discharge. but still there is room for improvement. When a very high pressure is required, a point is reached when a rotary pump acts almost like a piston pump, each gear striking a blow exactly like the plunger when the point of closest contact to the casing is reached. This is bound to jar injuriously the entire machine, and to wreck it unless it is very strong. Such are a few of the defects which came under the writer's notice when watching tests. There are many things to be said for and against all types, but the opinion may be hazarded that even the makers of these rotary or gear pumps know and admit that this apparatus is not yet the equal of the steam pump. Another type tried with moderate success is the centrifugal. That this would be an immediate success there is not the slightest doubt, were it not that, like the reciprocating pump, it is somewhat difficult to use it in conjunction with the motor. In order to obtain a centrifugal pump which will deliver 750 gallons of water per minute at 130 pounds pressure per square inch, and come within the weight practical for fire apparatus, it must run at a speed of 16 to 1800 revolutions a minute. For fire apparatus, at least, this is not practical, for a new difficulty arises, that of cooling the cylinders. High speed is possible in fast-moving cars when a strong current of air is forced through the radiator, but in fire apparatus, standing stationary at a fire, the designers are confronted by very different conditions. Therefore, in order to obtain the speed, a differential of at least 2 to 1 is necessary, or the other alternative must be used, that of increasing the size and driving direct at the same speed as the motor. In the one case, there is the differential gear with some loss of power, and in the other a slow but much heavier pump. Could a motor be built that would directly drive a centrifugal pump at a speed of 1200 revolutions a minute, it would be the ideal type for motor apparatus. And the writer believes that one will soon be obtainable. As already stated in this volume, there are various devices for raising aerial ladders, some mechanical, others electrical, and still others by means of compressed air. It is not the purpose to here enter into an explanation of how these devices should be operated, as any intelligent fireman can learn their use in half an hour, but a word may be said as to the placing of the ladders themselves. The writer has often seen ladders in such a position that it was quite difficult to work on them to advantage, whether the work was rescuing persons or operating lines. In order to obtain a clear idea of the proper position in which to place a truck so that an aerial ladder may be properly operated, let it be assumed that the ladder is to be raised to a window on the 6th floor of a commercial building. This would be about 65 feet from the ground, as the first floor is about 15 feet and the others about 10 in height. The approximate measurements can be determined by a practical truckman at a glance, and the truck should be set about 16 feet from the building, with the center of the turntable in line with the center of the window. The point of the fly ladder should extend about 15 inches above the sill, but care should be taken in placing the same that it should not be permitted to rest heavily on the sill, but should be lowered to within a few inches of it. As soon as the weight of a body is near the top, it will cause the ladder properly to set against the window ledge. Should the ladder be originally placed as above, there is no danger of its buckling in the center. Reference is made to this matter of properly placing ladders on account of the great difference in the width of sidewalks, and some officers accept the sidewalk as an infallible guide. Of course, it is not intended that the space should be measured off with a 2-foot rule, but a little thought and experience works wonders, and if they would only practice with ladders of various sizes, they would quickly pick up the faculty of placing them in the proper position. In the New York Fire Department, frequent drills are held, and it is surprising to see how rapidly even untrained men grasp the idea. A poorly placed ladder at a fire is inexcusable. For those who care to go into the subject a little more deeply, and perhaps to practice at the drill school with Apparatus, the following rule may be helpful. Divide the height to which the ladder is to be raised by 5 and add 3. Thus, take a 35-foot ladder. 5 into 35 goes 7 times, add 3, and the result is 10. So the butt of the ladder should rest about 10 feet from the building. Or, again, a 75-foot ladder should be placed approximately 18 feet away, and so on. This rule is not worked out to inches, but it constitutes a fair guide when sidewalks are very wide or the reverse, and affords the officer in charge a working basis. A few words may perhaps be appropriate at this point, anent a unique feature of American fire practice, namely the water tower. This apparatus consists merely of a lattice-work tower mounted on a quadrant, through the interior of which passes a hollow tube, through which, again, an extension tube, on the telescopic order, is fitted, in such a manner that it may be extended in a similar way to the extension ladder. When fully extended, the tower is between 65 and 70 feet. When not working, it is kept in a horizontal position, being raised when necessary either by hydraulic pressure or by springs. It is especially useful in fighting fires in high buildings, and that its adoption is not general in Europe is due to the fact that local conditions are not as a rule such as to necessitate its employment. Nonetheless, the following details may be of assistance to fire chiefs in all parts of the world. In many small fire departments, and for that matter in some of appreciable size, it is customary to use the bed ladders on trucks as water towers. Not being possessed of the latter apparatus, chiefs are obliged to use a makeshift in order to get a nozzle into an elevated position at fires where a ladder cannot be lowered against the building. A ladder pipe, after the style of turret pipes used on wagons and water towers, should be permanently attached to the underside of the ladder and securely fastened. A length of 3-inch hose is attached to the pipe and strapped to the ladder with a Siamese connection on the ground. Should a water tower be needed, this will effectively take its place. Run in 2 lines, connect to the Siamese, raise the bed ladder to the desired position, and the stream is controlled from the street by guys, or a man may be sent aloft to direct it. If it appears cumbersome to have an entire length with the Siamese attached, a short length of about 10 feet may be used, and it should be kept in position with the pipe near the end, and in case a water tower is needed, the short length is connected with a length of 3-inch hose carried for the purpose. This will bring the Siamese to the street level and will give mobility to the line. In case there is no stationary pipe on the ladder, an open nozzle should be connected to a length of 3-inch hose and laid on the ladder with the nozzle pointing through the rounds about 2 from the top. It must be lashed in position, and if the company contains a practical or even an amateur sailor, he should be employed to make the knot. Landsmen ought to be well versed in making such knots in advance, as it is useless to instruct a man in such work at a moment when celerity is most necessary. A word of caution should be inserted in connection with the use of aerial ladders as water towers. Although the writer is aware that a ladder so converted is still available, all ladders should not be used for this purpose. Persons in the building may be cut off by the flames, or if the firefighters are pocketed, a long ladder may be necessary in order to effect their rescue, and judgment must be used in the number of ladders which may be transformed. Although all that is necessary to do is to shut off the water, disconnect the lines, lower the ladder, ship the steering wheel, and move the truck to the point where it is needed. But it must be remembered that this will take an appreciable length of time, and the fire, sweeping toward the imprisoned people, will not await the convenience of the department. Hence, use caution before converting an escape into a water tower. As to the success of the gasoline motor for hauling apparatus, there can be no question. The experimental stage has passed, and that of certainty has arrived. The main point is whether the motor should be built in as an integral part of the apparatus, or whether it should be detachable and be in the form of a tractor. In some ways the latter seems preferable, since, should anything happen to the tractor necessitating extensive repairs, it is easily disconnected, another tractor attached, and the apparatus kept in service. It appears that this style of traction is coming into general use, and the writer believes will be universally adopted both in fire departments and commercially, as time demonstrates its utility. It is beyond the scope of this work to enter into a detailed description of each part of the motor apparatus, but rather to afford some general idea of what experience has taught. A word may be said here anent the storage battery. Many fire chiefs express a strong preference for this style, and like everything else, it is possessed of some good points and a number of bad ones. Thus, the batteries deteriorate rapidly when standing still, and are expensive to replace. For effective fire service, it is necessary to have a set charging continuously, while for heavy grades it is not as certain as gasoline. On the other hand, it is easier to operate, and is certainly more reliable for starting away in response to an alarm. While still in the experimental stage, it is worth watching, for there is no saying what developments may occur which will remove its present disabilities and place it beyond the sphere of the problematical. The intention of the writer is not to express a decided preference for any particular type, but rather to indicate the strong and weak points of apparatus, leaving individual chiefs to assess the merits or otherwise of the machines dealt with, and thus form their own conclusions. In operating water towers and extension ladders, that is, in raising and lowering them, there are several devices, electrical, mechanical, spring, and hydraulic, all of which have points in their favor. The electric motor can raise an extension ladder with rapidity, and the spring is equally good, some even considering it more certain. Hydraulic power or springs can be employed in raising a water tower. As before emphasized, locality must govern choice, and public money should not be lightly spent. In fact, the best test is to consider whether, were the purchaser paying for the apparatus out of his own pocket, he would consider it wise to spend the money. In the foregoing, a brief description has been given of the major pieces of motor apparatus, and it is now advisable to consider their operation. Hose wagons and runabouts possess no technical features, with the exception that they should be strongly built and with sufficient power to carry the loads placed upon them over rough paving and heavy gradients. But the fact should be appreciated that though a piece of apparatus may be seldom in motion, when it is needed it must travel like the wind. All departments have recently shown a tendency to run the hose wagon, equipped with chemical tanks, ahead, as a kind of scout. The writer thoroughly approves of this method. As has been frequently repeated, time is everything in firefighting, and a few seconds gained may prevent great loss of life and property. The fast-moving wagon arrives on the scene before the heavier engine, and attacks the fire with chemical lines, remembering in all cases to stretch 2.5-inch lines from the nearest hydrants. Upon the arrival of the engine, connection is quickly made to the hydrants, and preparations commenced to start water in these lines immediately, should the condition of the fire warrant such an operation. The old adage, "Never send a boy on a man's errand," should be borne in mind, and therefore never trust entirely to a chemical line. Although it may extinguish the fire and thereby decrease the fire loss, it is utterly useless should the outbreak assume great proportions, and under these conditions a good stream of water is an absolute requisite. In residential districts where the houses are detached, chemicals will extinguish many fires with the least possible loss. But their use should not be attempted in commercial buildings where great quantities of goods are stored, until science has given us a far more effective gas than is at present available. In employing a chemical stream, it should be directed low, as it is not the quantity of liquid which extinguishes the fire, but the gas arising from it which does the work. as it is evident that in order to get the best effect from chemical streams, the gas should be confined. Such streams are of no avail in the open. Where a stream of water is used, the correct method is to strike the ceiling with the stream on entering a room, which distributes the water. Should the entire contents of a small room be involved, the water is spread out like a fan over the whole area, when, as the writer's old mentor used to say, a dash will put it out. The next points to be considered are engine and high-pressure streams. As the homeopathic and the allopathic doctors always disagree about the strength of a dose of medicine, so there is always a difference of opinion amongst fire chiefs as to the size of nozzles to be used and the pressure required in delivering streams at fires. In the old days, the volunteers christened their machines the Niagara, the Cataract, the Deluge, names to denote overwhelming power, as it was the idea to drown everything in sight. Even today there is evidence in some quarters that this desire still remains. Nozzles 2, 3, and even 4 inches in diameter are sometimes used. Naturally, common sense should govern the matter, for though there are instances where one powerful stream may save the day, there are others where several small streams are far more effective. Take as an illustration the case of the Equitable fire. The strong gale drove the fire toward Nassau and Cedar Streets, the latter only 27 feet wide, and the former about 45, and the flames raged along Cedar Street for a distance of 375 feet, and on the Nassau Street side for nearly 200 feet. Here was a line of 575 feet to be protected, in narrow thoroughfares where the high buildings had windows of plain glass. 1, 2, 3, or even 4 powerful streams would not have had the desired effect. It required a perfect water curtain along the entire front, and the only way to accomplish this was to cover the buildings with a deluge from small streams, supported by 2-inch streams from the water towers to drive the fire back. Such an effective curtain resulted from this method that not a single pane of glass was broken in the windows of the exposed buildings in the streets mentioned. It was as though a heavy musketry fire from an entrenched army, backed by a few pieces of artillery, had checked the advance of a storming party. That this was wonderfully successful may be gathered from the Underwriters' report, which states that it was effective to a remarkable degree, and the writer would add was the only means under the conditions existing at this fire which would have accomplished the desired result. This is the homeopathic method. Now consider the allopathic side. To give an example, last autumn an explosion took place in a sulphur works built on a dock in Williamsburg, borough of Brooklyn. A strong southwest wind was blowing, and directly across the street were situated the oil yards of the Standard Oil Company, while at a distance of only 45 or 50 feet were extensive hay sheds 1,000 feet in length. A more dangerous combination is difficult to conceive. A fourth alarm was immediately transmitted by the district chief on his arrival, followed by a borough call which brought another third alarm assignment. On the writer's arrival, he found a most dangerous fire confronting him. The entire building of the sulphur works was involved, the flames shooting 100 feet into the air. The hay sheds had ignited, and the flames were rolling over the oil tanks to leeward. Deputy Chief Langford, with 8 engine companies and a fireboat, was assigned to the leeward position in the oil yards, and 6 companies under Deputy Chief Lally were placed in the street between the hay sheds and the latter. Although the water supply was ample, the combined force of these 14 companies using powerful streams was not sufficient to drive back the wave of fire which momentarily threatened to envelop the oil yards and bring great destruction to life and property. The fireboat, Abram S. Hewitt, had worked her way in to within 75 feet from the head of that threatening and destructive sea of fire. She was operating about 8 1 3/4 inch and 1 1/2 inch streams. The order was given that all streams should be shut down with the exception of 2 1.5-inch, which were operating under Langford in the yards, and that a 3-inch nozzle should be put on the large monitor at the top of the pilot house. The full force of the pumps was then thrown into that nozzle, giving a pressure of 145 pounds and a discharge of more than 3,000 gallons per minute. The effect of this was to crush the head of that fiery wave and roll it back and hold it, giving the men operating the smaller streams a chance to advance. Compare the two examples. In one, a threatening fire had spread over a great area. In the other, a terrific wave of flame was concentrated within a narrow space. A cyclone in the first instance, a tornado in the second. So it will be seen that in firefighting, both homeopathic and allopathic methods are required. But if the fire can be extinguished with a small stream, a large one should never be employed. How best to judge the size of the dose the writer is unable to tell. As each doctor diagnoses his own case, so each chief must make his own working diagram. And like some physicians, many firefighters have better discernment and keener judgment than others, sometimes born of greater experience, and sometimes more or less intuitive. All countries are looking for good men and paying liberal salaries, and each must study and fit himself for the ordeal. No maps or charts are available. The surroundings must be noted, and the decision must be prompt and effective. The intelligent operation of apparatus by members of firefighting forces is an absolute essential successfully to cope with their enemy. The direction of streams at a fire is almost akin to gunfire from a battleship. Shot and shell can be, and indeed very often are, wasted due to defective gunnery. Streams thrown into a building at an improper angle are useless, when, by a little judgment on the part of the officer in charge, much more effective work could be accomplished. This is particularly true of water towers and turret pipes. In placing a tower in front of a building, a little quick thinking on the part of the officer in command of the apparatus would often make a great difference. To begin with, a tower should never be placed far to windward except under orders from a superior. 99 times in 100, the fire will work to leeward, so the tower should be in the position whence the fire can be fought back from that side. The mast should be extended high enough to give the stream an arc which will enable it to strike the ceiling of a particular floor about 20 to 30 feet inside the window. As in gunnery practice, the best arc is at about 40 degrees elevation, but as a tower stream is not directed at a target, but must be operated over the entire front of a building, judgment should be used in its placing and elevation in the beginning. In connecting lines to a tower, deck pipe, or turret pipe on a wagon, about one length, 50 feet, of extra hose should be allowed. This is to give the apparatus a certain degree of mobility, as it often becomes necessary to move a tower or a wagon, and should there be no spare line, it cannot be accomplished. Officers ordered to connect to water towers or wagons should bear this in mind. Too much rigidity is undesirable, and by having 50 feet of range in front of the burning building, much more effective work can be accomplished, especially in these days when motor apparatus is so easy to move. While on this theme, it may be wise to touch briefly on the size and pressure of streams. The use of a water tower or of a wagon turret pipe presupposes the necessity for water under high pressure. Some chiefs have contended that a higher pressure than 100 pounds at the nozzle is impracticable, saying that when the pressure goes over this nozzle velocity, it is so high that the stream is torn to pieces, whipped into a foam, causing it to break and scatter a few feet from the nozzle. This contention is only partly true, for admitting that the higher the nozzle velocity, the greater the tendency of the stream to disintegrate. On the other hand, the higher nozzle velocity gives a greater volume and a much heavier striking force. These latter are prime requisites in firefighting. A blow struck or a thrust delivered with moderate strength has not the same effect as a blow with good muscle behind it, and in big fires it is often the power of the blow which counts. The stream which strikes with force will knock out the fire as a prize fighter knocks out his opponent. The writer favors higher pressure when necessity demands, though this is again a matter of judgment. In the Army and Navy, rangefinders are employed to enable officers in charge of guns to sight properly and direct their fire. Firefighters operate under such conditions that many times they are unable to see even the buildings, much less the windows or openings through which the streams are to be directed. In such cases, all must be left to judgment and experience. When a heavy body of fire is rolling out of a building, the writer would use a nozzle pressure of from 100 to 150 pounds. This gives volume and that striking force which, as already stated, are absolutely necessary in many instances. Before passing from this subject, it may be well to give a rule by which men may be guided in placing apparatus of the type under consideration. Good firemen fight at close range, and it is seldom that the occasion arises which keeps them at a distance. But under such conditions a stream will do effective work, allowing 1 foot of distance for each pound of nozzle pressure up to 100 pounds. Above this point it is a little less, but it is useless to go further into this matter, as the occasion should never arise when it is necessary to fight a fire at a greater distance than that of 100 feet. In some instances, the actual distance covered by the stream is greater when the nozzle is at, on, or near grade level. The point of delivery may be 50 feet above grade level, and those who care to amuse themselves and at the same time improve their knowledge can use the old rule: the square root of the sum of the squares on the two sides of a right-angled triangle is equal to that of the hypotenuse. The main point is to know the distance to which a certain pressure will deliver effective fire streams. Hydraulic engineers like J.F. Freeman and others give distances, always under settled weather conditions, but a fire chief cannot wait for a calm day, so the confronting conditions must be figured out. A little thought will make a most wonderful improvement, and it will be found by experience that men can estimate within a few pounds of the exact pressure at a nozzle. This will be treated exhaustively in the appendix. In dealing with the effect of additional lines in the tower, deck, or turret pipes, it must be stated that in most departments the orders require a company stretching to the tower, deck, or turret pipes to lay in 2 lines. Now, if a 2-inch nozzle is used on the tower mast, much better streams will be obtained by immediately adding another 3-inch line. It may be assumed that a nozzle pressure of 100 pounds is required from a 2-inch nozzle. This is equivalent to a discharge of 1,200 gallons of water per minute. In order to obtain this pressure, each of the first 2 lines would be delivering 600 gallons per minute, and the addition of the third line would cause this flow to be reduced to 400 gallons for each one. As the friction loss is equal to the square of the velocity, and as the velocity is governed by the flow, the result would be something like this: 400 times 400 equals 160,000, 600 times 600 equals 360,000, or as 16 is to 36. Therefore, friction loss would be more than twice as great as in the first case. This takes the writer back to the source of supply, whether it be a fire engine, a high-pressure pump, or water under force of gravity, which becomes the determining factor as to what pressure should be. If it is decided to force 1,200 gallons per minute through 2 lines, the pressure must be higher at the pump than if the same quantity were forced through 3 lines, in order to give the same nozzle pressure. In the case of water delivered under high pressure by pump or force of gravity, where there is a predetermined pressure, the additional line gives a better flow, less friction loss, and consequently a higher nozzle velocity. The chief officer must determine whether it is better to attach the additional line, thereby taking up the services of an engine, or to use the third opening in the hydrant to which a line might be connected for service at some other point where it was badly needed. In this chapter, the writer has had no thought of actually discussing fire strategy. All he has hoped to do has been to point out some of the situations which develop at fires, and to impress upon those responsible that their minds should act quickly and that all contingencies should be met with promptitude. End of Section 23. Recording by Maria Kasper. Section 24 of Fires and Firefighters by John KENLON. This LibriVox recording is in the public domain. Chapter 23. The Two-Platoon System. Any consideration of the factors governing firefighting would be incomplete were the personal equation neglected. In other words, the status of the fireman in relation to the community as a whole. The foregoing pages have made it abundantly evident that he who wishes to follow the calling as a life's work must be possessed of qualities out of the common. Apart from pluck and physical endurance, he must be prepared to attack the subject from its scientific standpoint and to devote to it his undivided interest and attention. That is to say, if he would rise superior to his volunteer predecessors. And it must never be forgotten that these latter brought unlimited enthusiasm to their self-imposed task, if nothing else. But in these days, firefighting has passed the stage of the dilettante. It has grown into a serious science, and as such has a right to demand that its votaries shall be experts in their own line, and that the huge responsibilities of lives and property entrusted to their care shall be no haphazard proceeding, but the result of serious consideration and selection. Now, latterly, a feeling has sprung up which roughly propounds the theory that the fireman should be the hired servant of the municipality, nothing more and nothing less. His engagement is to be of a temporary nature, bounded only by so many hours' work per diem for so much pay. He is to be considered, when not actually on duty, as free as the butcher, the baker, and the candlestick maker, and from the moment when he leaves his fire station, what he does and how he does it is to be his own business and no one else's. This is, to all intents and purposes, what the advocates of the two-platoon system would have the public believe is to the advantage of fire departments the world over. For 12 hours the fireman is to be on duty, and for the other 12 he is to be a private citizen, free from all trammels and restrictions which might tend to hamper his sacred liberty. It is a high-sounding and truly attractive doctrine. Only, having due regard for the efficiency of this most important of departments, how can such a method be expected to yield satisfactory results? In France and Germany, the barrack system is worked, no doubt, to an extreme, which would be distasteful and unpopular in any country where conscription was not the general practice. There, the fireman is practically under military law, and the slightest breaches of discipline are punished with martial severity, whilst individual freedom is necessarily much curtailed. But there is no advantage in riding a hobby to death, and both in England and in some cities in the United States, a via media has been evolved, different in detail but alike in essentials, which ensures the efficiency of the service and discipline with the least possible inconvenience to those concerned. In England, the fireman is a municipal servant. He is provided with quarters, whether married or single, and is granted so much leave every year. In addition, he receives free medical attention and certain allowances according to the town in which he happens to be serving. But all the time, when not absent with permission, he is available for duty, as is the soldier or the sailor. This appears a common-sense system of enabling a municipality to assess with some degree of certainty the probable fire risks it will be called upon to incur should it either increase or decrease the fire department, while it can always count upon the services of its enlisted men. New York has gone further and allows its firemen to live at home, have their meals there, and to spend their spare time in the society of their families, far removed from the noise and bustle of the average fire station. In fact, the system evolved may be taken as one of encouragement to home life and happy surroundings, the antithesis of arbitrary militarism and the curtailing of the individual's freedom. Only the demands of the situation are such that it is imperative that at all times and seasons the men of the department, except when specially excused, should be available for instant duty. Now, though comparisons may be odious, what alternative system is advocated by the upholders of the two-platoon theory? For 12 hours, one watch or division of men is to be employed, their place is taken by another group of similar strength. And supposing some great conflagration occurs demanding the combined energies of the entire department, what then? Presumably, messengers would have to be employed to whip up the contingent off duty, who from their standing would be within their rights in demanding overtime, who perhaps could not be found, and if found might demur to answering a call which was not obligatory, and who from their anomalous position might be forgiven if they imported an opera bouffe touch into subsequent proceedings, and kept a fire burning so long as might suit the financial status of those principally concerned. In addition, what guarantee would be forthcoming that the night shift would arrive in the best of conditions to carry out arduous work if called upon to do so? It has been proved from experiments made along these lines that it is by no means uncommon for the so-called fireman to practice his trade as bartender or undertaker all day and then turn up at the station in the evening for fire duty in order to make a little extra. It goes without saying that that species of extra time is costly alike to human life and property, and that a fire department built upon such principles is indeed founded upon sand. The truth of the whole matter would appear to be, in the opinion of the writer, that amongst the younger generation there is a strong aversion to discipline, even of the broadest kind, which interferes not at all with the liberty of the subject, and is only ordained that some systemization of duty and responsibility may result. Further, it is of paramount importance in these days of labor unrest that any body so vitally essential to the welfare of the public at large should be safeguarded from any interference from labor organization outside itself. Once the department becomes analogous with street railways or dry goods stores for its labor supply, then a long farewell may be said to any continuity of action, of policy, of training, and of general organization. Men will come and go at will, bearing in mind that their status is no different from that of any other daily worker. Esprit de corps, a vital force in firefighting, will vanish, and in place will be instituted a body devoid of any other consideration than that of making that little bit extra. An inspiring ideal, in truth. End of section 24. Recording by Maria Kasper. Section 25 of Fires and Firemen by John KENLON. This LibriVox recording is in the public domain. Chapter 24. Underwriters and Salvage Corps. Although not actually connected by organization with the fire department, at least in the United States and England, the Salvage Corps is nonetheless an important essential in the whole scheme, and as such demands some attention in a volume of this kind. The business of the firefighter is, as his name indicates, to fight fires. The saving of property and merchandise from the effects of water is the particular field of the Salvage Corps, and thus it is that separate organizations have been evolved for this express purpose. In New York, this work is officially recognized and supported by all the insurance companies doing business in the city, supreme executive control at fires being vested in the officer in charge of the firefighters. In fact, the Salvage Corps might not inaptly be compared with the medical and nursing branch of an army. A battle occurs, and obviously the combatants have no time to look after the wounded or to succor the dying. Their business is first and foremost the crumpling up and defeat of their antagonist, and until that is accomplished, all other considerations are relegated to the background. But humanity demands that the stricken shall be saved if possible, and that suffering shall be alleviated. Hence the presence of a large staff of doctors and nurses who otherwise have no connection with the events of the moment. They are distinct from the fighters, but admittedly necessary to them. Further, of course, they are under the supreme authority of the general commanding. Anything in the nature of divided control would be fatal alike to all concerned. This brief explanation is rendered necessary, since the functions and position of those operating in Salvage Corps is too little understood, and in fact their present status of a semi-independent entity is anomalous and not in the best interests of all parties. Now, who are the persons involved? Firstly, property owners themselves, who, whether insured or no, are at least presumed to desire as little destruction wrought to their goods as is possible, which can often be accomplished by covering up, wiping down, and pumping out. Secondly, the insurance companies, since with this assistance they may save the wastage of a complete loss, and at any rate realize a small proportion of the risks involved. Hence it is that a regularly paid corps of professional salvage men is maintained at the expense of these companies in some of the great towns of America and in London, those in the United States being generally known as fire patrols. The strength of the New York Corps consists of 38 officers and 190 men, divided into 10 patrols. The salvage wagons in service are of the usual type, carrying such apparatus as covers, door openers, axes, shovels, squeegees, and other equipment especially suitable to their needs. During the last year for which figures are available, 8,415 outbreaks were attended, the most calls in any one month being 802 in December. In that month, the duration or service amounted to 755 hours, while 3,531 covers were spread and 136 roof covers placed in position. Chicago maintains a corps of 8 companies consisting of 71 permanent and 33 auxiliary men, the work accomplished, having due regard to the territory involved, being efficient. Incidentally, annual reports are issued giving statistics anent the forces together with figures of the values they have protected, which of course is as it should be, and is only mentioned as a comparison with the extraordinary anachronistic condition of affairs in London. Here is the largest city in the world, with property values almost beyond estimate. It is asserted that the per capita loss is insignificant compared with that of American cities, but at the same time it would be imagined that salvage service would be carried out upon certain well-established lines. Yet, as a matter of fact, the London Salvage Corps, to give it its official title, is a purely private organization, equipped and supported by certain of those insurance companies underwriting fire risks. The word certain is used advisedly, since not all of those dealing in the local fire risks subscribe. Hence it is a purely private undertaking, and as such responsible to no public body except in the same degree as a private individual. No annual report is published except to those directly concerned. The strength of the Corps in officers and men is not officially issued, and any statistics of property values, percentage of losses, etc., if tabulated at all, are certainly not forthcoming from this body, at present benignly commanded by Colonel Fox. Of the annual report, such as it is, the following excerpt from a letter speaks for itself. At the end of the year, a brief, confidential statement is given out to the members, which statement is not illuminating in details. In other large English cities, salvage arrangements are altogether lacking, as is also the case in the smaller American centers of population. The reason for this is not far to seek. If the insurance companies have to pay the piper, they cannot be expected to establish in communities with minor property values
organizations which, on the face of it, must be costly experiments. Hence, 2 clauses of objection may be framed upon the existing state of affairs, which cast no slur upon those intimately concerned, but are simply concomitants of an archaic system. Firstly, no matter how cordial the relationship existing between the fighting force and the Salvage Corps, and no matter how rigorously it is insisted that the chief is in supreme control at an outbreak, with the best intentions in the world, on occasion misunderstandings are bound to arise, which, if not hazardous, are at least unpleasant, unnecessary, and not in the best interests of discipline. There is always the natural tendency for the subordinate to resent taking orders from any other than his superior officer, and though the chief and his aides may be recognized by the non-combatant forces as in executive command, at a large fire neither the chief nor his staff can be everywhere, and orders have to be transmitted, which, to comply with the hard and fast etiquette of the situation, would be cumbersome and impossible. Therefore it would appear a common-sense policy to arrange some form of amalgamation. This should offer no insuperable difficulty, as some method of meeting the additional cost could be evolved in consultation with the insurance companies. Which introduces the second clause. As at present arranged, the maintenance constitutes a severe tax upon those concerned, and there is no doubt that better administration would result from the Union. In addition, there is no reason why the individual property owner should not bear his share of the costs involved in the saving of his goods from unnecessary damage by water consequent upon fighting a fire. Of course, it may be argued that if he is already insured, he is paying twice. But the adjustment of premiums under such circumstances would be a matter of no great moment. Certainly, in New York, and in America generally, there is this to be said for the Salvage Corps, namely that they are responsible bodies maintained by statute, and thus under the supervision of recognized authorities. In England, however, there appears to be a total absence of organized departmental control, and the relationship existing between the London County Council, which supports the London Fire Brigade, and the London Salvage Corps, which is as much a private concern as William Whiteley or John Wanamaker, is purely dependent upon the goodwill of the former. In fact, to go a step further, it is hard to see what means could be adopted if the County Council vetoed the presence of the Salvage Corps at fires. Of course, such an occasion would never arise, only in marshalling fire forces, as in marshalling the array of an army, nothing should be left to chance, nothing should be haphazard, and all contingencies should be foreguarded. And since the general commands a fighting machine composed of combatants and civil units, and the admiral a personnel a proportion of whom are either clerks or semi-laymen, so should a firefighter and his non-combatant ally serve under one flag, recognize one chief, and be brothers in a common cause. There is no good reason why this should not be accomplished, and that till now it has not been consummated has been due largely to the apathy of those in responsible control. Any general consideration of the problems connected with fire insurance is quite beyond the scope of this volume. At the same time, however, it may be of interest to quote certain comparative data, and in addition, the writer is happy to give prominence to the good work being accomplished by underwriters in the United States. It is a common failure in America generally to condemn certain social factors as being responsible for this, that, or the other occurrence. The acute observer will have noticed that under no circumstances is the individual unit ever responsible for the sequence of events. Come murder, rapine, pillage, or earthquake, it is always that inconsiderate somebody else, corporate or incorporate, who is to blame. Never under any circumstances has that wonderful individual unit been in error. And the same might appositely be said of the press. Clever writers with brilliant pens overflowing with ink between 11 o'clock at night and 2 in the morning will, with the utmost complaisance, label corporations or persons in a genial way as rogues, vagabonds, or villains, accepting always that their readers will take their remarks with that proverbial grain of salt which is necessary to a true appreciation of the journalistic cuisine. Unfortunately, the average reader is stolid, unsuspicious, and indiscriminating. He rarely sees beyond his nose. He never reads between the lines, and he is as a child in the complicated moves in the game of publicity and policy pursued by many, which remarks may be accepted for what they are worth. Few acquainted with public life will honestly controvert them, and for the rest, their opinion is of equal value too, though of far less weight than that of the writers mentioned. Thus it is that a compliment must be paid to the National Board of Fire Underwriters, which in the United States is doing a great deal toward the education of the general public in the matter of fire risks. The following excerpt, taken from the address of an officer of the Northern Assurance Company of London, is worthy of quotation. The phenomenal growth of this country, the United States, of which all its citizens are proud, has been accompanied by the creation of enormous commercial and manufacturing establishments, great concentration of property values, and congested areas in our large cities, each containing hundreds of millions of dollars of values subject to destruction by fire. This extraordinary commercial and manufacturing growth makes necessary a corresponding increase in credits. To meet this need for larger credits, the banks have been made larger, and are being made larger all the time. One of the most important and essential foundations of credit is fire insurance. This is now so well understood that it is unnecessary to dilate upon it. As the great growth in business requires a corresponding increase in credits, which in turn makes necessary larger banking facilities, so the concentration of values all over the country in individual businesses and in congested city centers makes it necessary that fire insurance companies should have large and increasing reserves and loss-paying abilities. Under a general system of state-made rates, fire insurance companies would undoubtedly find themselves unable to build up large reserves, and there would be no inducement to make them large by capitalization. The welfare of the country requires that fire insurance companies should have the opportunity to create large reserves, with which to meet large conflagration losses, such as have several times occurred and must be expected to occur again. Inability to meet such crises would cause serious and perhaps dangerous panics. The average underwriting profit made by all the companies has been paltry, as will hereafter appear, and furnishes no justification for state rating board laws on the ground of excessive profits. The smallness of the average underwriting profit shows that the dividends to stockholders have been paid from interest and dividends from investments, and also that reserves have been augmented from the same sources. It is therefore apparent that excessive rates have not been charged and the proceeds distributed to stockholders. The above may be an ex parte statement, but on the face of it, it contains a thorough realization of the condition of the fire risks in America. Time and again it is insisted by the underwriters that it is the conflagration hazard which renders any approach to systematic or scientific underwriting practically impossible. If, as in Vienna, it were feasible to confine every fire to the building in which it originated, which can obviously be accomplished when houses are constructed upon a detached system, then the problem would be simplified. If, as in Germany, a man having a fire on his premises is held guilty of misdemeanor until he proves that its inception was beyond his control, or if, as is operative in France, a man having a fire extending beyond his own premises were held financially responsible, then again the problem would be simplified. But probably the sanest and most hopeful method of combating the huge fire losses in the United States is by the gradual instruction of the masses to a proper realization of fire control and what it means. To this end, the National Board of Fire Underwriters has most distinctly added its quota of assistance
by the publication of useful brochures and by the issuance of bulletins apropos to certain occasions when fires most commonly occur, such as Christmas Day with its Christmas trees and candles, and Independence Day, July 4th, with its indiscriminate use of fireworks. No one, however partisan, can deny that this is useful work and of the greatest public benefit. Annually, the fire loss in the United States may be roughly assessed at $250 million, or £59,999,999 sterling. This is naturally only a broad estimate, for to be irritatingly accurate, the estimated loss for 1911 was $217 million, though in 1906 it was over $500 million, the latter figure, to be sure, due to the San Francisco disaster. But taking even $200 million as the annual wastage, it would be profoundly interesting to know how much of that colossal total was due to the carelessness of the individual. It is beyond the ken of man how to arrive at such figures, but the writer can testify from personal experience, and has emphasized again and again in the preceding pages, that the human element plays a preponderating part in providing work for the firefighter. There is always something fascinating in picturing in the mind's eye all the wonderful things which might be were such and such a factor eliminated from the social fabric. The pacifist who dreams of disarmament and international peace is wont to enlarge upon what the reduction of the Army and Navy estimates would mean to the masses. A Secretary of the Treasury or Chancellor of the Exchequer with $100 million unallocated to any particular purpose in these dreary days is as rare as the dodo. In fact, he is non-existent. But supposing such amazing bouleversement of conditions did occur, it is only possible to surmise how that money might be spent for the good of the community. It appears on the face of it so fantastic, so irrelevant to the issues of the moment, and so far removed from practical politics, and yet implant in the individual the fundamental features of the dangers of fire and of the easiness of those ordinary precautions which in themselves are simple to the verge of puerility, but in the aggregate count for so much. Then there might be a reasonable chance of the materialization of that seemingly far-fetched dream. Hence, all means to that end are to be encouraged, and the work being accomplished by the National Board of Underwriters is deserving of more than passing praise on that score. For that there is need of some guidance can be gleaned from the following figures, which, making every allowance for climatic extremes, a fruitful source of fires, and constructive encouragement to the flames in the shape of the employment of wood as a building material, still evidence a remarkable gulf between fire risks in Europe and the United States. Thus, whereas the per capita loss in the United States for the year 1911 was $2.62, for England it averaged only 53 cents, for France 81 cents, for Germany 21 cents, and for Russia only 8 cents. These figures are not absolutely conclusive, since they are based upon the reports sent in from centers of population, and no account can well be taken of the country in sparsely populated districts. But as regards the United States, it may be remarked that the 298 cities upon which that average is framed represent a population of 31 million people, among whom there is fire protection. In no foreign city does the per capita loss approach $5, £1, though, excluding conflagrations, 32 cities in the United States surpass that figure. The highest fire loss in England, curiously enough, was in the ancient city of York, which, with a population of only 82,000, shows a per capita loss of $2.73, 11 shillings, which compares unfavorably with the town of Yonkers, near New York, with the same population, and a per capita loss of $1.73. For London, the per capita loss was 54 cents, based upon a population of 7.25 million people, which evidently included its suburbs and not the county proper. The per capita loss in Paris was 60 cents, For Hamburg, only 18 cents. For St. Petersburg, 93 cents. For Moscow, $1.46, exemplifying excellently the rise in loss occasioned by extremes of climate and wooden buildings, while the city of Vancouver heads the list with $2.61. These are statistics which cannot fail to provide food for the thoughtful, for fire wastage is a literal translation of the phrase commonly used to emphasize the extravagance of the individual, burning money. Finding money for the provision of armaments which may never be used is often decried as hideous waste, though there is something tangible to show for the expenditure. What then can be said in defense of a loss to every man, woman, and child in the United States of over $2 per annum, with a visible result only of charred ruins and possible suffering? End of Section 25. Recording by Maria Kasper. Section 26 of Fires and Firefighters by John KENLON. This LibriVox recording is in the public domain. Chapter 25. Conclusion. It is the experience of most writers on themes peculiarly their own that when the time comes to surrender the pen, only then do they realize how much more should have been added to the material collected, how much more clearly certain details might have been explained, and how altogether inadequate is the sum total of their labors. And so it is as regards this work. The term firefighting possesses such an immense significance that it would require many portly tomes to deal exhaustively with all its intricate problems. For as fast as one offshoot receives attention, another crops up hydra-like, and it becomes a question of serious consideration what proportion of notice, if any, should be allotted to many subsidiary branches of the main theme. Thus it is only feasible, by using judgment, to scrape the surface of the vast field of investigation, and by as skillful handling as may be, to sow the seeds of fresh thought in the public mind, which in time may germinate and bring forth a rich harvest of action. This indeed has been the chief inspiration of this volume. Those interested scientifically will, it is hoped, have found the wherewithal to whet their appetite for further research, and there is no doubt that there are problems without number awaiting the probe of the investigator in the domain of fire control, problems which demand the maximum of mental efficiency, patience, and determination. But the larger portion of the reading public demand the note of human interest, and as far as lay within the scope of the material, this has been supplied, for it is a trite commonplace that to arouse enthusiasm or a proper realization of the true inwardness of any subject, appeal must be made to the senses, and it appears of paramount importance to the writer that the man in the street should be aroused from the lethargy he habitually displays over questions appertaining to fires and their prevention. Terrible lessons are taught, and as speedily forgotten, not because the individual is unable to grasp the significance of the occurrences, but rather because the teachers are intangible elemental forces which cause disaster and await the skill of the human instructor to amplify and explain their lessons. And it may be said that until recently such instructors were sadly lacking. In the first place, the search after wealth is so keen nowadays, and monopolizes attention to such an extent, that occupations promising only a moderate financial sufficiency are to a certain degree shunned by the enterprising and the ambitious, with the result that those enlisting in their ranks are often devoid of that enthusiasm, the magnetism of which is so overwhelming that it communicates itself to others and sweeps into its net the youth and strength of a nation. With such material, what can be expected? Any individual adopting a calling merely as a means to obtaining the bare wherewithal to exist rarely earns his wage. His duties are rendered just so efficiently as to escape censure and no more. Now, without any savor of supreme conceit, the writer hazards the statement that for a change toward better things, the fire departments in the United States are responsible. In the first place, the magnitude of the risks involved has impressed itself upon the thinking portion of the community, and it has at length been realized that if an army and navy are necessary adjuncts to the safety of the Republic, then most assuredly the organization of a first-class firefighting force is necessary for the safety of the homes of the people. And that is the chief factor in the situation. Financial losses may be huge, but they will not appeal to the heart of a community to the extent of the death of one child by the flames. To deal seriatim with the crucial points of each chapter in the foregoing pages is out of place in this conclusion, since if each in turn has not been sufficiently conclusive, then the carpenter in this instance cannot blame his tools but himself. However, it may have been noticed that on occasion comparisons, those most odious of things, have been instituted, while criticism has seldom been far distant when dealing with foreign departments. It almost seems superfluous to state that whatever has been penned has been actuated by no carping spirit, but rather to bring out some obscure point or to emphasize some necessary moral. If every fire department was organized on precisely similar lines, then assuredly the fire fiend would play more havoc than it habitually does, since in firefighting, as in other spheres of life, one man's meat is another's poison, and most assuredly what will suit the requirements of one locality will most hopelessly fail in another. Further, criticism is a life-giving sap to any industry or profession, or for that matter to any human enterprise. Devoid of this spur, achievement would quickly cease from sheer inanition, and inasmuch as trees from time to time need pruning for their better growth, he would be a sorry gardener who hesitated over the task, lest perchance he might injure some branch or offshoot. Hence the writer hopes that all his remarks will be accepted with the same good nature as that with which they are offered. For there is need today for cohesion and mutual support amongst those who have made and are making of firefighting their life's work. This applies to all countries without exception, though there may be some slight difference in usage and organization. It is a peculiar reflection on human character, and not altogether a pleasant one, that recognition of services rendered is too often overlooked, unless there is an accompaniment of glittering uniforms and the blare of many bands. Stand in the limelight, make use of every channel whereby publicity may be gained, and ipso facto the end may be attained. From mouth to mouth spreads this spurious fame. Municipalities recognize it, and governments decorate for it. Now, those in the firefighting profession, though discounting the hollow adulation of the ignorant, and assessing at its proper worth an evanescent popularity which is of no permanent value, may be forgiven if at moments they yearn for some sincere acknowledgment from those whose lives and property they day by day protect. Of course, it may be argued by some that they are paid for their services, which is all they should expect. But there are equally those who will query if their wages are equivalent to a daily risk of life and limb, unknown even to the professional fighter, the soldier, and the sailor. As a matter of history, probably every fireman in every fire brigade in the world is only too ready and too willing to go to any extremity in order to save a human life. Surely it is not pleading for too much, if then there may be some sympathetic recognition of the fact, without the aid of brass bands and cheap publicity. Of course, the press agent, that questionable offshoot of modern journalism, will accomplish wonders, and be it added that, though not blessed too liberally with this world's goods, there are those who regard their dignity as above such methods of currying renown. This is particularly written anent firefighters of every rank and nationality. They do their work, and if a grateful community is too busy or too engrossed with its own affairs to mind their deeds, their sacrifices, or their welfare, then they accept the situation, though they may be forgiven if at moments it does seem to them a little callous, a little unfair, and not altogether considerate. Reading an English newspaper the other day, the writer came across a story of simple heroism which he may be pardoned for reproducing with some detail. It is by no means an uncommon occurrence. It possesses no limelight effect, and the surroundings of the event by no possible stretch of the imagination could be described as exhilarating or of a nature to inspire desperate courage. Rather are all the facts the reverse of these, but the narrative exemplifies that silent heroism which is no monopoly of any fire department in any country, but is rather the heritage of precedent handed down from time immemorial, and which carries with it that glorious superscription, "For a greater thing can no man do than that he lay down his life for another." The excerpt is here given practically word for word. That heroism is by no means confined to the battlefield or to the wild corners of the world's surface was exemplified once again by what happened in London on Tuesday, when the gallantry and cheerful self-sacrifice of the men of the London Fire Brigade was displayed. 2 of them lost their lives in a splendid attempt to rescue a number of workmen overtaken in a rush of poisonous sewer gas under the road in Pembridge Street, Notting Hill. The men were employees of the Kensington Corporation. One of them was suffocated before he could be reached, and 4 of his comrades came within an ace of suffering that same terrible fate. They were all struck down unconscious before they could be hauled out. A dangerous and threatening leakage of gas was the cause of the trouble. The leakage was reported to the Kensington authorities sometime before noon, and the 5 sewer men were immediately dispatched to locate it. Dressed in their heavy uniform and armed with safety lamps, they descended the manhole in Pembridge Street to search for the source of the trouble, leaving, as is customary, a mate on sentry above ground. They had not been down long before one of the men reappeared at the top of the manhole, livid and gasping for breath. He was only able to gasp out that his mates were knocked over by the suffocating fumes before he collapsed on the pavement. A message was immediately sent to the fire brigade station, and a large crowd assembled as the firemen dashed up from Bayswater, Notting Hill, Kensington, Euston, and other stations. There were scenes of great excitement as the men, with their smoke helmets adjusted, disappeared one after the other into the manhole. Amid rousing cheers, 3 men were brought up, livid, gasping, and only just alive. It was known that one man, Perry, was still somewhere down there in that horrible atmosphere, and the most desperate efforts were made to get to him. Fireman after fireman went down, only to be dragged back exhausted after a futile effort to reach the entombed victim. They must have been pretty sure that by this time he was dead, but that made no difference. Dead or alive, it was their duty to get this man out, and they stuck to their task with splendid heroism. The fatal tunnel was very narrow, at no part higher than 3 feet 9 inches. Perry was a man of considerable bulk, and it was thought that he had become wedged. The poison down below was worse and far more penetrating than the smoke of an ordinary fire, but the firemen cheerfully took the risk. All the afternoon the gruesome search went on, and at 4:30 the anxious watchers at the top were signaled to haul up one of the firemen. He was dragged out nerveless and dreadfully pallid, and though he was treated on the spot by Dr. Kennedy, it was too late. Half an hour later another was hauled up the narrow iron ladder and laid gently on a tarpaulin. He was found to be past all human aid, and the lookers-on bared their heads as the body was placed on a motor engine and taken to the mortuary. Traffic was diverted for many hours, the work of rescue being followed with breathless interest by a silent, awestruck crowd. It might well be added that the names of these 2 self-sacrificing heroes were William McLaren and R. Bibby. Now, the object in having given these details in extenso is to emphasize, as well as the ability of the writer will allow, the daily risks of the firefighter, often, as in this case, devoid of that supreme excitement which prompts many a deed of derring-do upon the battlefields. and for those who accomplish the latter there are the thanks of a grateful country, or at least that is the official phraseology. At all events, there is recognition of sorts, not the least mark being the esteem in which those comprising the fighting forces are naturally held. There is nothing to be gained by further following this line of thought. It has ever been so, and unless some vast change sweeps over nations and peoples, it will ever remain so. The student in his closet, the chemist in his laboratory, the surgeon in his consulting room, and the engineer in his workshop, all may devise some great benefit for humanity. But if they expect earthly reward, they most assuredly are mistaken. They must look elsewhere for that, for they have no trumpet blowers, and the intelligence of the individual, as a rule, does not stray beyond the pages of his favorite paper, which formulates his ideas, prearranges his opinions, and supplies him with arguments along almost automatic lines. Hence it is as well that all connected with the firefighting profession should leave notoriety to others to whom it is as the breath of life, and who find solace in well-turned laudatory phrases, rather than in a quiet conviction that they have done their best. The student of history must sometimes wonder how men of the stamp of Lincoln, Washington, Benbow, Burke, Wellington, and of course that immortal hero Nelson, would have thought of the brass band, press agent, limelight form of publicity, which today is so often regarded as the hallmark of meritorious service. However, the mole, if it works unseen, accomplishes a deal of tunneling, as is eventually ascertained, and the fire corps of the world, though the sphere of their usefulness may not be readily appreciated, can afford to await developments. There is, however, springing up in many quarters a proper realization of what fire risks actually are, and to that end private organizations are being instituted for the scientific and careful study of the problems involved. This in itself is a healthy sign. While annual fire conventions, of which one is to be held in New York this year, do a great deal toward advancing the interests of the firefighter and arousing the attention of the public in his career. And in addition, since a rope is made of many strands, these conventions assist toward international friendship and a better comprehension of national characteristics. There is a talk of international arbitration in the air, reduction of armaments, and the submission of points of difference to referees. Hence, every action which tends toward amity between nations is to be commended. And what more natural than that the united enemies of a common foe, the allied forces of intelligent and scientific action against not a national but a universal peril, should meet from time to time to suggest and adopt the most comprehensive means of checking the same. And such united action of human fighters against an elemental antagonist will, it is devoutly to be hoped, tend toward the elimination of the national fighter, not because the latter is unnecessary to the life of a nation as at present constituted, but rather because peace is the greatest of blessings, and will bring in its train scientific development along the most useful and beneficial of lines to the common weal. To the youth of all nations the writer would make the following appeal. The career of the firefighter is one of the most enthralling that the mind of man can conceive, and in its present stage of development it promises a remarkable field for the enterprising and enthusiastic. It has been shown that the days when the fireman was merely an automaton using a pail of water and a hatchet, when discretion and intelligence were useless owing to the undeveloped state of the science, and when any unskilled laborer could accomplish all that was required, are gone forever. In its place is a calling which is emerging from its chrysalis of obscurity to take its proper position amongst the recognized and esteemed professions of the world. While, as has been pointed out in the preceding pages, it does not offer the financial returns or popular recognition attached to other occupations, it does promise a sufficiency. If followed with determination, positions of responsibility are within reach, and what the future holds for the fireman no one can foresee. More unlikely things have occurred in the evolution of society than the formation of a national force of firemen, paid and recruited by the government, and having in their charge the fire risks of the community as a whole, worthy successors to the soldier and the sailor, if that time ever arrives when the sword shall be laid aside for the plowshare. And who shall say that it will not? Which brings the writer to the end of his labors. The day is closing in, and the lights are beginning to twinkle across the harbor of New York, as though beckoning to the wanderer to lay aside the cares of the moment and find rest and safety within their embrace. And somehow there steals across the evening air a vague feeling of sadness, the consciousness that many hands generously extended in the past as tokens of friendship and guerdons for courage will never again be clasped, that the enemy, fire, has reaped a rich harvest, and that in dealing in pen and ink with the antagonist of a lifetime, in the words of that great empire builder Cecil Rhodes, there has been so much to do, so little done. But none the less, from the writer's eyrie overlooking the restless Hudson, bearing upon its broad bosom the commerce of the 7 seas, he holds out his hand, in greeting to the new recruit, in friendship to the active rank and file, and in congratulation to the veteran firefighters the world over, in all climes, in all cities, in all countries, the greatest brotherhood of the world for the common weal. End of section 26. Recording by Maria Kasper. End of Fires and Firefighters by John KENLON.